Hello everyone, this is Shubham Panchal and I will be your instructor for this course Mastering Arduino from Beginners to Career Advance. In this course we are going to learn about Arduino, so I have divided the course into 10 modules. As you can see here, it will be covering about 60 sections and it will has 10 modules and the 11th is for the conclusion. Okay, let's start with the beginning. In the introduction, first of all I will be introducing you to what is Arduino, how it was made, and next we will be going to what is microcontroller and what is the use of microcontroller in Arduino, and we are working on the chip name ATmega328. Then after we are going to install the software, and how does the software work was the part of the second section, as you can see here. And we will be performing a simple experiment. Say you can say hello world of the embedded system, or you can say a blinking of LED. After that we will going to the third part, and the third part is programming. In third part you can see that I will starting the programming basics from the core basics. We will be going to some advanced topics such as array, and afterward in the later videos you can get the more complicated subjects based on that. Okay, after that I will be telling you about physical computing and the basics of physical computings, and how the physical computing affects the whole Arduino and our whole physical world. We will be talking about input output, about analog digital. We will be running some experiments on multiple LEDs, button inputs, even LCD will be used to control. We are using LCD to run some program giving it a value such as hello world and or other experiments. After that we are going to talk about motors. I will be telling you about the motors and we will be performing experiments on them. We are basically talking about motors such as servo, stepper, BLDC and DC motors, and we will be doing experiments on each of them. Then after that we are going to into the section of sensor details. This is module number 6, and here you can see that the introduction to sensors and the type of sensors. And there are, you can say that basically two types of sensors. They are analog sensors and digital sensors. We have classified them into two sections, such as based on their working, such as active sensors or passive sensors, and based on their signal type such as analog or digital. And after that we are working on the four sensors named potentiometer. Potentiometer is an electronic device, but we are going to use it as a sensor so that I can explain you the basic of analog function. After that we are going to use the piezoelectric sensor and the temperature sensor and passive infrared sensor. Don't worry about the name, I will be telling you everything about it in the video. After going that we are going to the serial communication. Well, serial communication is an important part of Arduino because it is used to communicate between microcontroller and the computer. So we are going to get through the basics, then about serial writing, reading and a lot of stuff. After that I will be telling you about the integrated development environment, or the IDEs. The IDEs we are going to talk is ATmel Studios and wiring and even Arduino, and there is an option of Arduino which is working online. After that in the advanced section we will be talking about I2C communication and wiring, RF remote control, interrupts, hardware debouncing and other stuff such as watchdog timer and RFID card reading. After that we are going to a real-time project. In real-time project you can see that the project is an automation based project. So we are going to use a system that we have collaborated. We have installed all the systems in it, such as a heavy motor run about 24 watt, 12 volt and about 2 ampere. We are going to run it with the help of Arduino and a relay control program and a relay module that have some special connections on it. And after that we are going to learn about the multiple sensors that we are using it and running all of them simultaneously to achieve a program and to achieve the code and to get it done in the real time, so that we can install the program and we can make some stuff out of it. And in the end we will be having a conclusion. In conclusion we will be talking about what we have learned and what is going on in this whole subject and what is the future of Arduino, or you can say embedded electronics in the field of Internet of Things. If this was the introduction of the course, if you all the 10 modules have some codes in it, so I have made, you can get the PPT or a PDF at the starting of the course. You can download it in the list of codes that are used in that course, and Other than that, there is an option of I have made a GitHub library named as Mastering Arduino from Beginners to Core Advanced. In the first module directory, here you can see that you can go to basics, go to codes, and you can get the GitHub link for that. This is the GitHub link for the course. You can just copy paste into a browser and start getting codes and do your own practicals. This was the basic of the course. If you have any doubts, you can ask me, or else thanks for watching. Hello everyone, before going to the next module, I want to tell you what is an Arduino and how it looks like. Well, here you can see that this is an Arduino, and here the black thing on this is called the microcontroller, and here is the GPIO pins, which can be worked as both as input and output. This is the restart button. This is the power socket for the Arduino, in which you can plug the device and work it on a standby adapter so that it can work continuously standalone on its own. This is the USB port. It has a special type of USB cable that is connected in this port, which can get connected to the computer, and about the software I will be telling you afterwards. Okay, thank you. Microcontroller. About the microcontroller, first of all we need to understand the difference between a microcontroller and a microprocessor. Well, if we say the microprocessor as the brain of a computer, then you can say that the microcontroller works as a brain as well as a muscle for the computer. In other words, microcontroller is a system on a chip. It means that on the chip it has its own RAM, that is 4 kilobyte, it has its own hard disk, that of 32 kilobyte, and it had its own processor, that is of 8 megahertz. Well, these systems and specification sounds very low, but they can run almost all of the required programs in this much, only this small amount of memory. Well, about microcontroller and its architecture. In 3 to 8 we have 28 pins. You can see here this is the physical number of the pins, and in the pink one you can see that the number that is assigned in Arduino. You can say that pin number 4 in the physical pin is pin number 2 in Arduino, and in the whole section we are going to deal with the Arduino, the pin numbers on the Arduino. Okay, now you can see here that a microcontroller is 8-bit. Well, what is 8-bit? Well, 8-bit can be said as the memory structure or the architecture of the chip. There are different type of microcontroller which has 8-bit, 16-bit, 32-bit, and even 64-bit of architecture. But here we are going to deal with the 8-bit. Okay, thank you. Well, after that we are going to talk about the next chapter, that is the Atmega 328 details. Well, we have talked about earlier that Atmega 328 is the black color chip on the board. This is known as Atmega 328 PPU. PPU because it runs on 5 volt and it is power saving chip. Okay, the frequency, well, it has a built-in clock that runs on 8 megahertz, but by adding a crystal on it, you can see that here this is the crystal, and after adding a crystal on it we can make it run on 16 megahertz, and all the Arduino boards with Atmega 328 work on 16 megahertz processing speed. And the next part is flash memory, or you can say it simply the hard disk of the microcontroller. It is of 32 kilobyte, and I mean by saying 32 kilobyte, it means that it cannot store photo or other data, but it is just for storing the program that is written on the chip. The program is written on the chip in the form of hexadecimal, but we have to program it in the Arduino IDE with C++ language. Well, Arduino is a special form of C++ language that is very easy to use, and it can be used for non-professionals also. About the pins, it has 28 physical pins. Well, you can count here, it has 28, more than 28 pins, because the ground port has been given 2 times, and also 3.3 power adapter is also added on the board, and 3 pins for input output reference. Okay, about the next points, digital pins. Well, on board you can see that it has straight 30 digital pins. Well, I want to tell you that first of all, consider that pin 0 and pin 1 as node should be used for the processing, because if we are doing a serial connection and then if we are using pin 0 and pin 1, then there will be an error in the serial communication. So we have to prefer that we we don't prefer pin 0 and pin 1 for our programming and other purposes. It has 5 analog pins such as A0, A1, A2 till A5. Well, all the analog pins can also be used as GPIO digital pins, but note that point that pin A0 should be written as digital pin 14 and A1 as digital pin 15 and so on. Okay, next. Thank you. Have a nice day. Hello everyone, in this video we are going to connect the Arduino to the IDE. For that you have to connect the Arduino Uno into any of the specific USB port that are defined in your computer. Okay, after clicking that, open the Arduino IDE. You can see that the icon on your desktop as Arduino, it's going to open, and then click on tools. After clicking on tools, you can get the ports as detail, and this port you can see that it is written COM port 7, that is Arduino Uno or Arduino Genuino. Click on that. After clicking on that, you have to set the board. For it, as it is selected default as Arduino Uno, but if any other type of board is selected like this, you have to click on here back on the board and you have to select Arduino Uno or Arduino Genuino. You have to check where you have to know what is the icons and how they are deferred or how they are put on the screen. This is for the new tab, rename or deleting of the files, and this one you can see that this icon is for serial monitor. I will be telling you about serial monitor afterwards. All the other options are on the top that are about the sketching, formatting, their tool selecting, and using Arduino as a bootloader. And in here sketch, you can see that you can import sketch, you can add libraries to it, and you can even compile the sketches. Okay, now going back to the PPT, we can see here about the structure of the Arduino. This is the icon that is for Arduino. This is the place where a green bar will appear if you are going to install or upload the program onto the board. This bar will show the percentage of program that has been installed in the board. This is the button that is required when the program is written in the Arduino IDE. After putting, we have to install or download the program to the Arduino board. For that, select the settings as I have shown you earlier, such as selecting COM port 6, getting it confirmed as Arduino Genuino, and click on that icon. After that, the program will install automatically onto the board. Okay, let's try one program. You can say it example as Arduino Blink, or you can say it as the embedded hello world. First of all, go to file, click on example, go to the basics and click on Blink. A new window will appear that has the program known as Blink. You can see here the LED pin, LED built-in. First of all, it is LED pin 13. You have to know that LED built-in is set to the pin that is named as LED pin, digital pin 13. You can test it by writing LED pin 13. LED pin 13 and LED pin 13. Okay, after going to that, go to the tools, select Arduino COM port 7. This is right. We have selected Arduino Uno Genuino. Okay, that is also right. First of all, we have to compile the sketch. Click here, the sketch is being compiled. You can see the green bar here, which is showing the status of the compilation. If any error occurs, this green bar and this whole blue strip is going to turn into orange. We will do that within a second. Okay, write a word here. Anything you can write. I have written the word H, and now we are going to compile it. It will show an error that it is not in the format as described. So we delete H. Now again compile it. We can see the compilation is done without an error. So next, go to the upload button. Here the button with an arrow icon. Click on that. The bar will appear and there will be lighting on the board. After that, you can see that the program is been uploaded on the board, and there is a blinking is done on the pin 13 and an LED that is connected to pin 13 on the board. I will show you in just a second. Okay everyone, this is the next module, Arduino software for the first timers. In this module, we are going to discuss about Arduino and what is breadboard. Let's get started with programming, download and install of the software, and about the integrated development environment, and writing our first program, that is blinking an LED, or you can say it hello world. Before going that, I want you to go to the Google and search for Arduino. After searching Arduino, you can click on Arduino button, Arduino home, and after going that, just click on the softwares. After clicking on software, you have to select your type of installation. It could be a Windows, it could be a Mac, or it could be a Linux. For me, I have selected Windows installer. After clicking on that, you will get the next page that is telling about contribute to download or just download. For our case, right now we are going to just download. After clicking it, the download of the Arduino software will begin. Well, I have downloaded it earlier, so you can just see here how the installation of the Arduino software begins. Okay, this is Arduino 1.8.4, that is for Windows. So it is an executable file. Just click on it and it will start to ask the security question. Just click yes on it, click on I agree, click on next, click on the location. It will ask for the location where the Arduino should be installed. For me, it's C program file 86 and the folder named Arduino. After clicking it, it will just begin to install. If you wanna see how the things and how the libraries or files are going to install, just click on details. You can see here. Well, within a minute, it will get installed. Well, I have just I have just fast forwarded the video to the last part of the installation process. I want to show you that you have to click on some buttons for installation. It will ask for the driver that should be installed in the Arduino, so just see it. On closing it, okay, now on the desktop you can see that there is an icon which is named Arduino. Okay, just see there. If you don't find the icon, just don't worry, go to C, go to program file 86, click on Arduino, and there you can find the icon, that is Arduino exe. Just create a shortcut of it on the desktop and you can begin. Okay, click on Arduino. It will ask for the access for the Java file. Click on yes, and now you can see the Arduino. This is the integrated development environment for Arduino. Here you can see that it has all the features that are needed for us. For port, if you connect the Arduino board to it, you can find here the port and all the buttons that are necessary. Okay, just we are going to move to the next slide. Thank you. Okay everyone, let's begin the module. And in module 2, first let us see the contents. Arduino with breadboard. Let's get started with programming, download and install the software. Well, we have done that previously. About the environment and how to blink an LED, or you can say the hello world of embedded systems. Okay, first of all, let's get to the programming. Okay, let's get started with programming. Programming an Arduino board which is written in C++. You can see here it is written in C++. Okay, it is a very simple structure of C++ that I have only 3 parts of it. You can see that here. First of all, you have to declare your pin here, and then you can set input or output. After that, if you want to run the code for one time, put all your code in void setup. This is the part where you have to declare your pin and set it as input or output. And if you want to run your code multiple times, you have to put it in the void loop. Okay, the structure is very simple. First of all, declare the pin, set it at input or output, then put it in the void loop for infinite time of running, or for void in setup if you want to run it into one time. Okay, then we are going to talk about what is IDE, or you can say integrated development environment. You have installed the Arduino as I have told you. Now we are going to know about the Arduino IDE. Here in the IDE you can see there are 5 blue colored buttons. They are as follows. First one is for compile, second one is to download the program which is written in the IDE to the board, third one is to start the new file, For writing the sketch, all the programs that are written in the Arduino are called sketch. Then after open, if you have done anything previously and you want to open that sketch, you can open that and save the sketch. From here we are going to call all the programs that are written in the Arduino IDE as the sketches. Okay, now you can study here that it is a very simple IDE. As you know, it is very simple IDE because it runs on a specially designed C++ language firmware. The first of all, to connect to the Arduino, you have to connect it to the port. Okay, I will tell you about that afterwards. Okay, thank you. Okay, let's just get to the theory part of how does the blink sketch work. Look here, by giving the test program to the file we have select. After giving for blink, we have to go here in the file, select example, select blink, and the blink sketch opens. Now we have done the practical part of it. Okay, now we have to get to the next module, that is programming from beginner to advanced. Okay, I will meet you in the next module, and thanks for watching. Okay, hello everyone. We have come to the module 3, that is programming from beginners to advanced. In this course, we are going to learn about Arduino syntax, introduction to variables, digital read, and serial port. Well, serial port is a very important part of Arduino and we are going to study about it in this lecture. What is analog read, and even we have to say that what is analog. Introduction to pulse width modulation, or you can say it PWM, and we will be doing a practical of how to fade a LED. The fading of an LED can be justified as similar to the dimmers. In dimmers, you can say that when the dimmers are pressed, the glow of the bulb becomes faint and it will continue to go down. After that, we will be getting into programming with conditional statements. That are the very important part of programming. We will discussing about continuous if and if else statement. After that, we will be going to for loop, and for loop there is also one part in the chapter, that is while loop. I have included it in the section so that we can get a better understanding of what is the difference between a for loop and while loop. In the last part of it is using an array. About array we will be talking about that on getting to the topic. Okay, let's start. Syntax. Well, syntax, you can say that the syntax in a programming language is similar to grammar in English or any another language. So syntax is the method by which the program should be assembled properly so that the compiler of the computer can read it. You can say compiler is a machine that is used to understand and check the program if it is written in the syntax, and then convert the C language, the language that is simple to understand by us, to a hexadecimal language. And hexadecimal language is consists of only two parts, that is 1010. Then after it can be written into each line can be written in a hexadecimal code that contains a base of 16 into 1 2 3 4 5 6 7 8 9 and 0, then A B C D E F. This is the maximum strength of the hexadecimal value that is being written in the next line. Okay, about understanding syntax, the Arduino is written in C++ language, so we don't need to have a basic knowledge for this course because we are doing it in practical and we are getting a better understanding of the language. If you have a prior knowledge to that, you can do it and it will be better for us. If you have a prior knowledge to it, it will be good for you because you will be better in programming and all other stuff. Okay, declaring variables and declaring pins. Well, I have told you that a variable can be stated as an object or an instrument in which the values are put. For example, you can say that the x is equal to 5. It means the variable of x store the value of 5. You can change in within milliseconds. You can say the value of x can be changed as 6, 7, 8 or whatever you like. This is known as a variable. Well, what about pin? I have told you in the Arduino that there are about 28 pins, out of which there are 30 digital and 5 analog pins that can be converted into digital. So we have about 18 pins that are digital and that can be working on the Arduino. So we have to declare the pin with a variable. an important part is that a variable can also store the value of a pin. Like if you had set a variable as is equal, I will be showing you an example that will be better. For example, if you have written the variable x is equal to 13 and you put all the places over x where the 13 has been written, you can see that the program will be still working, because when the system goes to x, it will be checking that digital pin, the value of x is 13, so it will understand that x is equal to pin number 13, and when we put x in the place of pin number as a variable, it will also understand. So let us check it. First of all, we have to compile it. There is an error. You can see that error because we had not terminated. There is an error in the line because we have not terminated the line. So let's terminate it with a semicolon. Now please check it as compilation. You can say that the value of x is not declared. Yeah, this is done by me to tell you that you cannot declare a variable directly without giving it a function, without defining a function int, because it is not Python. We have to declare every variable with a function int, or it can be float, it can be long, or it can be character. I will be telling you about that in the next sections, but here we have to put it a value int. Okay, when we had put the value int, you can see that the color has changed to blue. It means that it is a valid syntax. Okay, now check it. There are no compiling errors. It means that the value of x is stored as a variable as value 13, and it has been stored at every point. Okay, let's just upload it to the board. First of all, check the connections. Board COM port 7, board Arduino Uno. Now doing that upload, you can see that it's going and done uploading. Now you can see that the board, it's blinking. It means that the method is correct. Okay, now let's get to the next part. After that, you can see that the next part is running one program at a time, while the difference we have to know that the difference between running a program at one time and running it in a continuous loop. You can see that the blinking of LED is still continuous. It means that it is running in a loop. But what would happen if we run it is one time? Let's just check it. We have to put it into the void setup. Okay, just a second, let me do it. Come here, make a cut of all the programs, Control X, and write it here, Control V. You can see that after defining the pin, a program has been written with the same syntax. Let us compile it. Okay, after compiling it, we can see that the program is written. I am taking the microcontroller here so that you can check that it has been run for one time or not. I had clicked it, the program has been running, and you can see that it will blink for only one time. This is the method for running program at one time. This is called void setup. And if you want to run the program for infinite long, you have to put it in void loop. Well, you can keep the void loop empty, but it is not possible to keep void setup empty, because the declaration of pin and the calling of the serial monitor and all the functions that are done here are placed in void setup. Okay, now let's get to the next part of it. Here you can see that running a program for multiple times or for running it in long time. Okay, let's get back to the programmer, our IDE. We can see that in our IDE, just go here, select the syntax program and cut here. You can go to void loop, write it between the two curly brackets, because if we do not write it between the curly bracket, it will say that it's an error. Okay, again check it. Integer is declared. Integer, our variable has been declared. The void setup has been fulfilled with the condition pin mode x is equal to 13, that is output. Okay, now let's get down to the void loop. You can see that in void loop, digital write x is equal to high for 100 millisecond, x is equal to low for next 100 millisecond, and it is written in loop, so it will run infinite long time, for infinite long time. Okay, let's check it. And the upload of the program is done, and you can see that it is running for infinitely long time. Okay, let's get back to another section. Okay, after that we will come to see what is a function. If we run a program for one time, it is okay, but if we are going to call the values for multiple times, we need a function in which the program is written for one time, and whenever we want to call it for multiple times, we will call the function. I just give you a simple example. Just look here. Okay, here cut all the program with Control X. Okay, after void setup, before void loop, we write void void glow, glow. You can see that void glow has been written. Give it two curly brackets. After that, give it two brackets. After that, give it two curly brackets. Okay, in between them, paste the program, and in the void loop, call the function glow. Give them brackets and terminate it with a semicolon. You can see that the function has been called here, and its value has been written here. Now let's just check it. We had checked it, there is no compilation error, and we have uploaded it to the board, and it's successfully uploaded, and you can see that the blink has been still going on. Okay, the method for function is correct. I will be explaining you more about functions in the later chapters. It is just for the introduction of functions. Okay, thank you, have a nice day. Hello everyone, today in this lecture we are going to understand the basics of programming, or I mean to say the syntax that is used in Arduino programming. Okay, let's begin the lecture. It is in module 3 and we are going to start it. Okay, let's see it. About the syntax. The syntax, as I have told you earlier, that the syntax of the programming is similar to the grammar in English. Okay, let's just see the key points of it. First of all, here we can see a semicolon. The semicolon in the programming is defined as a terminating statement. For example, if we select an integer and define the value to a variable, let's just say we have defined a value integer x is equal to 13, but if we try to compile it, after compiling it, you can see that there is an error. The error is simple. It need a comma or a semicolon after the statement so that it can terminate it. Okay, let's just put a semicolon after it. Now see that it's perfect. But something that is to remember, that always after calling a function there should be no semicolon. If you put a semicolon after a function declared, it will be said that it is not possible, or it will give an error. Okay, now another next thing is that if we call something a statement such as if statement, for example, say if, let's just say if x is greater than 5. Remember something, that after calling a statement there should be no semicolon. The statement will be terminated with the help of two curly braces. There should be no semicolon that should be placed in it. And another important thing, that the semicolon inside another important function is that in the curly braces there should be a simple semicolon is placed, or else it will give us an error. First of all, let us see the correct version of it. It is giving us an error. The error is in void loop d was not declared. Okay, let's just clear it. Give us 5. Okay, let's just compile it, and it compiles perfectly. Just delete the semicolon after that, it will give us an error. Okay, it is not. You can say that you can make empty statements out of that. It is not necessary to put a semicolon, but it is for a better practice that after the statement is given such as x is equal to 3, you should terminate it with a semicolon. Let's just check it. Well, the semicolon is in place. The termination of the statement with a semicolon makes it compilable for the compiler, and it can be converted in the hexadecimal values that are fed into the microcontroller board. Okay, let's just see the another part of it. After that, we can see that there are two backslashes. What are they? Let's just see here. Backslashes in Arduino are used to comment a line. For comment, I want to tell you that if I make something like x is equal to 5, no problem, x is given is equal to a value of 4. Just do it a correction. Let me do a correction. I am going to the first line. See here, you can see that integer x is equal to 13. But if you want to tell some another programmer, or if you want to tell the future of yourself that what is here written, then you can write a simple line in English without making it go inside the compiler. Give 2 semicolons after that. No, give two backslashes after that, and write something that this is x that is equal to 13. The line will not go into compiler. Let's just check it. The line is perfect. But what happened if you want to compile a multiple number of lines? Here you can see that there are a multiple number of lines are compiled. So let's just practice it. This is done with the function backslash and an asterisk for the beginning, and something important that should be remembered, that a backslash, then for termination it should be done by a backslash. It's for the termination of the line, it should be done with the help of an asterisk and a backslash. Simple syntax: backslash and asterisk for starting, asterisk and backslash for termination. Write something. Hello world. You can see that here are multiple lines. You can see that here are multiple lines are written between 2 backslashes. You can write anything, but that will not go into compiler. It will not affect the program at any time, but it will create a better understanding of the program for the future you, or for another programmer who has seen that. You can write something: hello world, this is a blink programmer, and you can now just install it into the board. You can see that it's installing. Now check it. Now you can see the microcontroller. It's not working because we have given the statement at 1 and we have to clear it. Okay, go there and define the function GLOW as we have done earlier. Define, and always remember to terminate the function after a semicolon. Now install the program, and here you can see that it's completed, and you can see that the light is blinking. Is it clear to you? Okay. Hello everyone, welcome to another tutorial of mastering Arduino from beginners to core advanced. In this tutorial we are getting to learn about what is digital read and how we can view the value of the digital pin at the serial port. Okay, about the digital signal, as I have told you earlier, that digital signal can possess only two states, that are 0 and 1. It is been shown in a square wave such as like this. Here you can see that it is 0, it is 1, it is 0 again. This can be shown as a square wave, so it can possess only 2 values. Okay, now about the digital signal. For that we have to set the pin of the Arduino as input so that it can read it, so can it that read the voltage, and again we have to open the serial monitors. We have to initialize it so that we can see the state of the light. Okay, let's just go to Arduino. Okay, let's just go to Arduino, open the Arduino panel. Okay, go to example, select basics and select digital read serial. Okay, in this program it is written that first of all the value that the pin that we have to read it is set as pin number 2. So go to pin number 2 and connect a wire on it. Okay, in the serial void setup you can see that first of all they have initialized the serial monitor by setting the baud rate to 9600. Okay, and they have the pin mode or the push button. You can avoid writing push button, just write the pin number such as pin number 2 and set it at input so that it will read it. Okay, now go to void loop. It has said that void button state will be digital read push button. Remove the push button and write it value 2 for your better understanding and a clear knowledge of the thing. In the void loop, the program In the void loop, the program is saying that the button state variable will check the state of the digital pin 2. Whenever the state of the digital pin 2 will be changed from 0 to 1 or vice versa, it will give a value to button state, and the button state will be printing it. In the next line you can see that it will be checking the microcontroller in every 1 millisecond. Okay, first of all upload the code to the microcontroller. We are uploading it. It will take some second to compile it and then convert it into hexadecimal and download it to the board. Now it is converted. Open the serial monitor. Okay, now we can see a garbage value or a value that is changing from 0 to 1. Don't mind that, it is only a garbage that is generated by the microcontroller. Okay, here you can see 3 wires. First of all, the wire that is connected to the digital pin 2. Second, a red wire connected to 5 volt and a black wire connected to ground. Whenever you connect the digital pin to the black wire, it will show a fixed value of 0. Okay, this is saying that the digital value have a low value or it is connected to the ground. Whenever you connect it to the 5 volt, it will show a value of 1. Again, let me show you the pin that is connected to the digital pin 2. Okay, connected to ground, it will show a fixed value of 0. You can see that the garbage, after garbage you can click it, you can again see that it has a fixed value of non-changing because it is set to ground or it is set to low. Okay, another time let us connect it to the 5 volt and you can see it has a fixed value of 1. Removing it will be causing a garbage. We don't want the garbage, but whenever we connect it, it will show a fixed value of 1. Well, this is the program for the digital pin and this is for the digital read in the serial monitor. Okay, thanks for watching this. Have a nice day. Okay guys, welcome back to another lecture of mastering Arduino from beginners to core advanced. Okay, in this module we are going to understand that what is PWM or pulse width modulation. Well, first of all we have learned about analog signals and digital signals. But do you know how a digital signal is converted into an analog signal? This is the process by which is done by the microcontroller known as the PWM or pulse width modulation. Let's just see it. Example, let us say this is a graph from 0 to 5 volt and it is running in a duty cycle of 0 to 10 second. Okay, now in the PWM method, in the normal method, getting a digital signal from low to high, it will generate a straight line, while in the PWM the portion is divided into the forms of equal interval equal time intervals. These are known as the duty cycles. For example, from here to here you have 2 duty cycles. Okay, for that if you have set it from here to here, it is 100% duty cycle. But if you had set the value from you can see that there is a edit. Okay, you can see that here is the 2 duty cycles that we are discussing it. For if the line is going, okay, let me correct it. Edit. Okay, here you can see that a voltage difference from 0 to 5 volt. This is for the digital signal, but for converting into analog signal we are using the pulse width modulation method. Okay, see here it is divided into 2 duty cycles as A and B. Okay, here you can see that the duty cycle, if it says that 0 to first interval, that is you can say that 5 millisecond or 10 millisecond for a better understanding. From here to here it is 10 millisecond, from here to here. Okay, if the voltage goes straight from here to here complete, it is set as 100% duty cycle. It means that for an interval of 0 to 10 millisecond the voltage is 100%. It means that the PWM will give a final output of 1023. But if we want to change the PWM, if it has given the value of around only 50%, or you can say that it was high for only 5 millisecond and low for next 5 millisecond, you can say that the duty cycle is 50%. So it will give a value that is equal to 1023 divided by divide by 2, or you can see that it gives an analog value of 511.5 or 512 analog values. But if the duty cycle decreases further, you can say that it just goes for next only, it goes on if the duty cycle goes on for only 2 millisecond out of 10 millisecond, and the series generated for the next duty cycle same as you can see that it goes here 2, and for the next duty cycle it just goes back to 2. So you can say that for a time period of 0 to 10 millisecond, only 1/5 of the portion is high and the rest of 4/5 of the portion is low, so that the duty cycle here generated will be 1023 divided by 5. It is something about 200, so it will give an analog value of 200. But why we are talking about the duty cycle in the PWM? Because this is the most important method for converting an analog signal to digital as well as a digital signal to analog by reading its duty cycle, for how much minutes it's high and for how much minutes it's low for a given interval of time. We will be doing some basics experiments like fading an LED here with the help of PWM. Fading an LED is similar to the dimmers here. Okay, we will be doing in the next chapter. Okay, thanks for watching and have a nice day. Hello everyone, welcome to another tutorial of mastering Arduino from beginner to core advanced. In module 3 we are here at fade and LED. Well, first of all we have to get back to remember the previous lesson that was about pulse width modulation or PWM. As I have told you earlier that the PWM is the method of changing the duty cycle by which the voltage can be applied to a certain portion in a duty cycle, which will give low voltage, or you can say that the analog values. Okay, let's just try it with an example. First of all, open Arduino, go to file, select examples, select basics and select fade. Now for the fade, first of all we have to get back to the circuit diagram. You can see that in this circuit diagram that I have built here, you need only 2 wires. First, a wire that is connected to pin number 9, and that should be connected to the longer terminal of the LED, that is positive terminal, and the second wire that is needed is the ground wire that is connected to the ground of the Arduino. You can see that here the wire has been connected, one for digital pin 9 and second for the ground. Okay, let's just check the code. Now here you can see that in the code we need to open the code. Okay, let's just go to it. The code name is fade, and in fade you can see that the LED is connected to pin number 9 first of all. Second, there is an integer brightness, that is the value where the LED should, the value of the fade, or you can say that the PWM pulse duty change should be stored. And third is the fade amount. It is the integer that is going to add up simultaneously to increase the value of the pulse width modulation duty cycle. And the same, after reaching the highest position, will be decreasing in the same cycle. LED pin 9 is output. Okay, you can see that analog write LED pin 9 brightness. Now what is the value of the brightness? Brightness is going to the last value of brightness to the value of the fade amount. It means you can say that the last value of brightness to the value of fade amount, that is 5, it will increase in a series of 5. Okay, if the brightness is greater than 255, that is the maximum possible value for digital, you can see that analog write. If it increases, then the fade amount will be turned from 5 to -5 and it will gradually decrease, and hold the function, and the whole function will be happen in a and the whole function that will be processed in a delay of 30 milliseconds. Okay, let's just upload it to the board. It's uploading, you can see here. It's just taking some time for compiling and another issues. Okay, you can see that the light has been glowing from 0 to 255 with an increase of 5 values to the in a time interval of 30 milliseconds. If we want to change the interval, we can do it here. We can change the interval from 10. You will see that the fade will be going about 3 times faster than the last values. You can see that the value of fade is changing 3 times faster than the previous values, so it is going so fast. But what about if you want to see the value of fade on the screen? Okay, it is very simple. Go to the void setup and write SERIAL serial dot begin, serial dot begin, in the bracket write 9600, that is the value of the baud rate that is going, the board will be catching and sending it to the computer. If both the baud rates are same, it means that it can process or it can display the data. Okay, go into void loop. After delay second, write a simple line serial serial dot println for writing the printing in the next line, and write the value brightness brightness. It is written brightness here because the value of the integer of the fade amount change or the duty cycle is stored in the variable brightness. Okay, just upload it to the board. It's taking some time. Okay, it has been uploaded, and now open the serial monitor, and you can see the changes of the value that is going on. The values are changing as per the duty cycle, and its value is going up and down from 0 to 255. That is the maximum value to write in the 8-bit ADC, and it is done by the method of pulse width modulation, or you can say that the changing the value or chopping the duty cycle. Okay, thank you and have a nice day. Hello everyone, welcome to another tutorial of mastering Arduino from beginners to core advanced. In this tutorial we are going to talk about one of the most important things in programming, that is the conditional statements. About the conditional statement, it can be a simple if statement. First of all, it will check the condition. The condition is a Boolean expression. It means that the condition that is been declared into the two bracket, if the condition is satisfied, then only it will go to the statement. If the conditions are not satisfied, it will not enter the loop, or in other cases it will go to the else loop. Okay, here let's just see first of all, let's just study about it. Okay, a conditional statement in a programming is used to define a condition where the condition is a Boolean expression. It can only be activated when the condition that is declared and condition that occurs are matched. If the conditions are different, then it will not occur, and it will go out of the loop, and maximum time it will stay in the else loop. And if a statement can be stand alone, it means that it does not need an else statement, while the if statement with an else statement can be possible, but an individual else statement is not possible because it needs an if statement with it to run. Okay, but the most important thing about the conditions is that its possibility to become hierarchy. You can say that in this case, first of all, the first condition is satisfied, then that it will go to the second condition. If the second condition is satisfied, then it will run the statement, and if in the statement the third condition is written, then it will go to the third condition. And this thing you can see that it will go to the most inside condition that is placed in the hierarchy. But if the first condition is at the very point is not satisfied, the program will jump directly to the else statement. While the conditions can be placed independent of each other without any hierarchy, you can say that if 5 occurs, it will go condition 1, if 6 occurs, it will go condition 2, and if anything other than 5 or 6 occurs, then it will go to the else condition. Okay, now let's just see a simple example of what is conditions and how they are done. Okay, go to Arduino, make a new document. First of all, we are going to write about our LED pin that is been connected to pin number 9. Okay, first of all, edit this, write pin mode and declare the pin 9 as output. Pin 9 has been declared as output. Okay, but we want to see the conditions occur. For a better vision of the condition, we are declaring serial also. We have declared serial and giving it a baud rate of 9600. Okay, that's done. Now go to the loop, our void loop. Okay, in void loop, first of all, for a condition we need some integer. We will declare it int integer x. Okay, now go to the conditions. You can make a simple statement of the conditions such as if x is equal to 2, then this is the condition and that has been declared. Go to 2 curly brackets and write something such as say digital digital write digital write pin number 9 as high. Okay, in the program, first of all, we have declared pin number 9 as an output. We have called the serial monitor. After that, we are taking an integer and giving a condition in the if statement such that if the integer x is equal to 2, then only it will go to the statement that is saying that write digital 9 is equal to high, and you can say that it will be for delay, it will run for about 2 seconds. Okay, but if the loop is not executed, it will go back and it will be running continuously. Okay, let's just check it. We are going it a value of 1. Okay, upload it. It's first compiling the sketch and it's going to upload within a few seconds. It's uploaded. You can see that if x is equal to 1, well, that was a syntax mistake. I have to give it 2 equal to. Okay, now let's just see it. We have done a small mistakes and I will be explaining about that. Okay, first of all, if you want to say if equal to, then you have to always give to a value of 2 equal to signs. If you have given it a 1 equal to sign, that it is saying that x is stored a value of the given on the right side, it means that x is storing the value of 2. But if we are giving a 2 equal to sign, it is saying that x is comparing its value to the right side integer that has been given. Okay, LED is not blinking at any function. Now you just give the integer value 2. Now just run it. Compiling and done. You can see that the LED will glow. Okay, but if you want to see the state, how can we give a clear declaration without giving it a state? Go here in the condition and write serial dot write conditions. Okay, serial dot println. ln is important to write it to the next line after first line has been written. We are giving x. Okay, let's just again compile it and upload it to the board. We have uploaded it and let's just see in serial monitor the value of x is equal to 2. Okay, now about the else statement, you can say simply write ELSE without any braces or anything, go down, write two curly brackets, and indeed you can write digital write digital write 9 is equal to, let's just go there and do an experiment. We are giving it high this time. This will be high, and if the value of x will be equal to 2, then this will be LOW low, and we are going to change the value of x is equal to 3. Now in this program we can see that we have declared the value of x is equal to 3. If the x value is equal to 2, then it will enter the loop that the pin 9 should be low, but that is not possible here because we have set the value of x is equal to 3. So it will go directly jump to the else statement, which is saying that the light will be high or it will be glowing. Okay, let's just compile and upload it. We are uploading it. It will take a second. Now you can see that the LED is glowing, and if you want to see the value of x, you can go to serial monitor and check here. The value of x is equal to, okay, there is a mistake that I have declared the value inside the if statement, so the serial print will not occur because it is inside the statement and the statement is itself not occurring. Okay, go here. After the statements, both the statements after have been terminated, write the value of x. It will be always printing the value whether condition has been met or not. Okay, let's just check it. It's giving the value of x is equal to 3. Now if we say that the value of x is equal to 2, then it will enter the if statement. Okay, let's just check it. You can see that it is taking some second. Let us give it a restart. Okay, you can see that the light is not glowing and the value of x is equal to 2, so that it has entered the if loop. It has entered the if loop, and in the if loop we have declared the statement that the light will not glow. Okay, this is possible here, and this is the basic overview of the if statement, and we are in future going to discuss a lot about it, a lot about independent if statements and hierarchy. But right now this is the basic overview of the if statement. Thank you and have a nice day. Hello everyone, welcome to another tutorial of mastering Arduino from beginners to core advanced. In this tutorial, in module 3, we are going to discuss about for loop. Well, for loop is an important compound of programming that has been used in almost all type of programming. About for loop is used to run a specific time of code. For loop is used to run a line of code for a specific period of time or to perform a certain interval or taking certain objects. After that it should be exit. After that it performs the condition of exit. Okay, let's just try to write a for loop on our Arduino to get a physical computing example of it. First of all, for loop is used to write a statement for a particular interval of time, then after it should be exited. There are two methods of exiting it. First of all is default without writing anything else, but second method is important. It is called the break of loop. In this for loop we can break the loop at any time as we required. We are going to discuss about both of them right now. Okay, let's just first of all open the Arduino, open a new sketch, and as per this method we have introduced an LED at pin number 9, so we are going to do our work on that. Okay, let's just write some code. Pin mode, M should be capital because it's case sensitive. Pin mode LED 9 high. Okay, just arrange the brackets properly. Okay, and open the serial port for a better understanding of the situation. Serial begin 9600, set the baud rate. Okay, now come here. This is the part where the loop plays the role. Okay, write for this is the word for declaring the for loop. Give two parentheses and let's just see the syntax. First of all, if we want a variable and if we want is to get a fixed value and it should be open everyone, we should open for every situation. We should always make a variable a global variable. If we write it in the void loop, it will be a local variable, but if we write it before the setup and before everything, just declare int x is equal to 0. Now it has become a global variable and its value will be taken only for the first time. After that, in every condition the value will be changed as per the loop. Okay, in void loop we have written the for loop and we have given it parentheses, but now let's just do the work. X is equal to 0, give a semicolon. It says that the statement in this condition we are giving x is equal to 0, x is less than say 5. Now x should be increased. This is the method of writing a for loop. First of all, declare it, give two parentheses bracket. First of all, write the value of the variable we want. X is given the value 0. After a semicolon we have given x is smaller than 5 as we have understand. Then increase the x to one step as we want. We can also write x is equal to x plus 1, but it is simpler to write x plus plus for giving a single increment every time. Get two curly braces, open them and write digital digital write x comma high. It means that for the loop when the x is smaller than 5, it will give a digital write pin value of high. It means that the light will be glowing. delay should be introduced for a better experience of the program, and it is important in most of the cases to get a better perception of what we are writing and what we are doing, because the processing speed of microcontroller is very high, but we want to control it as per our work. Okay, about the what we want to get on the serial monitor, declare it serial serial dot print. I am using always print ln to get the line, get it work on the next line. Correct the syntax, serial dot print, and we are printing the value of x on the screen. Okay, that's good. For x is equal to 0, x greater x for x is equal to 0, x is smaller than 5, x should be incremented every time before reaching to 5. Okay, here now what should be doing after the loop? After ending the loop, we are giving the value digital write x comma low. But the process will be very fast because the speed of the microcontroller is very fast, so we have to delay it for next 5 seconds. Okay, let's just say the light will be off for next 5 seconds, give the value of 5000 here and terminate the line. Okay, we have declared int x is equal to 0, void setup. We have called led9 is equal to pin mode led9 is equal to output out put, everything should be in capital. We have called serial begin 9600. Okay, in void loop we have made x is equal to 0, x less than 5, x should be incremented by every step, and in incrementing every step, everything the return statement will be running. Okay, the digital light at pin 9 will be high for next 5 seconds and the value will be printing on the screen. But after getting it high on x is equal to greater than or x is equal to 5, it will terminate the loop, it will exit the loop and go to the next statement, that is showing that the pin 9 should be low for next 5 seconds. Okay, let's just compile it. We are compiling it, taking some time, no problem, there are no issues. Okay, let's just upload it to the board, and the uploading is done. Okay, let's just see the serial monitor, it's better for our better understanding. The serial monitor is open in the backward. Okay, let's just get it now. Light is high for next 5 seconds and after entering 5 it will be low for next 5 seconds. Again it will be high and again it will be low. Let's just say for a better experience of the for loop, we can just introduce a value known as break. If we want to break before 5, let's say 3, so we can write if x is equal to 3, give the curly braces, write break, break. Break is the method for exiting the loop. We have written it in the for loop. See that in the for loop we have written x is equal to 3, then it will be directly jumping out of the for loop. Okay, let's just upload it to the board. For loop, I am saving the code. Okay, it's uploaded on the board and let's just see it, what happens. It's uploading and the upload is done properly. Open the serial port. You can see that on 3 it will exit out of the loop. Okay, you see that after getting on 3 it just exited out of the loop because of the break statement that we have included it. It is a very important statement for writing program and getting the performance as per our getting the performance as per our requirement. And this is all about for loop. For loop is mostly used for calling the array values, because it is very important to get a list of array that has been specified each value at each step. But the best method to call an array is for loop. We will be discussing more about arrays and for loop in the later chapters. Thank you and have a nice day. Hello everyone, welcome to another tutorial of mastering Arduino from beginner to core advanced. We are in module 3 and we are going to discuss about the topic while loop. Well, while loop is similar to for loop as we have studied previously, but there are some basic differences between the for loop and while loop. In while loop it does not require an increment, while in for loop the syntax says that it requires an increment. And for using a complex statement, even you can use a boolean statement to run a while loop, while this is not possible in for loop. Another important thing that a for loop is very good example for calling an array, while a while loop should not be preferred for such experiences. The basic difference between a for loop and while loop is that a for loop is specifically simple and controllable loop, while a while loop is individual and it can run on infinite long time, and it can also use the boolean values as conditions it can require. It can also use boolean values as the condition that are required to get the statement. Okay, let's just perform a while loop example here. If you want to learn the basics of while loop and how can it be used for different complex programming example, I am showing you a website which will give you a basic difference between them. Now here you can see that here it is written that for while loop the conditions and the for loop the conditions that are met. Okay, let's just go back and open the Arduino and let's just write a code, simple code for while loop. As usual, I have given an integer value x and it is a global integer because it is a global variable. The as declared before, I am giving a variable a global signature so that it can be operated from all other the part of the programming. And let's just say that we have connected an LED to pin number 9. Okay, so declare it pin mode 9 comma output should be capital as I have told you earlier, and open the serial monitor for the better understanding. If the word does not turn orange, this means that you have made a simple mistake or anything such as making alphabet lowercase or uppercase or anything, any syntax mistakes is done, then the word will not change to their definite color. For example, for calling something it will turn into orange. Set a baud rate that is fixed for our tests. We will performing another baud rate example in the further lectures. Okay, now get into the while loop. While loop is initialized by calling simple while. You can say 1 is equal to 1. This is the most common example of calling the while loop. It will make the LED glow for infinite long time. Okay, you can see that here if 1 is equal to 1, that is a basic knowledge of mathematics, that is always true, then it will run. This is an example of the boolean statement that the while loop can take inside it. Okay, let's just upload it to the board. It's uploading. Okay, you can see that the light will always glow because 1 is always equal to 1 and this is a known fact. Now in while loop you can perform other statements also, such as while you can say that while x is always greater than 5. This is the best example. You can also add the increment inside it, such as called x increment by every step. In while loop we have performed an activity that it is saying that while in while loop, let's say that while x is smaller than 5, digital write 9 is equal to high. Let's just give it a delay of let's say 500 millisecond. Okay, now after exiting it should be given a statement, or else it will again run the whole void loop. 9 comma low, it will be running for next 5 seconds. So give a delay of 5000. Okay, in while loop if the x greater than 5, then it will exit the while loop. Until then it will be running continuously. Okay, let's just see it. We can also print it on the screen, so let's just print it on the screen. Write serial.println. it means print in next line each value, let's say x. Now just copy the whole statement and you can also paste it here for a better understanding of the program. Okay, now I have said that there should be syntax error. You can see that the word does not turn to orange. The same error here. Let's just remove it and let's just upload it to the board. Let's just save it as a name of while loop. It's uploading. And uploaded. Now you can say that in the digital serial monitor. I think there's some error in the code. While x is smaller, I have said you that there is an error. Now change it, the syntax, upload it once again. While x is smaller than 5, then the light will glow after x greater after while x is smaller than 5, the light will glow after getting a value of x that is greater than 5. The light will not glow. This is the simple syntax of the while loop, and we have performed it with the function of increment in it. You can see that the loop is running continuously. After the while loop, it has been entered into the next lines, but you can see that the value of x has been declared and it cannot be changed. So the function will not allow the LED to glow once again. This was the example of while loop, and we have declared the. Let's just recall the differences between them. For loop is used as a simple loop for declaration of variable. It has much greater extent of control over the loop, and it can also, both the loop can perform the break operation. Now while loop can also run on the boolean statements such as 1 is equal to 1, or the physical truths that are available in the world such as 1 is equal to 1 or 1 is equal to 1, or you can say that 2 is equal to 2, anything that can be a physical statement. And it can also run on the function of increment method. You can see that we have performed the same function as the for loop using a while loop, but there's a difference. In while loop, the last value is always less than 1. In this case, you can see that when it is smaller than 5, so the last value will be reading here is 4. While if you are perform the same function in the for loop, the last value it will be reading is equal to 5. In while loop it will be 4, and in for loop it will be 5. Okay, thank you and have a nice day. Hello everyone, to the next tutorial video of mastering Arduino from beginners to core advanced. In this video of module 4, we are going to discuss about arrays. Well, array can be said as arrays are the integers which can store a large number of values into it, and they all have a specified place or a specified number to call them. This method is used to store a large number of values and to call them when it is required. We have discussed previously about the for loop. Well, array can be easily called with the help of a for loop. Now we are going to discuss about the array and making a small program out of it. Okay, first of all, open Arduino, make a new document, open Arduino, make a new sketch. Now get here. First of all, we want to see the value, so we are first going to call the serial monitor values, SERIAL. Sorry for the mistake. Serial dot begin 9600 with parenthesis. Okay, now let's just get to the topic. Array can be called as an integer. See here, array, my array, ARRAY. No difference. Use two brackets. These brackets are the syntax which is used to say that this is not an integer but it is an array. Give a value of equal to. Now use two curly braces. In this curly braces, you can place the values of the integer. I say 6, 8, 3, 2, 6 again. Okay, let's say 9, 22. Okay, see that how many elements are there in the array? 6, 8, 3, 2, 9, 22. Now listen carefully that the first value of the array is not my array 0, but it is the value. Now listen carefully that in this array we have about 6 elements. So you cannot say that it is the first value has the. So you cannot define the first value by using method myArray1. For first value, the array starts with the value 0. For if you want to get print 6, you should use the value myArray0 for 6. Let's just try it. Say serial dot println say myArray use the full syntax, make two brackets and say value 0. Okay, terminate the line, upload it to the board. Wait a second, I am just plugging my Arduino. I am uploading it to the board, and let's just upload it. It shows that it is giving me an error. Let's just see it. I'm turning the serial monitor off. Wait a second. I have not closed the bracket. That was the mistake. Okay, let's see it now. Just see it. It's uploading, it's compiling, and wait a second. There was some problem in the board, so again let's just try it. It's been successfully uploaded. Let's just see what was the value 0, and it's 6. If you want to call the next value, just edit it from 0 to 1. Now upload it once again. You can see the value of 8 is occurring on the screen. This is because when we are calling array, my array element 1, it is saying that it is the second in the line. So for second you use 1, for third you use second, and for first you use 0. This is the method for calling an array. But what about calling the list, complete list of an array? Is it possible? Yes, it is possible with the for loop, as we have discussed earlier. Okay, let's just try it. First of all, delete everything about the serial, nothing more. Write 4, give to parenthesis, x is equal to 0. X is not defined earlier, so we have to declare it. Int integer x is equal to 0. Give a semicolon. X is smaller than 7 because there are 6 elements, so it should be smaller than 7, as I have told you earlier. X increment. Okay, the syntax is correct. Let's just give to curly braces. Now write serial, serial, my mistake, serial dot print ln. I am calling my array, array, my array, calling to brackets, as is the method. And what should be the value here? The value should be placed here is x. But there is one problem. Because of the speed of the processor, we have to make it slow so that we can view the values clearly. Okay, give it a delay of say 500 milliseconds. Okay, terminate the line, compile it. No compilation error, so upload it to the board. We have uploaded it to the board successfully. Let me do it once again. Okay, the program has been uploaded on the board. Let's send the serial monitor. Start it once again for better understanding. First element 6, 8, 3, 2, 9, 22. Every element is being called. There is a systematic array that we have used the word 7, so it is also taking the 7, which is not possible, so it is giving a garbage value. Come into the program, write it value 6. It will not give an error. Okay, give it a value 6. Again upload it and call the serial monitor. Now you can see that without any error the program will run. Okay, there is no array in the program, and the array is calling all the elements as required. But what is the use of array? The array is used in most of the cases for calling multiple sensors or multiple, you can say, LED lights. For example, an array of LED light can be called by this method so that multiple lights can get on and off at a specified time for as per the for loop or whatever your condition is. You can control it completely, and you can define 5, 6, 3 any pin number randomly, and you can call them with the help of array. We will be continuing multiple array in the next chapter. Okay, and thanks for watching. Hello everyone, welcome to another tutorial of mastering Arduino from beginner to core advanced. Well, we are here in module 4 and we are gonna discuss about the content. The content is as follows: difference between input and output, multiple LED array, how to blink a multiple LED array, how to give a button as an input and get a function out of it, do a logical operation from it. And the same will be as for an analog input, and it will be giving a logical analog output. After that, in the end, we will be seeing a LCD, or you can say it a liquid crystal display, and showing some digits or display, such as we are giving it a display same as we are giving the display to the serial monitor, but this time we will be giving it on an LCD, so the system can be run as an standalone without the help of a computer. Okay, let's just begin the topic. First of all, the difference between input and output. This is a theoretical part, so we have to get this is a theoretical part, so we have to get through it. First of all, there are two methods only by which the pins of an Arduino can get access. First one is to give a digital input, or second one is to give it an output. The output and input can be both digital or analog as per the pin description. Most of the pins are capable of giving an analog output or input, while every pin in the Arduino board that has a number is capable of giving an input and output in the form of digital, such as the analog pin A0 to A5 will be turned into digital pin by using the number digital pin 14 to digital pin 19. Okay, first of all, the input in the pin is given in the form of a voltage. If we connect the digital pin to read something and connect it to ground, then it will be giving a value of 0, while if we give a voltage of 5 volt which is connected to the board in the form of ground, then it will be give a value of high. The same applies for the analog. While there is a difference between digital and analog is that in analog you can get a measurement value. For example, if the voltage is 3, then it will be giving a value of 600. For the voltage of 5, it will be giving a value something about 480, 840, anything similar to that. It will be range of value from 0 to 1023 while reading, and for writing it will be 8-bit value. You means to say that 0 to 2 raised to 8 minus 1, that is equal to 0 to 255 will be the writing value, while the input value for reading is 0 to 1023. This is because the analog to digital converter is configured in such a way in the microcontroller that it can read 2 raised to 10 values as input, while 2 raised to 8 values will be given as output for the voltage sources. But the scale for it is same, it is 0 to 5 voltage. Only the difference is that in reading you can get a 4 times precise as value as in writing. Okay, now let's just discuss about the code and what is the difference in it. Here you can see that both of the form will have the same method for input or output, such as, first of all, we are going to discuss about digital and what is the difference in codes while writing a digital input or output. Both of the method only have one difference. Pin mode for input, it is written capital input, and for output it is written capital output in the same method. But when it comes to program in void loop, there is some method difference is available. There is some method, but when it comes to void loop, there is some difference for calling the pins. For digital write function, it is very simple. Just declare the pin as digital write, give the pin number and set the value. For digital output, it should be low or high. While when we come to digital read something, first of all we have to declare a variable, and then variable should be storing the value of the digital read and the pin. There is no declaration of low or high because it is the read function. It does not requires a pre-built value. It will be reading from the environment or from the board pin where it is connected. Okay, and the same method you can see the print value using the same serial.println for digital read as well as serial.println for digital write. The method is same. Okay, the next part is for an okay. Thank you and have a nice day. Okay, hello everyone. We are in the tutorial series Mastering Arduino from Beginners to Core Advanced. In this series, we are here at analog grid. So we have to first get a clear knowledge of what is digital and what is analog. For this, I have find a document on internet that is quite reliable. Okay. First of all, open the Google Chrome. Here about the analog signals and the digital signals. First of all, let us see what are analog and digital. Well, analog signals are the continuous signals that gives a physical measurement, why it says that you can measure a value of 225, 236, etc. While a digital signal is a signal that just has only two discrete values, that is 1 or low or 0, 1 as high and 0 as low. Okay, this signal they have a clear and smooth curve and they form a straight form waves. Okay, you can see here that let me draw it for you. Okay, here let's just see a clear visual difference between the analog and digital. Okay, first of all, we just draw two graphs here. See that graph 1 for analog and graph 2 for digital. For analog signal, it ranges from 0 to 1023. Okay, well, don't mind about my writing. Let's just see the thing. For analog signal, it will be a wave or a curve such as like this or like this it will go. But for a digital signal such as here, it has only two values, 0 and 1. It can be here or it can be here. There is no another possible value for a 0 to for a digital signal. But while analog signal can have a variable values, here it can be 225 here, 512 here or 1023 here. It has it can have all the values. At for the 10-bit analog to digital converter which has been pre-installed in the microcontroller. So 10-bit, you can see that it has a value of 0 to 2 raised to 10 minus 1, that is 1023. Okay. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this video, we are going to talk about controlling multiple arrays of LEDs so that we can run them independently while controlling about 3 LEDs at the same time. Okay, first of all, about the LEDs, they are simple light emitting diodes that are connected to Arduino. When the digital pin is high, they get glowed, and when the pin is low, they will not glow. Okay, this is the theory of array. This is the theory of LED. Now what would happen if we want to control a large number of LEDs? Say that they are connected to pin number 5, 9 and 3, but we cannot control them randomly. There is no method. If we are going to write a program for that, it will cost us a lot of line and the program will be unstable. So there is a method by using array, as we have studied earlier. If we use array to control a list of you can control a list or an array of LEDs together with the Arduino board and some small programming method, that is controlling a LED with array. This is an important part of physical computing, so please concentrate on it. Let's just begin with opening Arduino. Okay, first of all, in the setup you can see that I have connected the LED to pin number 2, pin number 3 and pin number 4. Okay, that's the pin of LED. So first of all, let me make it simpler. Okay, we are in void setup. First of all, we are going to call the pin mode of all LED, so that we are giving them values high and we are giving that output. We are setting them as output. We are setting the LEDs as output. Okay, calling 3 pin modes, give it a 2, give it a 3 and give it as 4. Now capital output OUT PUT, my mistake, output. Now just copy it and paste it on all 3 sections. Okay, the first function void setup has been completed. Now we are coming to the main point. First of all, making an array. I am giving name int LEDs, giving 2 brackets, that is enough. Giving to equal to, give to curly brackets for calling the array. This is the place where the value of the array is stored. Okay, we are giving pin number 2, pin number 3 and pin number 4 here. Okay, terminate the line. Now it is simple, call a for loop. Let me show you an example. Let's just say digital digital write digital write LEDs give to brackets and let's just say 1. So the pin number 3 LED will glow. Okay, let's just check the program and we are compiling it. There is some error and the error is, it is saying that let me correct the program. It is a simple mistake of Arduino. Okay, let's just do it once again. Okay everyone, it was my mistake. I did not give the argument, the value that the LED should be placed high or low. I am giving it a value high. Now you can see that the LED number 1 will be glow. Okay, let's just see it again. My mistake, I have LED second. It means that the second value of the array, that is pin number 3, the LED that is placed on the pin number 3 will, the LED that is placed on the pin number 3 will glow. Okay, let's just see it. A lot of compilation error I can see here. Let me complete it. It just an error, just a typo. Let's just see it. Okay, you can see that the LED that is connected to pin number 3 will glow. But what about pin number 4? If you want to test it, you can do it. Just go there and say 2. So the array position through, that means the third point. The third point we have connected LED number 4. Okay, let's just see it. Okay, you can see that the fourth LED is glowing. But what about if you want to call them in a sequence and give a simple example of a program for working it in a continuous mode? Okay, let's just try it. Delete the line. You can use for loop. Give parenthesis. Say x is equal to 0 as we do in for loop. Give a semicolon. Say x is smaller than say 3. X is smaller than 3. Give parenthesis x plus plus. Okay, now give to curly brackets. It's simple, just write digital write LEDs give to brackets. Be careful about writing the bracket. I have done a lot of mistake here, and the value that we are giving it is x. We are giving x and the statement is saying that it should be high. Okay, terminate the line. Now again, there is something you should be careful of. Once the LED are glown, they cannot be turned off. You have to mention that to turn off the LED. Okay, come here, copy the line. After the finishing of the loop, write 3 lines. In all 3 lines we are saying that the value of LED should be low. Okay, let's do it. It's taking a second, just wait for it. 3, and the height should be written as low because we want to pause, we want to set them at low state for a second. Okay, let's just do it. But for how much time? It will be doing in within a fraction of milliseconds, so we have to delay it for let's say a second. We are giving it a value of 1000 millisecond delay. Okay, let me explain you the code. First of all, we have called the pin mode of LED 2, 3, 4 as output. Now in void loop we have declared an array that is 2, 3, 4. That is the values we are calling here. For the next line we have made a for loop which is saying that the LED X will be high for let's say a second. Let me correct it. I will be blinking it for a second. 1000. In the for loop, each LED array value will be called and it will be blown and it will be bright for 1 second, and once all 3 LED are bright, the program will end and it will set all 3 LEDs to low. Let's just check it. I have a mistake. I have not declared it. I have it. Okay, now let's just try it once again. There is a mistake in the program. I have said LED 2 times, so let me correct it, and now let's just see it. 1 2 3 stop. All the LEDs are glown and they are stopped. If you want to see it in the serial port, it can also be done here. Just let me call the serial monitor as serial.begin. We can use different values of begin such as 115200, but they are for higher baud rates and we will be discussing about it later. In the line you can just call it serial.println the value of x. The value of, let's say, x. No, we are not using the value, we are using the value of array that the x is selected for the second. Okay, again upload it to the board. There is some correction required. Serial.begin, there are 2 n's. Correct it, upload it to the board, and once the upload is completed, let's just open a serial monitor. The program will restart and see here 2 3 4 shutdown. 1 second, 2 3 4, and again it will be a shutdown. Okay, by this method we can connect and we can control a list of arrays, a list of digital pins that are connected to another values randomly. It can be any pin such as 4 5 9 etc. It can also be used to control analog pins, and it is very useful method for controlling a list of sensors and motor. Okay, thank you, and hello everyone, and welcome to another tutorial of mastering Arduino from beginner to core advanced. In module 4 we are going to discuss about an input such as button and giving it an output such as LED glow. Whenever we press the button to state high, the LED will glow, and whenever we release it, the LED will go back to off state. Okay. Now first of all, I want to tell you that this is the most basic type of program that is been done in the physical computing. It's just a simple circuit. With the help of an on button you will get the LED on and off. Okay, but the important thing is that in this program we are using the logic of the microcontroller. You can say that when the microcontroller sets one pin high, it will perform a logical operation, then it will send the output of the digital pin that is connected to LED to high. So this is performed as an logical operation for the LED to get it brightening. Okay, first of all let's just try to write the program. The program is available at the Arduino with example in section digital named as button, but we want to make our own program. So we are doing it from the scratch. Okay, open a new tab in Arduino, write the pin modes. In this case we need 2 pins, one for input and one for output. Okay, let's just give it, copy the syntax, just a second. We are copying the pin mode. Okay, we have given 2 pin modes. Say LED pin 2, that is input. It means that it is taking the signal it is reading the signal for state high or low. Okay, and we are selecting LED pin 3 as the output or the pin at which the LED is connected. Okay, that's it. Now here let's just declare an integer. Say int b before button, int b. Okay, we have declared the integer. Call b. Let's just give a simple example for reading the details. We need b to store the value of the reading that is done when the digital pin 2 is getting high or low. So it is simple. Write digital capital READ D, digital read, it will turn into orange. Let's say pin number 2, in our case it is pin number 2. Okay, so the LED B, the LED pin, no. So the integer B will store the value of the digital pin 2 in it. Okay, and just write a simple logic. If B is equal to 1, we can say digital write, digital write pin number 3 comma high, high, or we also need an else statement in it. Else digital write digital write pin number 3 LOW. Okay, let's just see the syntax of it. At first we have declared two pins such as pin number 2 as input, and we are writing pin number 3 as an output. The pin number 2 will be used for reading the value, and pin number 3 will be the pin number 2 will be used to reading the value, while the pin number 3 is connected to an LED to give us an output. Okay, and in here we have declared an integer, but for the betterment of the practice, we are always trying to declare the integer at the top of void setup. Okay, we have make it here. Okay, integer B, and let's just say the initial value of integer B is 0. It will be for betterment of the program and improving the performance. Okay, at the first value of integer B will be 0, but after entering in void loop, the integer B will read the value of the pin number 2 as digital read. If pin number 2 goes high, B will be 1, and if the pin number 2 goes low, the B will be 0. Now for the if statement, the condition is if B is equal to 1 or B is equal to, you can say, high, then the operation of digital write pin number 3 will go high or it will glow the LED. And then for the else statement, it is necessary we are giving an else statement saying that if the value of B is not is equal to 1, then light will turn off, or you can say pin number 3 will be low. Okay, let's just compile it. We are compiling it, giving a name button button. Okay, it's compiling, just wait a second. Okay, we are uploading it to the board and the upload is done. Okay, let's just take it. Here you can see a wire is connected to 5 volt, and this is pin number 2. Whenever we connect this wire, it will turn on high. But remember one thing, that because of the garbage values, LED can turn high for few more seconds. For that we have to connect the high pin number 2 wire to ground to get it low. Okay, see, you turn it high, you turn it low, you turn it high, you turn it low. It is better to use wires in place of button for testing, because in button you can get the garbage value, or you can say the micro values of initially getting high and low, causing the transient, which will give a random values of high and low, which will make the LED to flicker. This is because the processing speed of the microcontroller, because it deals in milliseconds. So removing the transient, we are directly connecting wires. Let's just see once again. This is because of garbage value. Now see here, it turns on, turns off, turns on, turns off. Okay, this is the use of button value, and button will be very useful for many applications, because in most of the cases there is no button, but there will be sensors. They are digital sensors. They will be giving a value of high or low, and for that system of getting value high or low, you need a simple logical program such as written here to getting the value and perform a digital operation and perform an operation such as digital write pin high. You can be using another motors or anything, but in our cases we have made it the most simpler format, such as glowing an LED. Okay, the code will be present within the beginning of the PPT, and thanks for watching. And if you have any question, you can ask me in the comment section. Okay, thanks for watching. Hello and welcome to another tutorial of Mastering Arduino from Beginner to Core Advanced series. In module 4, we are going to deal with analog input and giving it as an output to the LED. Well, analog input, as we have seen previously, that analog input is the method that is used with the help of a potentiometer to show the voltage to the board, and such that the board can display the voltage on the serial monitor. But here we are going to study that you can write manually analog values into the program, and it will be giving as an output to the LED brightness, such that if you are given the value 255, the LED will glow to its maximum. But if we have given the value of 150, then the LED will glow up to 50%. And if you have given the value of analog write 50, then the LED will glow very dim. Okay, let's just try it with an help of an example. Okay, first of all, open the Arduino. Let's just start with writing our own sketch. We want only one value, such as LED pin, which is connected to pin number 3. So we set pin number 3 as an output. Remember one thing that should be very clear, that analog output can be generated only on the pins that have a special type of symbol on it. Well, you can see here the pins that are connected to the analog have a special type of symbol on it, which is named as PWM, because analog writing in Arduino is done with the help of pulse width modulation. Okay, let's just write the program. First of all, begin with pin mode. We are doing a pin mode of pin number 3 as output. Okay, pin number 3 is set as output. Okay, we want an integer that will be storing the value for analog. We said is integer v is equal to 0. Its initial value is 0. Okay, come here, write int. No, there is no declaration for here. V is equal to, let's say, 100. We given the value for integer such as 100. Now write analog, analog, capital W RITE, analog write. This will be calling the analog pin number 3 and giving it a value that is stored in the variable V. See the syntax: declaring an integer, calling the pin as output, giving the integer a value, and writing it is an analog format on pin number 3 with a value of integer V. Okay, let's just upload it to the board and see here. You can see that the light is glowing, but if we give the value from 100 to 200, just see the brightness of the LED. The LED turns more bright. Again, do it 100 and see here. The LED glows dim. But if you want to see real performance, set it at 10. Now see the value of the brightness of the LED. It's glowing very low. So by this method, we can directly give output to an analog pin to perform the operation, which happened because by writing the variable to the analog write, we are changing the duty cycle of the PWM, which in turn from digital to analog converter, which is 8-bit in 8MEGA328, that is used in Arduino Uno, will give a duty cycle which can be set as 10 divided by 255. That will be the duty cycle here. Again, make it 255. That will be the highest point of brightness. See, the LED is glowing to its brightest. If we want to see how the value is stored or how much is written in the LED, how much value has been stored in the variable, you can see here. Let's say 9600 here, and come down, write a value. Serial.println, we are storing the value in V, so we are writing here. Okay, upload it. LED is brightening. Okay, see here the value is 255, that is given by analog. Well, now set it 25. The LED is glowing at a very dim pace and the value of the analog write is 25. And if you want to find the duty cycle, just do a simple division of 25 by 255, which is about 10% duty cycle. Okay, this is the method for finding the duty cycle, and by this method we can control the analog write, or you can say the analog output, with the help of simple programming. Okay, we are discussing it further in other lectures, and now if you have any questions you can ask me, and thanks for watching. Hello everyone and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about LCD, or you can say liquid crystal display. Well, LCD is an important component in Arduino because it is the main thing that can give the display of the program, or you can say the variable that is inside the Arduino a standalone, so it does not require a computer. Such as in serial monitor, whenever we want to give a display we need a computer, while using this LCD here you can get all the displays on the LCD, so that we can make Arduino and complete the system in a box and can place it anywhere without the help of a computer, and we can see the variables inside it. It can use to measure temperature, moisture, and you can give your own custom prints on the LCD. Okay, now let's just see the block diagram of the LCD. Well, here is the schematic of the LCD. Remember important things: these pins are for the light, these pins are for the power, and here this important pin is for analog display. If you rotate the dial, it will give a value that will make the LCD go dark or dim. Okay, I will show you, just a second, hold here. You can see that with the help of rotating the dial, the potentiometer, you can see that the display of the LCD changes, and which gives us a dark or a light view. Okay, here the schematic. These are the four basic wires which are used to here are the four basic wires that are used to convert all the embedded program written in the Arduino to the display function of the LCD. Okay, now let's just begin to write a simple example. First of all, remember one thing, that in Arduino there is also a built-in library for LCD, and there is a simple program of LCD also written in the Arduino. We are going to see here the program. First of all, we need to call the liquid crystal library, so we are going to call it with the word liquid crystal.h, giving the close bracket. Now we need to declare liquid crystal an element. We are declaring liquid crystal element LCD, and we are giving the pin numbers as pin number 12, which is an enable pin, pin number 11 which is for the display, and pin number 2, 3, 4, 5 for the variables that are going to print on the screen. In void setup we are going to call serial LCD.begin. In void setup we are going to call the function LCD.begin. It is setting the pin to 16:2. It means that 16 columns and 2 rows are activated in the LCD. And in the next line we are going to print hello world. This is the word that we can directly print on the LCD just by calling the word into the brackets. In void loop we are going to set cursor to pin number 0 and 1, that is giving the lower column. Here you can see this lower column, first section will be getting the variable point, and here we are going to write a variable, changing variable, that is millisecond, and we are going to print it. Okay, let's just upload it to the board. It's uploading. Wait for a second, and just wait for a second, and here you can see that hello world is written on the screen, and it is counting the time. Let me make a clear display for you. Hello world, and it is counting the time in milliseconds. By this method we can connect the LCD to the Arduino and get our own desired display. Okay, if you have any questions. Okay, but what about writing something else? Okay, we are going to write something else as come down here, and LCD.come in LCD.print, write say something HIE. We are going to write the value in second line and in the first word. Okay, first section. We have uploaded it successfully on the board. Now let's just see here. We can see the high is written here. But what about Okay, this was the feature of the program here. But what if you want to write something else in another line? Give the value 4 and now write something as, again let's just try with HIE, high, and please clear the space. Okay, we are going to print it in another lines. Wait for a second, it's coming, and we are going to reset the Arduino. It will take a second. And see here, we are calling, my mistake, I have written it in 4th row, and we are going to write it in 1st row and in 4th column. Okay, we are going to update the program, and wait for a second. Now you can see that the word high has been moved 4 columns to the left. Okay, by this method we can write the words on LCD, we can print the variables, and we can get a real-time data on Arduino standalone without using a computer. This is known as LCD, and this is the LCD module I am using here. It is manufactured by Hitachi, and it is a very stable LCD. And there are also different type of LCD that comes in 16x4. They have some different pin diagram, but basically their working is same, and they require their own custom made library for running. Well, this was the LCD module. If you have any question, please ask me, or else thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to learn about motor and how to control the motor with the help of Arduino. First of all, let's just see the content. Our content is type of motors. Next content will be single DC motor, simple DC motor, servo motor. Then after we are going to talk about stepper motor, and in the last 3 tutorials we are going to learn about the controlling method of the motor, and we will be doing an experiment on controlling the motors. Okay, let's just begin to our first topic. Before starting type of motors, I want to tell you that about a motor is an electromechanical instrument that takes electrical power as an input and gives out in the form of mechanical power. There are 2 types of motor in the world. They are AC motor and DC motor. In Arduino we are mostly be talking about the DC motors of low voltages. Okay, let's just start about the DC motors and their types. First of all, the DC motor, it is a simple motor with 2 wires. You can see here it has only 2 wires. If you want to change the direction, just change the polarity, one connected to positive and another to negative, and if you want to change the polarity, just reverse the wiring and it will change its direction. Okay, this is a DC motor. Okay, next, what is a stepper motor? Well, first of all, what is a servo motor? A servo motor is a special type of motor that is used to give the values in degrees. It is not made to rotate continuously in 360 degree, while it is meant to rotate for a specified degree. If you set the motor to run at 30 degree, it will lock itself at 30 degree. It will lock itself at 30 degree, and whenever you try to change the direction of the motor, if the program is running, then it will set back itself to 30 degree. This is very important motor for making toy aeroplanes, and because this is very important motor for making toy aeroplanes, because for the rudders, if you want to set the value for 30 degree, and the wind will be causing another effect to suppress it down, while the motor will turn itself back to 30 degree, so that it can make the movement of the aeroplane very easy. The third type of motor we are talking is here is a stepper motor. Well, stepper motor, the third type of motor we are going to talk here is stepper motor. Stepper motor are of 2 types. They are unipolar motor or bipolar motor. They are specially designed motor that can run on computer commands, such as servo motor, but they are used for more than 360 degree run. They are used for long run, especially in CNC and 3D printers. They can be very high speed motors. They can be very low or very basic motor. They have a simple running mechanism which is set as a coil, and inside there is a magnet. The magnet is rotated with the changing value of the direction of each individual coil, which causes the motion, and each magnetic coil is activated by a pulse, while a driver is used to amplify the computer pulse into high voltage pulses for running the motor. Okay, and the last type of motor we are going to talk about is DC motor. Well, And the last type of motor is brushless DC motor or BLDC motor. Well, a BLDC motor is similar to a stepper motor, but the basic difference between it is says that it is a brushless DC motor. Means that the functional effect of the motor is similar to DC motor. The mechanism is similar to a stepper motor, but it is used for very high speed operations such as the rotors of the quadcopters. All the rotors of the quadcopters are only connected by BLDC motor because they are the lightest, they are the most powerful which in terms of speed, and they are the most simple type of motion. They are the most simple type of motor for high speed operations. They are controlled with the help of pulse width modulation and specially designed drivers. You can say that electronic speed controllers in the term of quadcopters. They are also connected with microcontroller, mostly of 32 bits, for controlling their operation. Okay, thank you and have a nice day. If you had any question, you can ask me, or else thanks for watching. Hello and welcome everyone to the tutorial series of Mastering Arduino from Beginner to Core Advanced. We are here in module 3 and today we are going to discuss about a simple DC motor, its working, its diagram, and how to connect it with Arduino to get the motion. Okay, first of all, about the DC motor, I want to tell you that DC motor is the most simple type of motor you have seen, because this motor is a very small device. It can be found in toys. As you have seen here the photo, this motor has been taken outside of the toy, and here the DC motor, you can see that in the video, is the big motor. They both have different design, but the thing is they both run on the same principle. When the power is sent in one direction, it will rotate in clockwise, and when the direction of the power is changed, it will run in anti-clockwise. First of all, the DC motor cannot be connected directly to Arduino. It requires a specific driver or a transistor to run it, because if we connect the DC motor directly to Arduino, it will draw a lot of power that can eventually burn the Arduino. Sometimes the laptop also can get harmed because of this. So to control a DC motor, we need a driver or a transistor setup to run it. Okay, let's just see about the DC motor. Here you can see the working principle of a DC motor. In a DC motor, here outside the body there are two magnets such as North Pole and South Pole. Okay, and inside it, here is the coil. Whenever the charge is passed across the coil or the contacts of the motor, here you can see these are the brushes or the contacts, and this is part is called the commutator. Commutator is a copper ring that is divided into two parts. Whenever the current is passed here, it will force the motor to it will force the wire of the coil to go into one direction. This is because of the right hand rule of the motor that was given by Fleming. Okay, this is known as Fleming's right thumb rule. You can see here. Let me make a correction for you. This is the right thumb rule. All three fingers are in another directions. Okay, let's just see it in small working. Here you can see that whenever a charge is passed, the motor will rotate in one direction, and when it comes in the middle point here, so the contactors change its direction, and this works as a mechanical rectifier for the DC motor to continue its motion in one direction. Important part, the split ring is a copper ring that is divided into two or more parts. This is the main reason for the motion of the motor in one direction, because when it comes here at the 90 degree, it automatically changes its poles in the mechanical rectifier form, and this will give the motor a continuous motion in any specific direction as the current has been flown to that direction. The direction of the motor can be changed. If we give here minus charge and it will be giving here plus charge, then it will automatically change the direction from here to here. Okay, now let's just see about how to connect a motor to the Arduino. Here you can see that it is running on the left thumb rule. Here I have shown you it is running on the left thumb rule. Here this will be causing the direction of the motor. Okay, let's just see about the drivers. Here you can see that this is the driver that will be using here for running a motor. Okay, here you can see that the diagram that is connected Here is the schematic of an Arduino and a running motor with the help of a 12-volt outside source. Here you can see that when the transistor is connected, that is an NPN transistor. And about the wiring, first of all, to activate a transistor, as I have told you, you should have to give it value digital high. Digital write that pin number and should be given a value of high. It will make these two transistors to go up, and it will eventually connect these two circuits, giving it a closed loop. And that closed loop will be taking the power source from the 12-volt battery and giving the motor a specific running output. So by this method we are operating the motor with a 12-volt output, but the control of the motor is done by the Arduino, and the interface between them is the transistor, because the transistor controls the power direction. Or you can say that it is like a valve and power is running like a water. So the transistor controls the water from the transistor controls the direction of the current or the flow of the current to give the motor rotation. But the main problem of this method is the motor can run in only one direction, and for running the motor in two direction you have to change the polarity of the motors. Okay, and this was the description of the DC motor. If you want to see, I will be giving you the diagrams. Here is the diagram, and here is the transistor connection, and this side will be connected to Arduino, and this side will be connected to the power supply as we required, and this here is the motor. These are the terminals of the motors. Okay, and these are the basic theory of the running a motor. Well, I think this method is quite useful for running heavy appliances also, but for that we will be talking in the last section or in the 10th module about running heavy motors by this method. Okay, if you have any comment, just please write down, if you have any comments, please write down, and thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to discuss about servo motor. Well, what is a servo motor? First of all, I want to tell you that servo motor is not like a simple motor which rotates continuously in a fixed direction. While on the other side, servo motor is a kind of motor that is fixed for a specified value. It can rotate only from 0 to 180 degree, and it is not possible to rotate it more than that in many servos, while there are some servos that can rotate complete 360 degree in continuous rotations. But the main thing that the servo motor is used, that the servo motor can set a specified degree. If we set a servo motor to move at 30 degree, it will lock itself at 30 degree. In any condition that will occur to move the servo degree, any condition that occurs to move the servo motor in any direction, the servo motor will refuse it, and it will come back to the position. It will come back to the position that is set to it. Say example 30 degree. If we set a servo motor to move a 10 degree direction in every second, it can do that like that 1, 2, 3, 4, 5, 6 and up to 10. If we want to set it to 5 degree, an exact 5 degree precise, it can get locked on the 5 degree. Well, there are many applications of servo motor. Example, the toy plane have the rudder are controlled by servo motors. The reason because of that is when the servo motor moves, it get locks at the position, and when the air flows over the wing, it turns to move the wing in backward direction opposing the servo, while the servo motor get back to its position and get the values clear. I have got some document on internet which can help you to get a brief knowledge about servo motor. Okay, see here about the servo motor. There are of many shapes and size. Some are industrial motors that are capable of rotating continuously to 360 degree. Well, the servo motor has a basic design. See the design carefully. This is the control signal, or you can say this is the Arduino. The pulse width converter, we have talked about it. It is ADC. Now coming here, this is the servo motor part. This is a comparator, a small chip that is implanted in the servo motor, and this is the position sensor. You can say a simple potentiometer. This is an amplifier, a part of the chip, and this is the motor. This is the motor axis. When the axle is set to rotate at 30 degree, it will compare its position here, and it says that it position it as 0 degree, so it will give an error here, and the error will be amplified such that setting the rotation of the servo motor from its whole loop to get back to 30 degree. When the motor gets to 30 degree, the data says that there is is no error. It said it wanted 30 degree and it is at 30 degree, so there is no error. So the value that is set here by Arduino to move 30 degree has been logged here by the axis at moving 30 degree. Whenever a change is made in the servo, it gets back to its location, it gets back to its point. But now we have to discuss about the how to connect a servo motor to a Arduino. See here you can see that there are, just a second, there are 3 pins in the servo motor. They are as follows. The first one is yellow, that is for signal. The red one is for 5 volt output, and the black one is for power voltage ground. Let's just see it in the diagram. I have made a simplified version of it. Here you can see that the yellow wire is for the signal, that is connected to the analog pins of the Arduino. The 5 volt is connected to the board, and the ground is connected to the ground pin. But I need to mention you something, that is it, if possible, give the servo an individual power supply, because if you connect the servo motor directly to the board, and if the motor, which has a size like this, will create a great disturbance, and it will surge a large amount of power, which can eventually fry the board, and it can also cause the damage to the computer. So to moving continuously a servo motor of heavy torque and heavy motion, it is recommended to use an external power supply and connect it to the ground, and then send the signal from the Arduino for the motion of the servo motor stability, and for protection of the servo motor and the mother, you can say, the Arduino board. Okay, this was the basic description of servo motor. In the following videos we will be using servo motor and controlling it with Arduino with an example. Okay, this is the clear documentation of servo motor. To search anything, you can go to internet. If you have any discussion or any problem, or you can say any question, please comment me, and if not, thanks for watching. Well, about the servo motors, I want to tell you that there is a built-in library in Arduino that can control the servo motors. You can see here, from file, going to examples, and go down, you can see that there are 2 programs built in for servo motor application. Here you can see that the default library of servo motor is called, the library is given an object, and the object is selected for all the operations. Here the object is said that the servo motor is attached at pin number 9 of the Arduino board. Okay, the pin number 9 will be giving the pulse width modulation signal for the servo motor to rotate. And here you can see that an analog pin at pin number, you can say, an analog pin is called at pin number, just edit. Here you can see that an analog pin is called, here you can edit, here you can see that an analog pin, here you can see that an analog pin is called at pin number 3, and whenever the reading at the analog pin is changed, the reading at the servo motor will observe the reading at the analog pin and give out a direction of motion, and the angle that is here you can, and give out a value. Here you can see that the value for the integer is defined by the function using the function map. Here you can see that in map the value of digital in here you can see that the value of analog input is given as 0 to 1023, and the motion of the servo motor is from 0 degree to 180 degree. Here when the value of the potential meter, you can say that it is to 55 or 555, it can take the servo motor to an angle of 90 degree. If the value of the potentiometer changes, the angle of the servo motor also changes, and the angle writing is done with the help of the function myServo, which was the element, and is done by the function dot write. And value is the variable which stores the value, that is done by this map function, so that it can give a value at which the motion of the servo motor has to take place, and at the value at which the servo motor has to stop. Okay, this was about the servo motor. Let's check about another. Let's just talk about the another program of the servo motor. Here you can see that in sweep, Sweep is a much easier program because it uses directly servo and let it to rotate from 180 degree to 0 degree and vice versa. It does not require a potentiometer for its operation. It's simple, connected to pin 9, then it uses a for loop for the variable position. Here you can see that the variable is increased from 0 to 180 degree with a 1 degree increment at every 15 millisecond. If it reaches 180 degree, then again even the position value increases to 180 degree, it is taken to 0 with a 1 degree decrement, and all the values of servo motor has been written by in the object servo motor by the right function as pos, and each degree has a difference of 15 millisecond. Well, these are the basics of the servo motor programming and servo motor, how to control it with Arduino. Well, this was the structure of the servo motor that we have talked here. It is using a simple motor, and there are some electronics behind it with a potentiometer, and these are the gear timers, and here a potentiometer is connected which gives the value at which the servo have to stop or at which the servo have to reach. This is done by the value correction has been done. The value correction is being done by the comparator which is pre-built in the servo motor, and the value for the signal input is taken with the help of Arduino, so that the Arduino can command the servo motor to get to a specific degree. These are the different types of servo motor, and here you can see that an AC servo motor, which is an industrial servo motor, which has a positional encoder rather than a potentiometer to give very precise values, so that it can perform very accurately. Here it is a similar servo motor that we have talked. It is called continuous servo motor because it can rotate to continuously 360 degree and can rotate to many turns. You can see that here. You can see here that it can rotate continuously. These are the special servo motors that do not have the pin that stops, that do not have the physical part that stops them from rotating continuously, and their potentiometer are of good quality so that they do not deteriorate the potentiometer while running to continuously 360 degrees. I think it is clear for us to get a complete knowledge of servo motor. If you have any doubt, please ask me. And otherwise, thanks for watching. Hello everyone, and welcome back to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about stepper motor. Well, a stepper motor is a special purpose computer motor that is used to run at specific degrees as well as for 360 degree motion. This is the most common motor which are used in CNC and are used in 3D printers and two-dimensional plotters. These are generally heavy industrial motors that can run heavy load as well as they can rotate in specified, you can say, 2 rotations or say 720 degree. It can also move to micro stepping so that it can move to 1/10th or 1/200th in many special motors of a degree. You can say that a stepper motor generally can rotate only about 200 steps out of 360. It makes one step about 1.8 degree. But if you use the micro stepping method to control the servo motor, it can move about 1/200th part of a degree, which can give a very bright clarification of the servo motor and can give very accurate results. Okay, about the stepper motor. The stepper motor comes out. The stepper motor comes in 2 variants. They are the unipolar motor such as this, and they are the bipolar motor such as this. There are only the difference of wiring. And you can say that a bipolar motor like this has 4 wires while a unipolar motor has 5 wires. These are the difference in polarities of the coil that are inserted in the servo motor for direction and motion. There are also hybrid motors that have 6 wires. They can run both as a unipolar as well as bipolar. Okay, let's just see a diagram so that we can get a clear understanding of what is a stepper motor. First of all, let's just get it from starting. Here you can see that the red part is in a magnet. In the 1, 2, 3 and the 4 there are numbers. They are the coils that activates by getting the value from the computer and get amplified by the driver, so that they can create a motion to the magnetic drive. Or you can see that the axle of the stepper motor is made out of magnet for giving it motion. Okay, this is the method for controlling a stepper motor. You can see that here in the diagram, whenever the pulsating clocks in a revolutionary whenever the array is called in a incrementing direction from 1 2 3 4, it gives a small value of motion to the rotor, and if it goes continuously like this and continuously motion, it can give continuous motion but very precise value. If we use microstopping, the value can be precise even more. Okay, servo motor and okay, stepper motor. There are also special type of stepper motor known as BLDC. As we have discussed earlier, there is same principle of working in BLDC motor. The main difference is the outer coil are replaced by permanent magnets, while the inner core is made up of pulsating magnetic coils, and they are controlled by high speed ESC, or you can say electronic speed controller, by microcontrollers, and they are of basically 32 bit to give high performance and high speed of values, so that they are used in quadcopters. Okay, about the wiring, let me give you an example of a stepper motor, both as unipolar like this and bipolar like this. You can see that this motor is bipolar because it has basically 4 wirings. That all goes to the driver. Here they are using a simple chip for the driver, or you can say signal amplification. The amplification power is getting by a 9-volt battery, and the signal for running a motor is getting by Arduino. Okay, while this function is very much similar to that is used in unipolar motor, it has a driver, and you can see that there are 5 wires coming out of the unipolar motor, and the power source. Here the power source is used by the Arduino, but for better performance the power source should be kept independent and protecting the motor from frying. Okay, you can see that there is the basic difference between the running of motor bipolar and unipolar is that they both run on different types of codes. Their coding is absolutely different, and they have a very similar motion. They can be used both for micro stepping, but their source code and their way of algorithm and programming is very different from each other. We are talking about bipolar motor. Mostly we are talking about the bipolar motors, because bipolar motor are the most common type of motor we are getting in interfacing and to get an operation done. In the further future chapter, we will be talking about wiring a stepper motor to Arduino and using with a driver to getting the signal amplified and running the stepper motor in the future chapters. Okay. The stepper motor library is already pre-installed in Arduino. The Arduino has built-in libraries for motion of servo motor as well as for stepper. Let's just see them. Here, going in menu, file, example, you can see when you go down, you can see the library designed for stepper. Well, here you can see that motor knob, 1 revolution, 1 step at a time, and speed control. Let's just see them. First of all, motor knob. Motor knob is a library that is used for running the motor, or you can say that it just defines the pin number in which the Arduino can be connected. Let's say 8, 9, 10, 11, and the variable there is steps. The steps is the variable which store the number of steps that has to be taken by the servo motor to reach a specified value. Here it is taking 200 steps. It means that the motor will rotate from 0 to 180 degree. You can manually change the steps as 50, 60 or whatever you wish. Now let's just see another program. Go to example and again go to stepper. You can say 1 revolution. 1 revolution is a small program which just says that the pin number the motor which is connected at the pin number 8, 9, 10, 11 will have to rotate all the 200 steps to get back to give a complete revolution motion and come back to its original position where it has been started. The motion can be tamed or can be controlled by controlling the speed. In this part we can see that the motion is having each step time difference has 500 millisecond or half second. You can also write them as 50 milliseconds so that the motor will run about 10 times faster than it. But you have to change the time direction of the board. You have to change the time value of both the variables so that it can give a clear rotation. If you change the value for 1, it means that the motor will have 200 revolution in 1 second, and after getting that it will rotate 10 times faster to get back to the initial position. So it is better to change the value of both the places so that you can have a smooth motion in both the direction. Another, let's just see it. The another part is motor one step at a time. This is a program that is mostly used for checking the step, and it is also used for getting the precise value of the stepper motor. This program is used for getting the stepper precise value such that you can get the interval of by the interval of one step. You can see that absolutely how much angle that the stepper motor has made from the previous to the present location. Actually it is 1.8 degree, but sometimes it can also change because of micro stepping. You can change 1.8 degree to 200 times clearer, or you can say you can divide it into 200 parts to get a better clarified value. Well, this method is used for controlling of the stepper motors that are used in 3D printers or CNC plotters, because they require a high level of accuracy, and for high level of accuracy the step degree should be very precise, so they are using micro stepping. We will be talking about micro stepping afterward, but let me give you a small glimpse about that. Stepping can be done in three parts. Let me show you. The difference. Okay, you can say that it is same as pulse width modulation. If the pulse is long, then it can give a degree, but if the pulse is very slow, or you can say that the duty cycle is very small, then it will give the value to move motor not 1 degree 1 point not it will not give the motor to move 1.8 degree, but it can also control to move motor to half of 1.8 degree, to 1/4 of 1.8 degree, and even the 200th part of 1.8 degree. For that process the micro stepping is used. I will be showing you diagram. Wait for a second. Here you can see that the example of micro stepping. This is a complete duty cycle that has been divided into 4 basic steps. You can say that each have a difference of 25% of duty cycle, but these steps can further be broken into small parts. Here you can say that this is the method. Here you can see that each part is broken into about 7 segments, so that it can give a value of 1/4 into 7, that will be given about 28. 1/28 the value of the stepping that should be done, so it can give a very precise step to be taken. The whole cycle is for 1.8 degree. At present it is able to give 1.8 by 28%. At present it is able to give 1.8 divided by 28, and that is the angle. The micro stepping is the most precise step that is the angle the most precise step can be taken by the help of a specified driver. But remember one thing, for micro stepping it is always used a 32-bit board as well as a 32-bit stepper driver to giving very fine values in industrial strength. In industrial hardware, all the stepper motors are being controlled by 32-bit ARM architecture microcontroller and 32-bit stepper driver, so that they can give a very fine precise value and they can run the operation at very high speeds. Okay, this was the theory about the stepper motor. Here you can see the Arduino, the wiring, the driver, the external source of battery, and the stepper motor. Here we have talked about the programs, and in future chapter we will be running a stepper motor for the practical purposes. If you have any question, please ask me, or else thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about running a DC motor with the help of an Arduino board and a driver. We cannot run a DC motor directly with the Arduino because a DC motor draws a large amount of current, and this current can easily fry the Arduino board even in your computer or laptop. So be careful while connecting the DC motor to the Arduino, because there should be no direct connection or there should be no leakage voltage in the board. So there should be no leakage voltage or current in the board which can directly flow to the computer or the Arduino, because it can really burn it severely and cause you a lot of damage. Okay, so protecting the Arduino from the motor, and having a good control of the motor, we need to connect it to a driver. A driver is a specifically designed machine which is used to perform the function of controlling a motor by the help of small digital signals that are provided by the Arduino, and by amplifying the signal with a built-in voltage source. Here we are connecting it here we are connecting it to a 12 volt source, so that the driver can amplify the signal. And for the control signal we are connecting it with Arduino, and the output of amplified signal and control signal is going to the motor. For that, we can select the direction of the motion as well as we can perform the speed variation of the motor. I have selected the analog pin for motion control and set it to very low, so that we can have a clear vision of the motor running. Okay, let me tell you about the diagram. Here it is the Arduino. It is coming out with three pins. It is coming out in the form of 3 pins. First pin is the analog pin, which is used to control the speed of the Arduino. Second and third pin are the digital pins, which are connected to digital pin 4 and 3 in Arduino, and are connected to the next 2 pins on the driver. The first 2 brackets are connected to a 12 volt, and the motor is connected to the output terminal. We can change the direction of the motor as we require by changing the pin number value from high to low. We cannot keep both the pin high or both the pin low, because it will create a zero potential difference between them, causing the motor to not rotate in any of the direction. For moving a motor, we can set one value high and another low to move in one direction, and we can change it as one more value low and another high to move it in another direction. Okay, let's just do a practical. Open Arduino, open a new sketch, and write here. First of all, we have to declare the pin. Write pin mode. Let's say pin number 3, output. We have done pin number 3 as output. Now again pin mode. MODE. Pin mode, say pin number 4 as output, because I have connected it to that pin. If you have connected it to another pins, please be careful while writing the pin numbers. Okay, now come to void loop. Write a simple program. Say digital, write pin number 3, HIGH, and we have to set pin number 4 as low. Okay, write in next line DIGITAL WRITE, digital, write pin number 4, LOW. Okay, just check the program. Pin mode 3 and 4 are declared as output. The board is connected to pin number 3 and 4. Digital, write pin 3 high, pin 4 low, and the motor is here. Wiring is going correctly in the. Please check the wiring, because it can severely damage the microcontroller if a wrong wiring is done at high voltages. Okay, let's just compile it. We are compiling it. Okay, just cancel it. Come here. It's compiling. Just wait a second. Okay, there are no compilation errors. Go to upload and upload the board values. Okay, the board is uploaded, and you can see the motor is rotating in one direction. If you want to change the direction of motion, please go here. Say the pin number 3 as LO. We are doing an experiment. Both pin number 3 and 4 are set as low. Now check it. Can the motor rotate on both low? Well, you can see that the motor has stopped working. Now say this low and 4 number pin as high, HIGH. Again upload it to the board. Now you can see that the motor is rotating in another direction. Well, this is the motor for this is the method for controlling the direction of motor. But if you want to see it on the screen, let's just write a simple program. First of all, I have to stop the motor. For that, it will not create any disturbance in our programming. I had to stop the motor. Now, if you want to see the direction of the motor, it is good for us to get a clear view by using it in getting the direction in serial monitor. Write serial.begin, serial.begin. Write 9600 for the baud rate. We have given it 9600. For that function, make a simple statement. You can say that this is another form of if statement. Okay, let's just do it. It is taking a second. Wait, stop. Okay, come back to programming. Right here, clockwise serial serial dot println for the next line. Okay, write it clockwise. Okay, we have done that. Set one pin to high. I am setting pin number 3. Now upload it to the board. Cancel it. I am cancelling it. You can save it as you want. Now see the direction of the motor. I think that's clockwise. Set it. It's going clockwise. But what if we want to rotate it for 10 seconds clockwise and 10 seconds anti-clockwise? Well, there is a method for it. First of all, let me stop the motor. I will show you the method. I am stopping the motor. It is taking some time. Okay, and it stops. There is a very simple method to rotate the motor in both the direction. Just come here. If you want to rotate the motor in one direction for 10 seconds, write the program delay, delay, let's say 10 seconds. Okay, stop it. Now come here, write digitalwrite, digital write pin number 3 SLOW, comma, digital write WRITE DIGITL, my mistake, digital write 4, comma, HIGH, high. Come here. You can say that this is high for that moment for 10 seconds, and it will be rotating in another direction for another 10 seconds. SERIAL dot println. You can say it counter clockwise. Okay, counter clockwise. Terminate the line and write DELAY, delay of 10 seconds. Let's say 10 seconds. 1 2 3 4 values. Okay. Now I'm keeping the motor for your understanding. Uploading the program, and let's save it. DC motor, and say running. Okay, saving the program. You can download all the programs at the starting of the module. In there you can get the program. Okay, it's taking some time. Okay, let's just open the serial monitor. Let me open it once again. Now you can see clockwise for next 10 seconds. It's running continuously. Just wait for the second to come, and you can see that it's rotating in another direction. Well, by this method you can control the motor in both the direction, and you can get the value of clockwise and counterclockwise by changing the polarity. You can say that it's changed once again. Okay, well, that's all for this video. If you have any doubts, please ask me, and if you have any doubts, please ask me, and thanks for watching. Well, hello and welcome back to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about controlling a servo motor. Well, a servo motor is a special type of electrical motor that is used to give a precise degree of value. It is not used to give a continuous rotation. Well, to connect a servo motor to an Arduino, it is very simple. Just you can do it by connecting the yellow wire to signal, the red wire to 5 volt. You can connect it by connecting yellow wire to signal, or you can see the pin which we have defined for controlling the servo. volt wire will be connected to red wire will be connected to 5-volt output, and the ground wire should be connected to the ground terminal of the Arduino. Yeah, it is good for running small motors, but if we are using big servos, then it is necessary to give them individual power supply. Okay, now let's just begin it with completing a code. Okay, come here. Here is a code that is a library is always a good library for controlling servo motor is available in the Arduino, but we want to write our own code, so we can do that. First of all, go here at the top, include. We are calling the library. We are calling the library by writing include include. Include. It will change the color. It means includes servo.h. Let's just check it. Include give servo.h. H is the extension for C file. Okay, now here write servo servo is equal to give it a name my servo, or you can just say my. That is good. We are giving name my. Okay, now in void setup we have to define the positions that should be in my servo. Go to the top, we need to declare an integer for the value storing of the angle that should be taken by the stepper motor. We are declaring int angle. Angle is not possible, so let's just say deg. Into deg, it means degree. Okay, is equal to 0. Is equal to 0. Now come here, set my, write my dot attach. We are defining servo at pin number 3, so we are calling my.attach pin number 3. So the servo is connected at pin number 3. Now it is very simple to control the motor for 30 to at a fixed location of 30 degree. Simply write my.write my.write say 30. I will be using a variable, but right now I am just trying to do it as simply as possible. Okay, the last program is running on servo. Just hold on a second. Equal to symbol should be removed from here. I am declaring. Now upload it. Here we have to define my before void setup. Okay, come here, cut it right here. Okay, let's just upload it. We have written it 2 times. Okay, my mistake. Let's just return it. It's compiling for a second. Just wait for a second. It will do it. And the servo has been taken the position of 30 degree. Let's just change it to 40 degree. Okay, it changes the value. Now let's just take it to 90 degree. Not 490, it should be 90. It's taking the position 90. Let's just say 0 degree. Okay, let's just say 180 degree. That is the last value that can be defined using the servo. Okay, but what would happen if we try to move it? If we try to move it, it is not possible to move it because it is locked at the position. Okay, but if we want to see the motion of servo very slowly, you can just go to files, open example, go to servo, go to sweep, Now here select the pin as pin number 3. For me it's pin number 3. You can select any analog pin which you had connected to Arduino. First of all, let me explain the code. First of all, we have called the library. Then we have defined the object servo as my servo. Next we have defined a position for it, and it is initialized with 0. Next my servo dot attach. It is declaring the pin that is taken as signal pin. That is pin number 3 for my case. And in void loop we have written a program for loop. For position is equal to 0 less than 180 degree, position should increment by one step in every 15 millisecond, and the step that is incremented should be written as the position for the servo motor. And the same happens when the position reaches 180 degree and it is greater than 0, then it will decrement with every 15 millisecond, and the position will be written in the servo motor as angle. Let's just upload it to the board. It's compiling, wait for a second. Now you can see the motion of the servo motor. It's happening. This is the motor of this is the method of controlling a servo motor. You can write it manually, you can call it a program, give it a logical function, or if you want you can just test it. You can just test the servo motor by this method. Well, this was the video tutorial on controlling the servo motor. Keep in mind, for running heavy servos it is better to give them individual power supply, connecting the power supply to the ground of the microcontroller board, than using them. If we connect a heavy servo directly to the microcontroller, it can damage the microcontroller as well as the computer. Okay, keep the program safe, and if you have any doubt please ask me, and then thanks for watching. Hello everyone, and welcome to another module of Mastering Arduino from Beginner to Core Advanced. In this module we are talking about sensors. This is module 6. Okay, let's just check the content, and the content we have is introduction to sensor, what is sensor, type of sensor, potentiometer, piezoelectric sensor, temperature sensor, and PIR sensor. We will be doing experiment on the on the last 4 sensors, and all other will be theory. Okay, let's just come to the first part. What is sensor? Well, a sensor can be said as anything that is taking as an input from the environment and giving it an output to the system which is connected to it, which is used to record the change in the environment, is called the sensor. Well, this was the technical definition. You can say simply a sensor is a machine that is connected to a system which is used to give any specific changes in the environment to the machine, its detail. It can be said that if a sensor is connected to environment, if the temperature rises and it is a temperature sensor, then the sensor will say that the temperature has been has going up from 35 degrees Celsius to 45 degrees Celsius. It can be a humidity sensor which is saying that the humidity is increasing or decreasing with the time. And well, all this about the sensors, but the basic thing is that the sensors are the device that are taking data in the form of inputs. Remember one thing, that sensors are only of 2 types. They are analog sensors and digital sensors. In the real world or in the physical world, all the signals are analog, but the computers have built in analog to digital converters, which converts the analog signals into digital signals, because computers cannot understand the analog values. So for the sensors, it is required that they can give only 2 values, analog values, such as a multimeter which gives the value of a voltage such as 35 voltage, 45 voltage, or 120 voltage, while a simple sensor such as a PIR sensor or a presence detection sensor can give only 2 values, such as someone is in, which makes the values high or 1, or someone is not present, which gives the value low, or you can say 0. This was the basic thing about the sensor. And there are very high-tech sensors also. Let's just check about the Wikipedia. What does it say about the sensor? Well, Wikipedia have a very technical definition about the sensor, that it is a part of a subsystem that is used to process the data and give the environmental changes value to the machine. Well, the sensors can be very simple, such as a simple transistor for a temperature sensor, or can be extremely complicated, such as a camera or a LiDAR sensor. Okay, this was the definition for the sensor. Let's just see the different type of sensor. I have made a simple chart for your understanding. Here you can see that all the values from 0 to 1023 for 10-bit encoders. Remember one thing, encoder can be very high, they can be 32-bit, 64-bit. For our sake of convenience, we are using 10-bit encoders because it is present in Arduino. It can be even very high, it can be 2 raised to 20 or 2 raised to 32-bit encoder for very fine and very precise knowledge for the sensor input and outputs. Okay, for the input values it can be 500, it can be 750, it can be 0, it can be anything from 0 to 1023. So it gives a physical precise measured value, while for a sensor, for a digital sensor, it can be only a 0 or it can be only a 1. There are no other values possible in sensors. So sensors are of two types, they are analog sensors and digital sensors. For example, the camera that we use takes the values of the physical world in the form of digital signal and send it to the computer. The camera works on inter-I2C connection or I2C protocol. We will be discussing in the later chapter. This was the function of camera. It has a sensor. The camera is itself called a sensor because it has a photo dot on it, and the photo dot takes the light and gives it a grid value, forming a giant matrix, and the matrix gives the values for the color. It can be RGB, red, green, blue, and taking the value from it, it gives the image of the picture on the screen. Okay, about the sensors, all sensors are input, and there are some examples such as solar panel. You say that solar panel is a device that is used for generating electricity, but the first and the most important use of solar panel is to detect light. In heavy sensor where it requires a precise values, they using for the light values, always solar panel are used because they give a very precise value. And sensors are also of two types. First, sensors are of active type and the second are of passive type. In the active type, you can see that the sensor that does not require voltages or current to run them are called active sensors, such as solar panel, because it does not require any external power source to run it. While a passive sensor, you can say every sensor is another example of passive sensor. You can say temperature sensor transistor, such as LM35 requires 5 volt input for its working. So they are called passive sensors because they are taking power. So active sensors are good, but most of the sensors that we will encounter in the physical world are always passive sensors because they have very precise value and they do not depend on the external conditions for their voltages, so they give a very precise value. Okay, about the lidar. Lidar is a type of sensor that is used to emit as light. That is used to basically the function of the lidar is to measure the distance. So it has two parts. Let me draw it for you. Here we are coming down, just wait for a second, and yeah, you can see that here is an example of a lidar. My drawing is not good, sorry for that. Lidar is like this, a rectangle box. It's not rectangle, I know. It has two lights, or you can say two devices. First function is to emit light, and that will collide to some object, and then it will come back to the another part so that it can read that light is coming, and taking a time interval in the processing unit. It is taking the pulse width modulation of the sensor, that the pulse that has been set at 0 degree receives at 30 degree. So there is a small algorithm which says that for 30 degree the distance is 45 meter, and which by this method it gives the value to another microcontroller or computer to which it is connected. This was the theory of lidar. So I have to tell you that all the sensors are input sensor, but there are some type of sensors, there are also such as output sensors such as lidars, because these lidars give the first of all they emit the light, so they give a value as an output, and when the light strikes to a solid surface it comes back to the sensor, so the sensor reads it one again. So this time it becomes an active sensor with a theory that it emits light such as an in the form of output, and reads the light in the form of an input, and that gives the value to the microcontroller, process it with the help of an advanced algorithm, and give the value of the distance. These are very high-tech sensors because they are also enabled to calculate the speed of light. A simple example of a lidar sensor is ultrasonic sensor, very cheap if you want to do experiment. Well, ultrasonic sensor is not a lidar sensor, but it works on a similar principle. Let me explain it to you. This is an ultrasonic sensor. You can see here it has the same functionality as a lidar, but it uses ultrasonic waves. This point emits the ultrasonic waves, and when it strikes to a substance, it will be read by this module, and this both are doing, there is a chip behind them that uses the algorithm to compare the time interval between them to find the distance. Because of this, because it's very cheap, because the speed of ultrasound is very low, something about 360 to 400 meter per second, so it is very easy for a simple microcontroller or simple processing chip to calculate the distance. So ultrasonic sensors are very cheap, but there are very high end ultrasonic sensors also available, and we will be discussing them about in the future. This was the example of an ultrasonic sensor that is used to measure the distance. We have lidar, but we can use ultrasonic sensors for small distance up to 4 meter, while a lidar is used to measure distance from 15 centimeter to about 80 meters. Well, they say it's 40 meter, but if we hack them, the sensor can give the value up to 80 meters also. And there are also some high-tech lidar sensors that can range the value up to 30 kilometers. They are used by mostly militaries for their operations to measure the distance between the mountains and other positions to give them the value for their post and other physical values. Okay, this was the theory of the sensor. If you have any question, you can ask me, and if you want to know the detail, you can just ask me the question, or else. Thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial, we are here at module 6. In module 6 we are discussing about what are sensors and how sensors are useful in Arduino and other environments. Okay, first of all, let's just get to the content. The content is as follows: introduction to sensor, what is a sensor, then after we will be knowing about the type of the sensors that we use, about the potentiometer. Well, potentiometer is not a sensor, but it is the most common thing to get to understand this, what is about a sensor. Then we will be talking about the piezoelectric sensor, then we are talking about the temperature sensor, and at the end we will be talking about the PIR or passive infrared radar sensor. We will be talking about passive infrared sensor. Okay, let's just get started. Introduction to sensor. A sensor is a device whose function is to detect the changes in the environment and give a specific output to the user or the device. Well, you can say that if the temperature is 37 degree and a heat sensor is placed in the room, and if the temperature changes to 37 to 39 degree, it will show that there is a rise in temperature, and that is about 2 degree. Well, it is easy to talk, but how does the microcontroller or any other computer system get the knowledge of the temperature change? Well, this is the method of interfacing the sensor with the system by the help of programming and with the help of GPIO pins that are placed on the microcontroller boards. Okay, well, and sensors, about the sensors are, I will say that sensors are used in various technologies such as in robotics, as in automated cars. It can be used in industries. Well, they are the mostly used in industries. For example, the camera which we are using here is also a type of sensors, because it is changing, because it is recording something, the changing environment, and it is giving a feedback. Okay, but there are different type of sensors. We can talk about the piezoelectric sensors, a temperature sensor, humidity sensor, or we can say about PIR sensor. But we are going to deal with the most basic to the most advanced type of sensor that we are discussing. Sensors can be generally classified only on about two types. They are analog sensors or digital sensors. Analog sensors are the sensors which are similar to a potentiometer, or you can say that they give a measured value, while the digital sensors are the sensors that can give only two type of value, that is 1 or 0. It can give us only the state is high or state is low, while an analog sensor can give us the value quite different, such as 335, 336 or 590, etc. In this chapter we will be going to In this chapter we are going to learn that in Arduino there is only a possible analog to digital converter that has a range of 0 to 2 raised to 10 minus 1, or you can say that 0 to 1023. So the range of the sensor is set as that, as follows, so that it can get read about it. Well, about the another type of the only another classification of the sensor is called as active classification or passive classification. A sensor can be active sensor or a sensor can be passive sensor. Active sensors are the sensors that does not require external power supply to operate them. Example, you can say a solar cell. A solar cell can be used as a very fine sensor for detecting the presence of light in a room. It is also used for transmission of audio signals from one place to another. I will be telling you afterwards about that. And a passive sensor is a sensor that need external power to operate, such as a temperature sensor. A temperature sensor is a device which needs a power as an input. Well, here you can see that this is a temperature sensor that gives the value in the form of measurement. You can measure the temperature outside it by using a library which is specially dedicated to this temperature sensor, and the main function of the library is to calculate all the environment variables and give it an suitable and take the main function of the library to take the analog value, give it as an input for the function, multiply or do the mathematical calculation out of it, and give the value output as the exact value for the temperature outside. Well, these are the analog sensors. While the digital sensor can be very simple, which can be seen in the case as the PIR or passive infrared sensor. Passive infrared sensor are using for reading the presence of a human in the range, but they do not detect the value of the presence, such as they cannot give an output as the measurement, so they give the value in the form of ones or zeros, or you can say that low signal if no human is present and signal high if the human is present there. Okay. Well, on Wikipedia there is a very beautiful definition of sensor is given, where you can read that a sensor is a device whose function is to detect the change in the environment and give it as an output to the microcontroller or the system in which it is connected. It can give a value of 0 to 1, or it can give an analog value. Well, the sensor of different type we know today here are the sensor that we know today are that detect light, they can detect temperature, they can detect humidity, they can even detect the pressure. Moreover, it is saying that there is always a sensor for everything. It means that you can use a sensor or a group of sensors to make a new type of sensor or a new type of device into it. Sensors has a basic application in many fields such as machinery, aeroplane, aerospace, car, medicine, robotics, and all other day-to-day lives. Even our mobile phone contains 2 to 3 sensors such as gyroscope, accelerometer, and there is a small sensor at the camera that detects the presence of human ear for giving a better performance of the audio quality. Basically, sensor can be anything, and you can read here. You can see here. This is an infrared sensor. When an object come in, this is an infrared sensor. When an object come in front of it, it gives a value of high. While when object there is no, while when there is no object in front of it, it gives a value of low. You can say that this is also sensor, but this is an example of digital sensor. It cannot give the distance of the measurement that has been taken here. In the main sensor, we will be talking about both analog and digital sensor, how to use them, and the most important thing is that how to use them in logic, how to get a specific type of logical requirement that we need here, how to get to perform a specific logical operation with the help of sensors, such as running a motor, brightening an LED. All this we are going to talk about them in further videos. Right now this was the introduction of sensor. Thank you. If you have any Right now this was the introduction of the sensor. If you have any question, please ask me, or else thanks for watching. Hello everyone, and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this topic we are going to discuss about potentiometer. Well, a potentiometer is a voltage dividing device, but it can be also used as a sensor to measure the potential difference across the lines. Just talk about potentiometer. A potentiometer is a 3-terminal device with a rotating dial on it, which works as a potential divider. You can see that on the 3 legs, the third leg is for 5 volt input, and the middle leg is connected to the pin which is set as analog to sense the voltage difference. Well, this is the basic pin diagram of the potentiometer. It has international symbol as this one, and the Canadian and US symbol as a zigzag line with an arrow. Let's just get a brief description about the sensors. Okay, on Wikipedia there is a beautiful page which tells about the sensor. It says that it is a 3-terminal device with a rotating dial on it, which can be used as a voltage divider, as well as it can be used as a device to sense the voltage difference across the terminals. Okay, here you can find different type of a potentiometer, and this is the basic working of it. It is the fixed position. It has two basic moving parts. First one is a fixed contact, and second one is a moving contact with a high resistance wire placed on it. When the dial is rotated, the distance between the fixed terminal and the moving terminal increases, and as the distance increases due to the Ohm's law, and due to the Ohm's law, the resistance between the points increases. Because of that, the potential difference between them decreases. Well, this was the basic working principle of the potentiometer, and it contains nichrome wire for the resistive material, while there are different types of sensors that can be used here, which uses graphite or other heavy materials for the resistivity element. Sensors can be simply rotating dial like this one. You can see that here I am rotating the dial. Well, but how to get it connected to the Arduino? I have shown you in the previous video, but I want to tell you here about the potential difference that has been created by the Arduino. For that, just go to Arduino files, go to basics, and select the first option, that is analog read serial. In analog read serial, you can see here in void setup, it is calling the serial monitor. Well, that's it. In the void loop, it is first calling the pin A0. Well, for my configuration, I have connected it to the pin number 3 of the Arduino, and in serial print, it is calling the sensor value, or you can see that what is the analog to digital value that has been taken by the sensor. Let's just upload it to the board. It's taking some time, and it's uploaded to the board. Now open the serial monitor. We have opened it, and here you can say that it's giving a value. Now just rotate the dial. Let me correct myself, there is some wiring mistake. Okay, let's just perform an experiment. First open Arduino, go to file, select examples, and go to basics, select the first option, that is analog read serial. Okay, in void setup, it has called the serial monitor with a baud rate of 9600, and in void loop, it is saying that the integer has given a sensor value variable which will be storing the value of the integer, and it is reading analog read pin A0. Here it is reading the value, and the potentiometer has been connected to one pin to ground, one pin to positive, and one pin to analog pin 0. After that, it will be printing the value as a variable sensor value, which will be showing the value of what the analog read has been done, and with a delay of 1 millisecond. Okay, let's just upload it to the board. It's uploading, taking some time, and upload is done. Okay, let's just see the serial monitor, and it's giving a value of 693 and 4. Okay, let's just rotate the dial 0, and it's going to 1023. Let me make a clear expression of it. We are going to 0, we are going to 1023. Let's just make it in a between. It is giving 671. After rotating a few turns more, I am getting 392, 458. By this way, we can control the potentiometer, and this is the method which is telling us what is the value of the analog to digital converter. But if you want to get the potential out of it, there is a simple method. Just go here, and you can say that store a value in another integer. Go here, write an integer int volt, integer voltage has been declared, and give voltage a calculation. SENSOR VALUE sensor value is equal to declare the integer volt and take it value as sensor integer, give it a multiply. We are giving it a multiply and then giving to curly bracket, write the formula 5 divided by 1023, where 1023 is the maximum value and 5 is the maximum voltage. So here the value of volt will be storing sensor multiply by in bracket 5 divided by 1023. Okay, right here voltages VOLT. Okay, voltage is written here and it is taking the value within 1 millisecond. Okay, let's just compile it for checking. It's giving me an error. It is saying me the voltage that is defined here. My mistake, I have not terminated the line. Okay, terminating it, again giving it a compilation. Compiling is done properly. Now upload it to the board. We have uploaded it successfully. Open the serial monitor and we can read the voltage, that is 0. Turn the dial. Okay, there is a mistake done by me, that is the value of the voltage should not be an integer because it is taking values that are out of decimal, so we should be giving it a FLOAT float so that it can read the values in decimal. Okay, upload it to the board. We are uploading it and now let's just see the value. It's reading in double values. Okay, let's just turn the dial. There's some wiring mistake, I am just going to correct it within a second. Okay, let's just come here. First of all, let's just see the syntax. First of all, we have called serial monitor in void setup, and in void loop we have taken a pin to read the sensor value, analog value at pin A0. After that we had given a formula, that is for volt sensor value that will be equal to 5 divided by 1023 into multiplication of sensor value. Okay, it will after the calculation it will give the value for the voltages here. Okay, let's just try to compile it. It's clear, no issue. Let's just upload it to the board. We have successfully uploaded it. Now just open the serial monitor and you can see a value here. Now let's just change the value. 0. It's giving me a voltage of 1.43, 2.45 or 44. Okay, no issue. Giving a maximum value of 5. Again changes to something 3.62. By this method, a potentiometer can be used to read the voltage across the line. Well, it is not a sensor, but it is a best example to declare. It is the best example to explain about the analog sensor values that have been read here. That we will be reading in future. Okay, if you have any questions, please ask me, or else thanks for watching. And welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial, we are going to talk about piezoelectricity or piezoelectric sensor. Well, piezoelectric sensors are the special type of sensor. When they are pressed, they will generate a voltage. This is because of the electromechanical stress or strain that has been happening on the crystals, so it generates a voltage across the two plates that are connected to it. In here you can see that this is a piezoelectric sensor, and here is the first plate. In between there is a material, and outer plate is there which has been soldered by me. Well, the piezoelectricity is very important for defining when piezoelectricity is a very important effect for using in sensors, because it is used to generate pressure, because it is used to measure or sense the pressure difference, or you can say the rapid force that are applied to anything. Piezoelectricity has a special effects. Piezoelectricity has been used in special sensors such as load sensors, because as the load is applied on the sensors, because of the mechanical strain, the voltage reading across the load changes, so they are useful in many conditions. Here you can see that in the diagram, when the piezoelectric sensor is pressed, a voltage is generated. Let us see a simple documentation of it. Let us see a single documentation Let us see a simple documentation of it at Wikipedia. I have found something. It is saying that when the piezoelectric sensors are applied, when the force is applied on the piezoelectric sensor, because of the crystal structure of the material that is been used inside it, it can be generally a ceramic or another crystal substance. When the force is applied on it, because of the mechanical stress, the internal structure of the substance changes, and this creates a potential difference across its surfaces, and this generates a voltage difference. Piezoelectricity and piezoelectric sensors have been used in many applications, such as in piezoelectric microphones, generation of electrical frequency, making microbalances, and most important thing of piezoelectric sensor is used in ultrasonic sensors. Let me show you. Here you see that these sensors, they are all based on the piezoelectricity They are all based on piezoelectricity. You can see that the cylindrical object has inside a piezoelectric component, that when electricity is applied on it, it gives the reverse of piezoelectric effect, as when the electricity is applied on the ceramics, it generates vibrations, and these vibrations are used to generate ultrasound waves. As the same at the other side, you can see that there is also a cylinder. When the frequency strikes on substance and reflects back to the other sensor, due to the frequency generated on it, it generates voltage. And by calculating the speed of ultrasonic wave and the time difference between them, it can detect the distances. This is a very important sensor here. Now just wait a second. Now here we are going to do an experiment on piezoelectric sensor. Well, there are two methods to get the piezoelectric sensor. First is by reading a digital value, but there is a problem, because when I connected the piezoelectric sensor to a multimeter, it is already generating some garbage values, and this can clearly cause an error in the reading of piezoelectric sensor with the method of digital read. So I have just used the method of analog read, because in analog read you can get a clear value of measurement of what is going across it, and you can get a value of voltage. Just go to a file, select example, go to basics, select analog read voltages. I have selected it. Just a minute. Okay, we are connected it. We are connecting two pins. First pin to the ground and another pin to analog pin A0. You can connect any pin to anywhere, but let me correct it. I am connecting it. First pin, black one, to ground, and red one to analog 0. Wait a second. Well, I have connected it. Okay, I am going to upload the code to it, and the code is uploading. There is a problem on the board, so I reconnected it. Now I am uploading the code. It's uploading, and you can see that it has been uploaded. Open the serial monitor, and you can see the garbage values that has been generated on the sensor. Okay, now go to the sensor and keep your finger on it and press it. You can see the voltage. When I press it, it generates a voltage of 5 volt. Again, you can see it. It's giving some garbage values. It is getting down by a second. After that, the mechanical force has been displaced completely. Within a few seconds, the value of the voltage goes back to 0. Again, I am going to press it to show you. Whenever I press it, it generates a lot of stray voltage. Or you can say that it generates a potential difference across these plates, which can be sensed by the Arduino. Okay, you can see that I am going again to pressing it. I am again going to press it. Okay, you can see here, whenever I press it, it goes to straight 5 volt. Okay, by this method we can use the piezoelectric sensor in many devices, and we can use it to perform another logical operations. By the help of microcontroller, we can define a logical program to it, and we can get another functions from it, such as whenever someone applies a foot on the sensor, you can connect it to a microcontroller and set is to make a buzzer. Whenever someone presses it, the microcontroller will order the buzzer to sound. So whenever someone is entering your room, whenever he presses the sensor, the buzzer will create a loud sound. By this method, by this logical operation, which is written by a program that is written on Arduino. If you wanna do it, I am going to check I am giving a function. Just wait a second. I am connecting the LED to the Arduino to make a small function of it. Here we are going to perform a logical operation with the help of a piezoelectric sensor as an input to the microcontroller. The microcontroller will perform a logic and a LED is connected to pin number 2 to give its output. Okay, we are setting such that whenever the voltage across the piezoelectric sensors goes high above 3 voltages, the LED at the pin number 2 will blink. Okay, we are going to write the program. See the screen, we are going to write it here. First of all, define the pin of the sensor. Say pin mode. Just a minute, connect it. PINMODE. PINMODE, pin mode. Say pin number 2 as output. Okay, we have set pin number 2 as output. Come down here. Give a simple if statement. If, say voltage VOLTAGE, voltage greater than 3, give the statement DIGITALWRITE, digital write, pin number 2 will be high, HIGH. You can see that, but it should be high for a few seconds so that we can see it. Say delay, say 100 millisecond. It will be making the program much more clear. Okay, just upload it to the board. It's compiling and uploading. Well, the upload has been done successfully. Go to the serial monitor so that we can get a clear option. Okay, you can see that it's above 3 volts, so it's giving an output as LED high. Again, we are waiting for it to go down. Just wait for a second. It's going down. Wait for a second. We can see it. Okay, let's just change the value from 3 to 5. It will be giving us a better precision of the system. For the system, it will be giving us a better precision value. Okay, let's just see it. Whenever I press, it's saying above 5 volt. It is not possible. Say above 4.5. It's let's just take it. It's float, so it can read 4.5. Apply the program on the board. Okay, just open the serial monitor and press. You can see that whenever the 5 volt happens, it begins to blow. Just wait for it to go down. It will take 100 milliseconds to stop. Oh, we have not put the else statement. Okay, go here, write else, give two brackets, write DIGITALWRITE, because not writing the else statement, it's becoming high for the permanent. We have to make it low also, so we are going to make it low. Write 2 is equal to low in the else statement, upload it to the board, and now see it. Uploading program. Wait for a second. Okay, go here in the serial monitor. Again, you can see it. Whenever it will go below 4.5, it will begin to stop. The LED will stop. You can see here. Once more, let's just do it. Wait for a second. It's going down. And you can see it, the system is working. So by this way you can use a piezoelectric sensor to perform an activity and write a simple program of it to get an operation such as LED high, or you can also place a buzzer in place of it to giving you more a visual sound, to give you a sound alert. Okay, I am going to save this code, and you can find the code with the PDF of the document. You can use it for your own design, and you can edit it and you can write it as per your wishes. Okay, if you have any questions you can ask me. Otherwise, thanks for watching. Hello everyone, welcome to another tutorial of mastering Arduino from beginner to core advanced. And today we are going to talk about temperature sensor. Well, what is a temperature sensor? A temperature sensor is a device that is used to measure the temperature across the environment or the object which is in contact with it and give a voltage difference across the terminals of the Arduino. The voltage difference here are also given in the form of analog signals because for the precise voltage it is not possible to take the signals in form of digital read. So we are taking the sensor reading in the form of analog signals. Okay, let's just talk about the temperature sensor. Here we have connected here the temperature sensor named as LM35. LM35 is made by Texas Instruments and it is a transistor and which have a voltage linearity. It means you can say that whenever the voltage is applied across it will be showing you whenever a voltage is applied across it, and whenever a temperature is increased across the frame of the sensor, it will give a voltage difference across its middle terminal. And we have connected the middle terminal to analog read of Arduino, so it will give a temperature difference, and by having a small calculation you can get that there is a temperature difference within the atmosphere, or you can get the temperature of the environment. Okay, let's just see about the sensor. Here it's datasheet. I will be giving you the datasheet along with the PDF of the course. Okay, let's just see. Well, first of all about the datasheet. A datasheet is a special type of document that is prepared for the with the a datasheet, a special type of document that gives the complete description of the electronic component about its physical dimensions, its mechanical strength, stress, capabilities, and the maximum voltage or current it can take. All these data are given in a specific document, and that document is known as a datasheet. Here you can see that I have taken a datasheet from Texas Instruments about the LM35 sensor. It is a linear voltage device, and you can see that here are the physical dimensions of it, and we are taking about the LP package 3-pin TO92. This is the sensor that we are using here. Okay, these are its mechanical stress, strain capacities, its mechanical parameters as well as its electrical parameters and working differences at other temperatures. You can see that here it has been giving operations at the pins and how to connect it. All the features are given in the datasheet. A datasheet is given by the company that had made the sensor. That gives the electronic engineer a complete knowledge about the sensor or the electronic component that he is using and how to use it or how to get the information out of it. So a datasheet reading is very important for the engineers to get a complete brief knowledge of the sensor or the electronic device. Okay, here its working temperature is minus 55 degrees Celsius to 150 degrees Celsius. Okay, let's just try to connect it to get a voltage reading. It's simply open the Arduino board, go to edit, go to examples, and go to analog read voltage for getting the voltage difference to you. We have connected it to analog pin A0 and wiring is as per the PPT. You can see that the first terminal is connected to 5 volts, the last terminal is connected to ground, and the middle terminal is connected to analog pin A0. Let's just see it in the Arduino voltage sketch. Upload it to the board. It's taking some time, and it is taking some time and it's uploaded on the board. Okay, let's just see what is the voltage across it. At present it is 23 or 24. Okay, when I touch the sensor the voltage changes continuously as I am touching because my hands are warm. Whenever I touches the sensor is going to increase its temperature. So as per the temperature linear coefficient, the value of the voltage across the terminal increases, so the analog read can read high temperatures across this. Okay, that is for the reading of the voltage. But how can we read the temperature? I have found a beautiful code here. Here you can see that it is exactly similar to analog read. Well, we are going to do it in the analog read also. Multiply the value. Okay, see here. This is the code that I have written. First of all, they are defining an integer First of all, we are going to define an integer as VAL for value. In serial begin 9600 for the operations. Analog will read A0 because this is the pin we have connected for the sensor, and it is the equation down here. For the value MV, we are going to val divided by 1024 into 5000. And for CEL, we are going to divide MV by 10. Okay, for Celsius, and for Fahrenheit you can multiply the CEL into 9 divided by 5 and plus 42. Okay, just get the value for CEL here. I am going to upload it to the microcontroller, and we are giving a difference of 100 for better understanding or for quick operations. It's uploading. Wait for a second. It's uploaded successfully on the board. Now you can see the temperature, and whenever I touch it, the temperature changes. I am going to do a practical operation. I am going to put a matchstick around it. Wait for 1 second. You can see that the temperature is rising continuously. Please be careful while doing the operation, because it can fry the sensor if you have taken the matchstick for longer times. And for reading the Fahrenheit, let's just do a small change in the code. Where the CEL written, go there and write FARH for Fahrenheit, because the Fahrenheit here is the variable that shows the value for Fahrenheit. As per the calculations of CEL, multiply by 9 divided by 5 plus 32. Okay, let's just upload it to the board. And okay, let's just see it. Here you can see that the temperature is okay. Just a mistake, it's not. I will be doing F for Fahrenheit, uploading it to the board. Okay, you can see that there is 89, 90 or 88 degree Fahrenheit, and whenever I touch it, the Fahrenheit values changes. Okay, but what we have to do a logical operation to it. I will be including logical operations from here for getting a brief information or brief technical knowledge of the program and how does the program work. Okay, go to here in void setup, write just a minute, write PINMODE, pin mode. We are going to collect an LED at pin number 2 and set it as output. We have set it at output. Terminate the line, come here, and I am going to select the value CEL for my understanding. That is good. Go down, write the if statement. If the CEL greater than say 32, the digital write LED will be high. Just a second, DIGITAL WRITE capital as per the syntax 2, and it's important to keep it also as an else statement, because without else you cannot turn off the LED. Give statement, write digital write 2, LOW. Okay, terminate the line and just upload it to the board. Wait for a second, I am going to connect an LED. Okay, here you can see that I have connected an LED to LED pin 5. Just see here. Okay, I have connected an LED to LED pin 2. Okay, we are going to upload the code and give it a name as TEMPERATURESENSOR. You can find the code at the beginning of the module for your practical purposes, or if you want to do an experiment. I have made a small error here. The P is capital and we want the P to be small. Okay, now upload it to the board. It's uploading. Just wait for a second. Okay, the upload has been successful. Okay, go here and let's just see. The temperature is 23 degrees Celsius. Whenever I am putting my hand on the sensor, the temperature keeps rising, and whenever it rises about 32, I am going to change this from 32 to 30 for quick operations. Okay, we have set it to 30. Again we are going to upload it, and the sketch is being uploaded. Now open the serial monitor once again, and I am putting my hand on the sensor so the temperature becomes high, and let's just make it about 29. Now let's just see it. Well, you can, it is a better practice to set the values as per your precision, because it will help you in many sensor calibrations. I have calibrated it to 29 degrees Celsius. The word F is written here by syntax mistakes. I will be correcting it. There are two mistakes here. First of all, I am going to write C for this, and the light will be glowing for next 100 milliseconds. To keep the program stable and give us a visible operation. I am uploading it. You can see here it's uploaded. Wait for a second. Open the serial monitor. Now connect your finger here. Just a minute. There was some loose wiring. I have corrected it. Now whenever I am going to put my fingers across the temperature sensor, the value of the temperature increases as follows. And whenever it goes about 29 degrees, the light will glow, and when I put my hand back, the temperature will soon decrease and the light will turn off. Just wait for a second. It's going below 29 and it's flickering because it's oscillating between 28 and 29. Now you can see that the light has been turned off. Again, the light has been turned on for a few seconds. After getting below 29, it will turn off. Okay, you can see here. Again, well, this was the LM35 Texas Instrument sensor. This was LM35 temperature sensor made by Texas Instruments, and in this program, in this module, we have talked about the temperature sensor and what is the data sheet and how to read the data sheet for the temperature sensor. We have built a small program for reading the voltage across the temperature sensor, and as well as how to read the temperature across the temperature sensor, and had performed a logical operation. See once again. It's just going to blink, and whenever the temperature goes below 29 degree, it will turn off. Well, this was the operation performed by it to give you a simple logical understanding of the program. If you have any questions, you can ask me, or else thanks for watching. Hello everyone, welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial, we are going to talk about the passive infrared sensor, or you can say it PIR sensor. The PIR sensor is a special type of sensor that is used to detect the presence of human within a range of 10 meters. Its sensors work on the basic principle of detecting passive infrared waves that are coming outside the human body. Well, you have seen that the human body human body emits some radiation that is in form of infrared, and that is invisible to us. But when the sensor here, you can see that when the sensor here takes the infrared radiation on it, it gives a value of high to the microcontroller. Well, this is the sensor you can see here, and this is a Fresnel prism. Let me give a correct vision of you to you. And this is a Fresnel prism that is connected on the sensor, so that it can catch the infrared radiation from all the 360 directions. Okay, here this is a complete module of PIR sensor. Okay, let's just tell you about PIR sensor. There are some sensors that are available that can detect up to 100 meter of range, but that are not in our course. So we are talking about the PIR sensor that is very easily available, and it can detect the human from within a 10 meter range. Its sensor is used to perform various activities and give various logical operations, such as opening of gates, and even detecting the presence of human to give an alarm to the person who is watching it. Okay, let's just go to Arduino and write a program for it. First of all, in Arduino you have to say pin mode 2 comma output. Let me correct it, PUT output. Okay, 2 is pin mode output, and we want to view it in a serial monitor. So serial.begin, serial.begin is there with 9600. Okay, no problem. Now in here we need a integer to define it. Okay, we will be defining it as a global int d for detect is equal to 0 initially. Okay, come here, say d is equal to digital read digital read to. Okay, we are reading digital pin 2 and storing its value in integer d. Okay, now serial dot pln, let me correct it, ln, we are reading data sensor 2 and the variable value is stored in variable d. So let's just take it, just give a delay for better operation of the system, say 10 millisecond. Okay, now just connect the Arduino board, connected. You can see the sensor here, sensor is there, upload it, write it PIR, say PIR sensor 6. It's uploading, it's just taking some time. Wait for the sketch to upload, and it's uploaded. First of all, I am taking my hand in front of the sensor. Okay, just a minute, I lost Arduino. Go to Arduino, open serial monitor, and you can see the value is low. Okay, the sensor is not set. Here are two variable resistors, or you can say potentiometers, for correcting the sensor. Let's just dial them to high sensitivity, and another is for delay. Give them high value. Now you can see that here that the value of sensor is going high because my hand is placed over it. Well, I have set the sensitivity of the sensor high so that it is detecting me. I am sitting here on the table and it is detecting me. If we set the value of the sensor to low, it will be very difficult for it to detect me, and I have at present set its value to 10 meter, and the value is set high for delay, so that you can see that the sensor is giving me a high value. It means that the sensor is saying that someone is the room, someone is present in the room. So by this method we can use it to detect by this method we can use it to detect humans and other type of life forms such as cattle, dogs, etc. This is a very useful sensor for opening of gates. In the shopping mall you have seen the automatic gates, they are working on the principle of PIR sensor. Okay, this was my tutorial for PIR sensor. If you have any question, please ask me in the comment section, or else thanks for watching. Hello everyone, and welcome to another section of Mastering Arduino from Beginner to Core Advanced. In this section we have entered in module 7, which is named as Serial Communication Basics. And what are the contents here? You can see that the contents are as follows: Introduction to Serial Communication, Serial Begin Details, Serial Write, and Serial Read. And we will be talking about all these topics in the later videos. First of all, we are going to know about what is serial communication. So let's just get to its introduction. About the serial communication. The serial communication is the method of communication between two computers. It was the first design with the help of RS-232 cable. There is a port in your computer that has a cable which is in blue colored and have multiple holes in it. This cable is used to connect the monitor to the CPU, and this cable can also connect the laptop to another monitor. This cable is known as RS-232. This cable runs on the protocol named as the serial communication. Okay, about the serial communication, and there is also a similar way which is known as parallel communication. Here you can see that in parallel communication there are multiple wires connected to between the two chips to process the data in a very high speed rate, while in a serial communication there is only one wire, and physically there are two wires to communicate between them. First one is the clock and second one is the data line. You can see that first data D0 enters the another CPU, then D1, then D2, then D3, and the series goes on to D7. So it is called serial communication because each bit is entered in another computer from the host computer in a continuous series. Okay. In Arduino, this is the most common method for connecting Arduino to the computer. You can see that here this is a cable in which I have connected it via USB to the Arduino board. This method is communication. This method of communication is also serial communication. Well, about the serial communication, let me open the Arduino. In Arduino, you can see that here, whenever we want to connect the Arduino to computer, we have to write serial dot begin, which means that the serial commissions this means that the serial commission should be started. Okay, give to curly braces, and here we write the baud rate. The baud rate is the rate at which the data between the two machines is transferred. It is said here are standard values for the baud rate. Let's just see here: 9600, 19200, 38400, 15200, and so on. Well, the baud rate for both the computer need to be same. Here you can see that the original baud rate between them is 9600. So you can get all the values and you can get the data in the readable form. But if the board has set the value of 9600, in computer you are opening it in 19200, it will give a false value. It means that the system cannot read the data. So for communication, it is necessary that both the computer are said to have a common baud rate. And there are other options such as new line and all this for the communication. You can see here, and let's just get it to 9600, and you can see that the communication is done properly. To begin serial communication, just write serial.begin and give it a baud rate of 9600. I am going to do an experiment. I am giving 115,200 baud rate. Okay, here I am going to delete the program and write capital SERIAL dot print. This means that the serial word has been printing on the computer. I am giving it say hello, HELLO. Terminate the line and so on. Okay, now upload it to the board. First of all, I need to set a baud rate, a delay function, so that we can see the data clearly. LAY, say delay of about 500 milliseconds. That will be enough for us. Say 500 milliseconds. Terminate the line and again upload it to the board. Now open the serial monitor. What can you see? You cannot see anything because I have set the baud rate at 9200, while in system I have defined it 115200. Change the baud rate to 1152200. Now you can see that all the lines you can get the data in a readable format, but you can see that it is not terminating continuously. It is all going in one line. So for that, to get the data every time in new line, write the function serial.print ln. ln will introduce every time a new line of every bit of data has read. Okay, see here, you can see that the data is coming in every time in a new line. This is the method of serial communication between the systems. You can do a lot of functions with the help of serial communication. You can read the data, you can write it with the help of serial monitor. Here you can see that there is a space. In here you can write the commands inside the Arduino, but here we have not programmed anything in the Arduino to read the command, so nothing will happen. In the later videos we are going to write the functions and study about how to read the command from the serial monitor when it is given from the computer serial monitor. Okay, now you can clear the output here, and let me show you something. I have found a very beautiful document on Wikipedia on what is serial communication. Here the serial communication is the method of transmission of data between the two computers, or you can say two electronic devices. As of now, it is a very simple method and it is more reliable in today's world than the parallel communication, because at today's world the speed of data sending is very high, so it can match up to the older parallel communication methods. Remember one thing more clearly. In when we are talking about ultra high speeds, there's the you can say the CPU talking to a RAM. It is always parallel communication, because there is a lot of data that should be gone between that should be sent and received between the two systems for high speed communication. So the relationship between you can say a CPU and RAM is parallel communication, while the communication between a CPU and monitor is serial communication, or you can say an Arduino and a computer are also doing the communication in the form of serial. There is also PCI and PCI Express cards that are used in communication are an example of serial communication. Okay, you can see here about the cables. First of all, serial communication was designed only to communicate the computers that are very far away. You can say the distance between two states or two cities, that was devised to communicate between them, and for high distances the using of parallel communication became ultra expensive, so they have defined the method of communication named as serial communication. You can see here first line is for data, and there is also a second line that is for the timing clock between them to get their interface done properly and get the data at a same baud rate in both the PCs. And there is also about the serial buses and their type of uses. Serial versus parallel is a hot topic of discussion, but remember that for ultra high components, when requires very high speed of communication, parallel communication is preferred, because it's simpler and had a lot of wire for high speed communication between them, while for long distances and most common use of method of communication between the two electronic machines is today's serial communication. Now remember one thing, that in Arduino Uno there is only one port for serial communication as pin number 0 and pin number 1, while in another board such as Arduino Mega, in Arduino Duo there are 3 channels for serial communication, such as serial communication 1, serial communication 2 and serial communication 3. You can see here serial communication is the application, and here you can see that serial communication can also be performed on another devices in the Arduino, such as a sensor named MPU 6050 and Arduino board communicate with each other with the help of serial communication and I2C protocol also. You can see that in Arduino Mega and Duo they have 3 communication channels, as RxTX1 for serial communication 1 up to RxTX3 for serial communication 3. Okay, let's just recall everything. We have talked about serial communication. Just a second. We have talked about serial communication, the difference between serial and parallel communication, what is the baud rate, and how the serial communication between two happens. It consists of 2 wires, first for data and second for timing clocking. Okay, we have made a small program here. I will be giving you the program in the first section of the module. You can get the program from there and to perform your own experiments. Okay, you can perform your own experiments there, and if you have any question you can write it in the comment sections, or else thanks for watching. Hello everyone and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to discuss about what is serial begin. When serial begin is a function that is used in Arduino programming to call the communication protocol and set the speed between the two systems, or you can say that it is setting the speed of data transmission from Arduino and PC. Usually serial begin has a speed of 9600. You can get all the values for serial begin here, such as 9600, 300, 1200 and up to something about 200,000, but the values can be defined as per the user also, but that requires the interface between the two machines and requires a high level of programming capability to get a serial monitor of a specified frequency. Well, we are going to do an example here. In the serial monitor value has been set always with the word of serial begin, but in other boards such as Arduino Mega and Arduino DUE, which are 8-bit and 32-bit boards, they have 3 ports for serial communication, such as serial 1, serial 2 and serial 3, and they all can talk with the system with another serial values of communication such as 9300, 9600, 1200 or 115200. Let's just do a program for Arduino Uno. Write serial serial.begin serial.begin. It is case sensitive, so always see that whenever you write something it should be turned into orange. And let's just say the speed 9600, 9600. Okay. Go down. If you want to view the serial communication, write serial dot print serial dot print. Let's see that I have done a mistake here, so it is not turning into orange. Okay, serial dot print, I have to do it in multiple lines, so I am doing print ln. You can say something as HELLOWORLD. It's user space, so you can write anything you want. Okay, go there. But if you want to write 2 words or 2 lines, you can do that by writing serial dot, just a minute, serial dot print. But remember one thing, the last line should always be written as print ln, so it can give you the clear value. If you have written both the line print ln, then it will be giving you another values, or you can say your code will not be able to see it properly. Okay, write ln in the last line for next line. Okay, say something like hello world and hi. Okay, terminate the line and give it a delay. I am giving a delay for proper visualizing of the program, but if you want, you can set it very low for high speed communication. Okay, give it a delay of 500 millisecond, terminate the line, upload it to the board, and it's uploading, just taking some time to get compiled and converted into the hexadecimals. It's done. Now open the serial prompt. You can see that we have seen that the baud rate here is 9600, while the baud rate at the here is 7480880. Go there and correct it with 9600. You can see something hello world hi. But if you want them to have some distance between them, you can just write a /t. It will give them a distance of new tab. Well, there was some syntax mistakes. Well, I have got the correct syntax. See here, whenever we write it with a T, it will giving me a tab space here. You can see here the distance between them has been increased. Okay, let's just see without the tab. And here you can see that the space between them is very low. But if you want to increase them the space of a tab, you can write \t and upload it. You can see that the distance of tab has been created. But if you want to make it write every time a new line, write it \n, upload it, and you can see here every time the word enters, it will enter in a new line. Okay, what about getting the words in the form of decimal, hexadecimal, binary, anything? If you want to see here, see here. If you want to do it, see here. Write 1 2 3 and upload it to the board. Okay, see here, it's printing 1 2 3, and write here print ln for getting it in next line. Okay, now write 1.23. see what happens here. You can see that 1.23 is applied here. Write a long string of something like 3.14157 9. Well, that is the exact value of pi. Let's just see how much value are received in the serial monitor. It is receiving only 2 values. If you want to get more values, count the number of values. It 1 2 3 4 5 6. Give it a comma, write 6, so it will be reading 6 values from the decimal. Upload it to the board. Now see here, we can read the whole number here. It is giving me a complete value of 6 values behind the decimal, 3.141579. I have a better option. What about writing the things in binary? BIN. Let's just try it. See here, it's a float, so delete it and write something else. Say 200. You can see that the 200 has been written into binary. Now convert into octadecimal. OC, it's a format for writing numbers within the value of 0 to 7. See here what is written for 200. The value is 310. It is of log base 8. Now write in hexadecimal. It is the value for 16 variables. See here what is the value for hexadecimal. Call the serial monitor and you can say it the value of 200 is C8. Try something, let's say 548. What is the value of 548 in hexadecimal? It is 224. Okay. Well, this was all about the writing in serial begin, and this was done with serial print, the method of writing it on the Arduino. So in the next chapter we are going to read a very important document, that is what is serial.write, because we can print anything on the screen as we want, but what happens if we give a value from here to the board, say something A B C, nothing happen. But we are going to make a program such that whenever we enter the value or give a command with the help of serial monitor, an action happens on the board in the next video. Okay, till then, if you have any question, please ask me, or thanks for watching. Hello everyone and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to discuss about a very important function, that is serial write. Well, I have named it serial write in place of serial print because I will be telling you, because there is an important part, because you can say that serial write is a description for serial print. There are basically 4 type of values that we can print. It can be an integer, it can be a float, it can be a character, or it can be string. So I have used the word serial write so that we can say that we are printing multiple values on it. Well, there is nothing such as serial write in the Arduino, but for the sake of convenience I am saying it is serial write. And let's just begin the Arduino. First of all, we need to call and sketch. We have called it. First of all, we are going to discuss about the integer and how to print it on the screen. I have connected an Arduino. First of all, I need to discuss about integer. So I am setting an integer, say integer x, and giving a value, say 77. That's it. Now come here. For always working in serial, it is necessary to call the serial monitor or serial port, BEGIN. Say you can say it 9600, but you can define as your own wish, such as 115200, but the value should be same. There are only a few values that can be used in it. Okay, come down here, call serial dot print and say the value integer x. And now let me explain you. I have called an integer x giving a value 77, called serial monitor with baud rate 9600 and giving a value of print fx, but I have done a mistake. I am going to tell you afterward. Okay, first of all I am going to upload it to the board. It's taking some time, and you can see here it's uploading, it's compiling first, taking its value to the hexadecimal and uploading to the board. Okay, the upload is done. Now what you can see that is a string of 7777 continuously going on, because the line cannot terminate itself, because you need to define it to terminate. For that, come here and write print ln. Now see what happens. There are also functions such as \n for new line, but we are using print ln. Okay, open here and see, you can see only one value in a line. This is the method. Okay, come here, we are going to do an experiment. I don't know does it happens in Arduino or not, because it happens in C \n. Okay, let's just try it, and it's calling the value and it's saying it's a mistake. Okay, let me give two inverted commas in it. Okay, now let's just try it. Again it's saying char to integer not permissible. Okay, I'm going here. There's a simple method. If the values does not work in the same line, remember one thing, there is a very simple method, you can call it in another line. This is the most suitable method. Say \n. Now terminate the line and upload it to the board. What happens, let's just see. And you can see that it works. This is the method. You can use the word ln, print ln, or you can use the \n, but I prefer to use the word ln because it takes only one line, or in other case you need to give the value to the same line, multiple functioning will be calling, or simply you can use the word ln, so I prefer ln. Okay, let's just try it with another thing. Well, you have seen the value of x in the form of decimal, but if you want to see its value in binary, can we do it? Well, yes, write bin in capital with a comma and just upload it to the board. Let's just see what happens. It's taking some time, no problem. And see here, the value of 77 is coming in the form of binary. My mistake, I have not called the next line value ln. I am going to upload it. The value of x is 77, but now it will be coming in the form of binary 1010, the computer language. The computer is reading it in the form of 101101. But if you want to call it in hexadecimal, is it possible? Well, I will say it is possible. Just write the value hex in capital with a comma with the value, and the parameter is called hexadecimal. So let's just see what happens. I can see that the value is coming in 4D. The value for 77 is in decimal, but its value in hexadecimal is 4D. Well, for D I will have to say you that for up to 9 it's okay. For 10 the value A is used. For 11 value B, and up to 16 the value E is used. E or F is used. I don't know the absolute value of it. Okay, come to the next part. Okay, this was about hexadecimal. Let's try it with octadecimal. Octadecimal, it means that the value is up to only 8. Okay, just upload it to the board. It's uploading. 0 to 7 will be the value for octadecimal, and it will coming out 0 to 7, it will be 8 values, or you can say 2 raised to 3. Its value is 115. Okay, that was enough for integer. But what happened? I am doing experiment. I am calling it 77.55 or 66. Let's just say it's saying 77.66. What happened? Let's just check. It's also an interesting thing. Just see here, it will say 78 or 77. It's saying 77 because it cannot read the float value. For a float value, you have to call something called float. It will turn into blue. Say float y is equal to say 3.14. Now call the value y here. It's uploading, taking some time, no problem, and it's been successfully uploaded. Okay, open here. You can see the value 3.14. Okay, let's just do another interesting experiment. its absolute value is 3.1415, that is the value of pi 79. I want to show you something interesting. What would happen if you call 6 places to the decimal? Does it read? Well, it will not. You can say only 3.14 is showing. There are about 6 values to the decimal, so you have to do something interesting. Go down, give a comma and give the value 6. Now what happens? See here, you can call up to 6 places to the decimal by using this method. And you can see all the 6 values are coming, but what happens if I want to call only 4? Okay, it will round figure itself to the 4th value, and see what happens here. And it's calling itself, and you can see only 4 values, and last value is 1 5, but it has round figure it from 579 to 6. Okay, now this was all about integers and float, but what about if you want to write a character such as ABC or anything? So we are calling CHAR, character. Say character C is the value that is storing the character. Remember one thing, it is not the character that will be printing, but it is the value. For that is an interesting fact. Use 2 commas and write a value such as say A. So the value of character C will be A. Come here, write C. We are calling C, but it is calling the value A because it is stored inside the character value. It's saying a mistake. I have not terminated the line, so I terminate it. Now again I am going to upload it. It's uploading. Just wait for a second, and let's just see what happens. You can see that we have called C, but it's printing value A. But what happened? You can say we printed A, B, C. I want to show you something interesting. First of all, it will not take the value itself. It's taking the value, then no problem. Let's just see. In calling ABC, we have called the value of character, so it will print the value C. For the sake of convenience, I am saying ABD, so you will not get confused. I am calling ABD. The value that only going to print is the last value of the character string, and that is D. Okay, come here and see. We can only see the D because anything that is stored more than a value will not be read. So if you want to read multiple lines, that is a simple method. You have to use the value string. STRING, S should be capital ING. String, say string S is equal to say hello world. We are using also a space here, WORLD, hello world. Terminate the line. Use 2 inverted commas for each time, because if 1 inverted comma cannot use the value of string. Upload it to the board. It's uploading, and it's saying a mistake. We have done a mistake initializing constant. Okay, I have not given the value of equal to. I have given it, and bottom we have done a mistake. We are not calling the value S, so S is done here. Okay, I am going to upload it, and it's uploading, and you can see the value hello world on the screen, and you can see that the hello world can be printed on the screen. And one thing interesting, if you want to print the value say 65, it does not require a termination column for the character. You can simply write 65 and terminate the line. It does not require inverted columns. Say C, and now see what happens. It's quite a bit interesting. It's saying the value A because the SC value of A is 65. The ASCII value, a American Standard value of 65 is A. If I say the value to 66, it will print value B. Let's just do it. I am going to print the value 66, and it's uploading to the board. Just wait for a second, and it's uploaded successfully. Say what happens. It will be printing the value capital B. You can see here. If you want to do it, give it a comma starting and end, and see what happens. It will print value or not. Let's just check it, and you can see here the value is 6 because it is already reading the last value. It has taken it as a character, but only last character can be read. See 67, going to upload it with character value, and see what happens. Only 7 will be read here. Well, there are many other functions which are related to print, but only these four are necessary for you. We can recall the sections such as for integers as 77, you can use int. For floats such as 3.1415, we are using the comma and using the value. For 6 places to decimal, use 6. For hexadecimal, use OCT capital. For hexadecimal, use XEX. For decimal, or you can say binary, use capital BIN. For reading only one character, you can use CHAR. And for reading a whole string, we are using strang with two inverted commas. You can see here there are two inverted commas here and hold the string. Okay, you can get the code and you can do your own practice if you want. And if you have any question, please ask me, or else thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about serial read. Well, there is a method in Arduino by which you can print the data on the serial monitor, but how to print the data or how to make a method such that we can give the Arduino an input command and it will give us a logical output. So to use that function, there is a method that is known as serial read. In this method you can give the command to Arduino and Arduino will perform the function as the programming has been done inside it. Okay, let's just begin it with an example. First of all, open the Arduino and we need an integer. So declare an integer, say int type, that's it. Give integer type. Okay, open serial dot begin serial dot begin 9600. As I have told you earlier, we are using the baud rate of 9600 because it is the most common baud rate. Okay, now here comes the main part. Write an if statement. If, give to parenthesis, write serial dot available serial dot available is greater than 0. Let me write it, is greater than 0. It is the mean of it is saying that whenever the value that has been entered in the serial monitor is greater than 0, then it will start reading the data and give two curly braces. Say, just a minute, let me check. Okay, here write the variable. The variable is named as type. So say type 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 is equal to serial dot read. So the data which has been read here will be stored in the serial. The data which has been read by the serial monitor will be stored in type. Okay, then write serial dot println serial dot println type. The data that we have stored here will be printed on the screen, but before that give a delay so that we can see the program working. Okay, we are giving a delay of, let's say, 1000 millisecond, or you can say it 1 second. Okay, for the type it will also be delay, say 1000 millisecond. Okay, let's just connect the Arduino board. It's connected. Upload the sketch. We are uploading the sketch. Just wait for a second. It's going to upload and it's saying here is a mistake. What is the mistake? I have forgot to terminate the line. Okay, go there, upload it once again. It's uploading and within a few seconds it will be going to upload. Just wait for it. Okay, the upload is going on. Okay, and the upload is done. Open the serial monitor and write something, say 5. There is a logical code in Arduino that says that if you enter 1 it will show 49, if you enter 2 it will show 50. Okay, if you enter 3 it will show 51. See here, if you enter 50 it will show 51. Okay, you can make it simple by saying that type minus 49. It will give us a stable value. Just check it. Enter 1, press enter. it's giving us 0, so just write it 48. We are just calibrating the code. Now let's just see it. Write 1, press enter, we get 1. Write 5, press enter. There are some logical mistakes here. Okay, let's just, the 13 that is being print is the value, that is the garbage value that the Arduino is taking out. First of all, you have seen that the value 53 or you can say 13 value has been written, but now whenever we give the value, it's giving us an output. Write 6, wait for a second, 6 has been written and minus 35 will be coming out. Okay, but what about strings? Is there a method so that we can write a string here? Yes, the method is possible. Use the variable data type char. Now go here, go read string, read string. Okay, now perform an experiment, upload it to the board. We are uploading it. It's saying a mistake that a char type cannot get it. Okay, I am going to show you an example of it. Just go there and remove the word string from the read. Okay, now upload it to the board. The upload is being done. Let's just wait for a second. Now enter a simple word, say G, and you can see here G can be seen on the screen. What about GH? It will come in 2 lines, G and then H. Oh no, it is, yes, G and H. It is only taking one variable or one word at a time. What about taking a full string such as a name such as SHUBH? For that we have to use the data type string. See here, go to the top and write string string. Now go here and write here string read string. Upload it to the board. It's uploading, just wait for a second. Upload has been done. Go there, write SHUBH, press enter. You can see that the complete word has been written. Now let's just perform an experiment here. Say that let's just first take the last curly braces down. Let's say if type type is equal to character say ABC. Perform an activity. Just go down, make 2 curly braces and perform the activity. Say serial serial dot println println, make 2 parentheses, right here correct 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 WORD for the test. Give it a delay DELAY for better performance. Say delay of 100 millisecond 1000. Give it a 1000 millisecond for better performance. Okay, upload it to the board. Upload has been done. Just go there and correct word. It's taking the wrong value. Okay, just go down and make it correct. Cut the whole program and write it inside the loop. Now upload it. You can see that it is taking value A, nothing happened, but we write A B C, it is saying a correct word. A B C, it's saying, let me check it, it's saying the word is correct. By this method you can use the string and give it a command. Here the command we made is word ABC. If the type value is ABC, then it will be showing the value correct word. If the value has been written something else, or you can say that there is a mistake in command, then it will not show the value. By this way the commands are made in the computer, and by this method you can also make your own custom commands in the Arduino. If you have any question, please ask me, or else thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to learn about IDEs and what are IDEs and are there any different type of IDEs that we can use for programming of Arduino. Let's just see the content. The content is the IDE for programming. What is the IDE or integrated development environment? What is it means and how can we program Arduino in different environments other than Arduino IDE, such as the wiring IDE and the Atmel Studio. Okay, let's just begin the course. Well, about the IDE, the IDE's full form is Integrated Development Environment. It is a software that is installed in the computer that can have an operating system such as Mac OS X, Windows, or Linux. The IDE, once installed in the computer, creates an interface between the user and the board. When we plug in the board uses a COM port to connect it to the IDE, and when we write a program into the IDE, it converts the program into hexadecimal and feed it to the onboard chip which is installed in the Arduino. By this method, the board can connect to the computer with the help of integrated development environment, and the IDE has built-in serial monitor so that the data which is coming from the board can be seen on the IDE. Okay, let's just talk about the IDE. There are many different type of IDEs other than the Arduino IDE which can be used for programming. There is also an online IDE which is available on the Arduino website. You can see here it is known as Arduino. First go to the website of Arduino. You can see that there is an online IDE available in the software option. Let me show you. Okay, Arduino home, go to the softwares. Let me wait for a second, it's coming. Go to softwares, and the first portion is saying me the web best editor, and you can try it by clicking here. You have to make an ID on the Arduino and using email and password, and you can use it on the system. Okay, but about different type of Arduino IDEs, well, there are many different type of IDEs which can use the libraries that we will be using on Arduino and can perform the same function as the Arduino IDE, but can also run different type of boards such as PIC-XA and another ARM architectured processing board there, but very simple configuration and very simple coding method. One of them IDE is the wiring IDE. I will show you here why it is wiring. Well, this is a wiring IDE. The name of the IDE is wiring. It can be used to run a lot of different type of programs. You can see the list of the board about wiring: Atmel, Rogue Robotics, Arduino, BD microcontrollers, and MLab. You can also add your own boards in here by using the different type of libraries. Okay, now about the Atmel Studio, the most important type of IDE that is using for Arduino is Atmel Studio. The Atmel Studio is the industry standard IDE which is used by companies to program their microcontrollers, but it also has a function. By installing a specified library of Arduino in it, you can program the Arduino from here. But remember one thing, if you make a good practice at Atmel Studio, it will be very good for you because it is the industry standard for IDEs. Okay, this was the basic of IDE and what we are going to see here in the later chapters about the wiring IDE and the Atmel Studio. If you have any question, you can ask me. Till then, thanks and thanks for watching. And welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to learn about the wiring IDE. The wiring IDE is a type of integrated development environment that is similar to Arduino, but it has a lot of features, such as this IDE can be used to program other microcontroller boards such as Atmel, Explained, AVR, and all other microcontrollers. Okay, first of all, let's open the IDE. It's wiring IDE here, you can see that. Okay, now I want to tell you about the microcontrollers that can be used here. It's very similar to Arduino, but the board options are very long. Its wiring has its own microcontroller board such as wiring 16 MHz, wiring play shield, and all other microcontrollers. It supports Atmel boards such as Atmel chip 168. We are using 328 and it is 168 that has 16 kilobyte of RAM. It's 16 MHz, and without the crystal also. I have first told you that Arduino uses a 60 MHz crystal, but in wiring you have an option that you can program the microcontroller without the help of the crystal. It also supports other boards such as Rogue Robotics, and the most common is Arduino. Arduino you can support Arduino Uno, Demilino, and even Nano. But remember one thing, that you cannot use Arduino ARM architecture boards such as SM3XE based Arduino Duo, because it will not has the library. Wiring does not have the library for it to work and support. Another microcontroller such as D Micro Maverick and MLab you can also use on this microcontroller interface IDE. Okay, let's just see what is wiring. Wiring is very much similar to Arduino, and the programming methodology such as, let us check, PIN MODE pin mode. You can see that it is exactly similar to Arduino. You can see that it's exactly similar to Arduino. It has a lot of features which are upgraded to Arduino to make it wiring compatible board, such as it can support wiring its own hardware library such as wiring hardware. Well, this was the basics about the Arduino based wiring. Both of them share a common interface system, or you can say the IDE is based on processing, a third type of IDE on which Arduino and wiring both are based. Let me tell you the story about it. Open now, search wiring IDE. Wiring and Arduino both are based on Casey Rees and Benjamin Fry from MIT. They have developed the IDE for that is known as processing. It's taking some time. Let me load it. Here you can see that we have reached the wiring website, and it is wiringorg.co. Okay, it's opening. Just wait for a time, and we have to read something about it on Wikipedia, so we are reading on it. Let me tell you something about processing. Let me wait for a second. Process ING IDE. It's searching. Just wait for a second. The whole story of Arduino, the whole story of wiring, the whole story of open source electronic is based on processing. So it is important to tell you something about processing. Here you can see the Wikipedia page of processing. It says that the processing is the integrated development environment for the microcontrollers such as Arduino. Even wiring and all those are using this environment. Everything is developed based on processing, because it is a strong GPL language that is based on C++, Java and OpenGL. Okay, but processing has some very interesting feature. Processing is mostly used for high performance graphics. You can see that here is an example. Processing is used for graphic integration or making graphics. This was the main use of processing. Rather than processing, if you want to do a microcontroller programming with the help of processing, it is not easily possible because it does not support for that. But by hacking processing language and its interface to program something like Arduino, it was done. I want to tell you about processing. Let's just open it. Let me open it. Processing. I think I have processing. Yes, I have processing. This is processing. It is also sharing the same syntax formula that is used in Arduino in wiring, while the important thing is that it is used for graphics rather than microcontroller programming. If you want to get a graphical visualization of your data or your Arduino, what is sending, you can say the temperature sensor graph of Arduino. You can use the processing language for that. You can see that it has the same features of Arduino, but it is much developed than that, such as sketcher, debug, run, file, example, everything. This is, you can say, the godfather of all the IDEs that are developed, because of Atmel Studio, a very high performance development environment, but it is not suitable for hobbyist or general purpose student. You can say students. It was not possible to use Atmel Studio, so they have hacked processing IDE and converted it into Arduino and wiring IDE. Wiring is similar to Arduino, but it has some more interesting features. But remember one thing, wiring does not support 32-bit microcontroller Arduino boards. It has same features, same working capabilities. It is somehow better in some contexts, such as using it without crystal. You can program it in different ways, and it has a better microcontroller. You can say visualization can be done in a better interface. It has a better serial monitor, but wiring has some limits. Well, this was about wiring and the processing ID that I think I should need to tell you. And here you can download wiring at wiring.org.co. Okay, this was about wiring. If you have any question, you can ask me, or else thanks for watching. Hello and welcome everyone to another tutorial series of mastering Arduino from beginner to core advanced. In this tutorial series we are going to talk about the advanced topics, and the contents for this series is as follows. You can see here I2C or inter-IC protocol for communication and processing between two microcontrollers, SPI or serial or peripheral interference between two microcontrollers, wireless communication between a microcontroller and a chip, interrupts and hardware debouncing or debugging. Hardware debouncing, it is used for getting a filtered signal, SD card data reading, writing and data logging, RFID card reading, and at the last we will be talking about watchdog timers. Okay, let's begin with the first section. In the first section we have I2C communication, or you can say inter-IC communication protocol. Inter-IC communication protocol was Inter-IC protocol was a method that was used to communicate between two ICs. It is similar to serial communication between a computer and a microcontroller, but it is designed to communicate between two microcontrollers, or you can say two ICs. It can communicate between a microcontroller and a different type of IC which supports I2C protocol. Okay, let's just talk about I2C. I2C has a 4-wire channel, 2 for power and 1 for serial communication, which means for serial data transmission SDA, while another for serial clock, which gives a stable clock time between the two, which makes a stable clock time between the two microcontrollers. This protocol is very important because it can be used to communicate with a multiple number of ICs where one acts as a slave, where one acts as a master, while there can be a number of slaves between a single channel. And if a microcontroller want to call the number 3 IC or number 3 slave IC in the channel, he can call it by using number 3 and giving the pull-up registers call or a high value. While if you want to call the number 4 IC, he can just give a high value to the pull-up register of serially connected slave number 4. By this method, you can communicate with all the ICs which are required by calling their pull-up registers. They all are connected in the same wire. There are only 2 wires for interfacing, one for SDA, that is meant for serial data transmission, and SCL, that is meant for serial clock. In this 2 wire going out from microcontroller, you can connect a number of communication devices or the slave ICs within it, and each one has a special dedicated number or a pull-up register value for it. For that, whenever the microcontroller requires, he can call any one of the ICs as it is required. Okay, there is a built-in library in Arduino that is called wire or wire.h. You can call the wire.h library and communicate between the Arduino and the other ICs or other Arduino boards. This communication protocol is also similar for Raspberry Pi, but it has its own dedicated library, as well as for other microcontrollers, but they had their own custom made libraries. Okay, let's just begin with an example. First of all, let's just see its wiring. In this you can see that there is only 2 wire. One is pin number connected to analog pin number 4, and that is going to slave pin number 4 also. Wire number 5, that is going to slave pin number analog 5, and one is for ground. But here in the setup you can see that we have 4 wire. One is for power, because I am doing a test, that is if we can possibly control 2 microcontroller with the same power source and have a serial or have a I2C communication channel between them. And let us just begin with writing a code. We have seen the wiring and there is an example code here. Let's just begin with writing the code. Okay, come here. Pause. For the I2C communication between two ICs, we have to write 2 different type of codes in both the ICs. First of all, a code that is for master communication or for the master that is required to call different number of ICs is called the master code, that will be fed to the Arduino that is connected to the computer, while there will be a second code that is implanted into the slave. The code for the slave is same for as number of Arduino devices that you are connecting, but each have a different, you can say, address for communication. I am showing you the example. Just see the Arduino. First of all, without for removing any type of confusion, I am just going to remove all the other wires from the Arduino. Okay, you can see that the Arduino is standalone. There is no wire connected to it. You can see here. Okay, let's just upload the slave code first. Let's just talk about the slave code. Okay, here is the slave code. You can see here, first of all, we are calling the wire library. After calling the wire library, we are calling it wire.begin, same as serial.begin, but in this case we are communicating on wire, and it is giving the number 8, so that if we are calling it on 8, then its physical address is 8. So whenever the master is calling number 8, it will be calling this IC. Okay, second, wire on request, and it is giving a function. Okay, delay in the loop, and let's just go down to the function. It is saying nothing, but it is saying a simple line, that it is saying wire.write hello. You can say it can give 2 lines. Okay, write wire.write wire.write. You can give another line for that. I am, say simply wire.write IC2. It is its position, or you can say slave IC, SLAVE, slave. Okay, it is giving 2 lines for the master to read. Okay, just upload it to the board. We are going to save it as I2C SLAVE slave. Okay, it's going to save. Just wait for a second. Okay, my mistake, I have not terminated the line. Okay, I have terminated it. Now we are going to save it. Again, what is the problem? Wire.slave expected before token. Okay, let's just upload it. My mistake, there was a curly bracket mistake. Okay, I am going to upload it to the board. Just wait for a second, it's uploading, and you can see that it is compiling and it's uploaded to the board. Now one important thing about Arduino Uno is that we can remove the IC simply by using a simple screwdriver. So I am going to remove this IC and connecting it to another specially designed board for the communication of slave protocol. You can see here it has no FTDIRL IC that is used to communicate between the microcontroller and the computer. In Arduino, you can see here this is a small IC. Here you can see this is a small IC. This IC is used to communicate between the computer and the microcontroller, while here there is no FTDI IC, so you cannot communicate with this board and the computer, but this IC is going to plugging in into this board. Okay, I am going to remove the IC from Arduino. Wait for a second. It's been successfully removed, and it is going to plug in into the another microcontroller board without FTDIRL communication. Okay, it is successfully embedded into the another board. Okay, now about Arduino, remove the plug, go there and connect it with another IC. Okay, you can see here there are 2 ICs on 2 different boards. Okay, and this IC here in the Arduino is going to work as the master. Wait for a second, I am just going to connect it to Arduino properly. Okay, the IC is connected successfully in Arduino, and let's just plug it. I have plugged it successfully and the button is lighting. Okay, now we are going to talk about the master program. Come here, we are going to talk about the master program. See, for I2C protocol, the master is simply, it's saying that wire.h for calling wire library, another word string C. We are giving the variable C a value of string so that it will be reading string. Similar wire.begin for calling the wire protocol, serial.begin so that we can see the data on the serial monitor. In void loop it is similar wire.request from, so it is saying that it is requesting port number 8 and the data will be coming in a 6-byte value. Okay, then next, if wire.available greater than 0, you can see that C will be holding the value that is coming from wire.read string and the value that will be coming from the slave, and then after we will be going to print the C. Okay, let's just upload it to the board. It will take about a few seconds. Say I2C master. It's going to upload it in the board. Just wait for a few seconds. And it's successfully uploaded. You can see here. Okay, now I am going to connect the two boards same as the wiring as shown here. Okay, now I am going to connect the two boards same as the wiring as shown here. Pin number, analog pin number 4 to analog pin number 4, analog pin number 5 to analog pin number 5, ground to ground, and I have done an experiment connecting 5 volt to 5 volt here. The board has same pin wire here. I am going to connect them. Just wait for a second. Okay, let's just open the serial monitor here. I have connected 4 to 5 and 5 to 4. Let me reconnect them. I have reconnected them. Again, see the serial monitor. You can see the word hello is coming here, but we can read. Okay, the word hello is coming here. Edit. Now after changing the value from 6 byte to 12 byte, I can see that here the word hello and hello slave is coming from the slave IC. You can see that in the wiring there is no communication, only the 4 wires that are the 4 serial communication between the Arduino and the another microcontroller. Let me give it a purified value by giving the value 11. Okay, let's just upload it to the board. It's uploading. Just wait for a few seconds. Open the serial monitor. Now you can see that the values written here are hello slave. It is giving the value 11 instead of 12 because in Arduino the numerical values in C starts from 0. So from 0 to 11 will be definitely giving a value of 12. So here we can see that the two lines that we have written in the slave are as follows. Let me show you the slave values. Hello and second line is slave, that will be giving a total value of 12 and their port number is 8, or you can say their address is 8. In master you can see that we have given the value 8, that is their address, and 11, that is the value of communication bits or bytes, that is the value of communication bytes. If we have delete the value to 6 and upload it to the board, just wait for a second, it's uploading. Now here you can see that after uploading only hello will be printed, but if we delete the value from 11 from 6 to 11, let's just see it. It's saving that hello dot slave, hello slave. If you set the value from 12, from 11 to 12, see here, it's also picking a garbage value. You can see here there is a invert question mark, or you can say a garbage value here, but for proper communication, for 12 words we have to give the value 11. It can be n minus 1, where n is the number of words that are the values that are coming from the slave. Okay, just upload it for proper 11. And port number 8 from slave to master, and giving the value to serial monitor. You can see that the value hello slave, the 2 words that are coming from the slave IC, from this board it is communicating to this board, and it is going to the computer. Well, it seems so simple, but it is very important, because in physically we have communicated between 2 boards. One board is communicating to another board, so it is a very important topic. You can do a lot of work. You can also give your own logical operations, such that whenever a serial master board is set to communicate with a slave board, he can turn off its LEDs, he can control its buzzers, motors, even a lot of function can be done with the help of this method, inter-IC communication. And it is the standard protocol for communication between the ICs. And you can have multiple channels of inter-IC communication by the use of a very small chip. It is said as NXP I2C multiplexer. I2C bus multiplexer. It can create a lot of channels by use of this small chip. But this chip is SMD also, but these chips always comes in SMD package. So please, for proper soldering, select SOP package, and for industrial level use SMD package. Okay, this was the tutorial for just wait for a second. We are going to see the chip. Here is the chip that is used and it is known as NXP I2C multiplexer. The protocol was developed by Philips, but it was purchased by NXP Corporation, so it is named as NXP I2C multiplexer. Okay, if you have any questions, please ask me, or else thanks for watching. Hello and welcome to another video of mastering Arduino from beginner to core advanced. In this video we are going to talking about wireless communication using a RF remote and transmitter and receiver. Okay, let's just first come to the hardware. This is a RF transmitter which runs on 415 megahertz. Okay, and this is the RF receiver, which is a 4-channel device. Here you can see that there are 4 buttons which indicate that it is a 4-channel device. Okay. Now let me tell you about the theory of it. It works on the principle of communication between the radio with the help of radio frequencies at a fixed frequency of 415 megahertz. Here you can see a dial which is red painted. Here you can see that this dial can be adjusted so that the transmitter and receiver frequency can be matched, and to give a proper matching function, you can rotate it. Okay, here you can see, first of all, get the pin diagram of it. Here the first pin is for ground, the second is for 5V power, and the next 4 pins are for each channel communication. Okay, it gives a 5 voltage output when the button is pressed and the communication is completed. Okay, to see its working, first of all we are going to open Arduino. It's opened, and go here, go to examples, and check the digital read serial. Here I am connected the board at pin number 5, so I am going to test it at pin number 5. Let me upload it. It's uploading. Wait for a second. It is taking some time to upload. And it's uploaded successfully. Okay, let's just see it. Whenever I press the button, I can see 1 is coming. You can see here 1 0 1 0 1 1 0 1 0. Okay, whenever I press the button, the signal is completed, and it sends the signal a 5V output to the digital pin 5 of the Arduino and gives a signal of high. Okay, but let us test a program here. I am going to open an Arduino sketch here, and first of all we are going to define the pins. Okay, give a pin mode. we have connected it on pin number 5. So say pin number 5 comma input input, pin number 5 input. Okay, and the LED is connected on pin number 13. So we are going to say pin mode, say pin mode, pin number 13 as output. Okay, pin number 13 is output. Okay, here write a simple program of if statement. If first of all, for holding a value we need an integer, so we are going to call it int x is equal to, let's say, 0 for proper function. And before writing if, we need something for holding the value. Say x is equal to digital capital R EAD digital read, say pin number 5. Okay, now here write an if statement. If x is equal double equal to, for giving comparison we are giving two equal to 1, then we are going to write the statement digital write, say 13 is equal to high, 13 is giving high output. For let's say delay, delay 1 second, for that we can see the working of the system properly. And we are giving an else statement as else statement. If the x is equal to 0, then the system will be low or LED will be turned off. And there should be no delay in the else statement because it will cause a problem. Okay, just upload the sketch to the microcontroller. We are giving it name remote control. You can find the sketches at the beginning of the module. You can download it and work as your own ways. As you're required, you can work on the sketches I am giving you at the beginning of the module. Okay, let me compile it and upload it to the board. I have successfully uploaded. Okay, whenever I press the button high, it's giving me the LED as output. We can do one function here. We can get the serial output of it so that we can get a clear vision of what is going inside the microcontroller. Serial.begin 9600. Okay, let's just do an experiment. Say 115200. Only just for the sake of an experiment we are doing it. It is not necessary. And you can write the state outside if and else statement. Say serial. Say serial.print. The variable is x, so we are reading the variable x. Okay, successfully written, and we are going to upload it to the board. It's uploading. Now you can see in the serial monitor, whenever I press the button, it's giving the value of high. First of all, I have to correct the baud rate to 115200. You can work on same baud rate 9600, but it is done for the sake of experiment. Okay, see it taking just 1 second to give the next reading, and when I leave the button for a few seconds, it is light on, but after the second is completed it turns off. Okay, but we have 4 buttons, or you can say we have 4 channels. So let us make a program in which we can get the output from 2 buttons of the remote to give a input to the Arduino. So that we can work with 2 buttons. Well, it is easy. Just go here and say pin mode. We define pin number 4 as input. I have connected another pin to pin number 4, and go down here. Say y, declare the integer at the top, int, y is equal to 0, terminate the line. Come here, say y is equal to digital read digital read at pin number 4. No problem, it is at pin number 4. We don't need anything else. Go there down and check it with the help of terminating the variable y and writing terminating the variable x and writing the variable y. Upload it to the board. Now we can see the state of y here in the serial monitor. It's taking y. It's connected to the bottom of the. It is connected to button number D here. You can see in the remote. The bottom button, whenever is pressed, is giving the value of y, and the top button is giving the value of x. Okay, now go here. we can read both the values of x and y. So write a simple program. Say whenever the value of x is equal to high, say pin number 13 is equal to high, and whenever the value of say if statement, again whenever the value of y is equal to high, say pin number 13 is equal to low, and give a pin number of print say print x and say print t. We can use this method, it is successful. And say next line serial dot println, say println x and y here. Okay, terminate the line, compile it. It's successfully compiled. The variable backslash t is used to give the space between x and y. Okay, you can see here it's giving two values x and y. When I press x is equal to I, and when I press y is equal to another value. Okay, it's a backslash mistake. Write this, upload it to the board, and it's uploaded. See here. Okay, when I press x is equal to low, and when I press high, y. Okay, see the complete experiment. Again, terminate everything, open the serial monitor. Everything is shut down, everything is low. When I press button B, it says x is equal to high and light is continuously glowing. When I press Y, it says y is equal to high and light is turned off. Again, x is give us continuous lighting on, y it give us continuous lighting off. On, off, x, y. So by this method we can use the two pins of the remote control to control an LED to an infinitely long on state or infinitely long off state, and we can control about 4 instruments because it has 4 channel, and we are going to use the remote for controlling a big motor in the later videos that is going on in the next module. So please watch it, and if you have any question you can ask me, or else thanks for watching. Okay, let me give you a complete summary of the what we have learned. RF communication runs on 415 megahertz. It is a 4 channel button because it is a 4 channel remote because it has 4 buttons. The transmitter and receiver frequency is matched by this rotating this potentiometer dial here, and it works on 415 megahertz. It can use to control lights or any instrument, lights such as motor, everything. For Arduino we have to use it as digital read for the input pins to get the value and process it further, and it can only give the value in the form of digital such as low or high, which is 0 and 5 volt, and we can use multiple pins in the same Arduino to control multiple objects. And here in the code, let us see the code. Okay, we have defined 2 pins as pin number 4 and 5, and for that we have 2 variables as x and y here, and an output is taken as pin number 13 as LED, and we have called a serial monitor at 115200. Let us try it at 9600 for the sake of experiment. Here x for reading 5 at digital read, y for reading 4 at digital read pin number 4. Statement is simple. If x is equal to high, then LED will glow. If y is equal to high, then LED will not glow, and there is no need for this any else statement. Here you can see it will first print x, then it will print y. If you want the distance, you can just simply add serial dot print. There is no need to put ln, give 2 braces, and the most simple method is to simply give the space, and if you want more space use backslash t for getting more spaces, but we are using simple spaces, no problem. Terminate the line, check the code, upload it once again. It's successfully uploaded. As you can see here, you can see the problem because we have changed the baud rate. Go up and you can run it on both the baud rates. Now you can see the spaces difference between x and y. When I say x is equal to high, you can see here light is glowing on. When I say y is equal to high, you can see the light is glowing off. It can run for infinitely long until the y is satisfied, and it can be shut off for infinitely long time until x is satisfied. Okay, this was the summary of the video. If you have any question, you can ask me, or else thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about radio frequency identification tag, or you can say it RFID tags. RFID tags are the tags that are used in shopping malls to detect the product that are protected from stealing, or their tags are also used in many other places for detecting the RFID tags are mostly used in dogs for tracking the location of the dogs, and they are also used for tracking the location of the product. They are simple tags. Here you can see in my hand, this is example of an RFID tags, but this tag is passive tag. It means it does not have any power source. If the RFID tag is an active tag, then it can detect up to 50 meters of range, but this is an passive tag, so it can only be detected up to 10 centimeter of range. Here in the Arduino you can see that there is a black thing. This is EM18, or you can say the RFID tracking module. Whenever you place the tag across the EM18 module, it will give a value of its identification number to the EM18 module, and EM18 module give the information to the Arduino. By this method we can use the RFID tag to read the data, and this RFID tag can help us in a lot of projects such as door opening, etc. By using RFID tags we are getting a very good method for electronic key. If electronic key is similar to a mechanical key, while here we are using an electronic key such as this RFID tags. There are two tags here, but they cannot be copied because they are electronically locked and they have a small chip inside them which gives the value of them. And here for the key verification, the value of the chip is used and it cannot be cloned. So it is a very secure method of communication. You have seen them in credit cards also. This is the same method, but there is a difference that in credit card they are using 413 megahertz cards, while we are using 133 kilohertz cards because they are simple in application. Okay, let's just see the block diagram for the cards. Let me once again correct you. RFID cards are of two types. They are passive cards which have a distance of 10 centimeter, and active cards which have a battery built in them so that they can be reached from a distance of more than 50 meters. Okay, now let's just see the module. Okay, here you can see that this is EM18 module and connected to the Arduino. It requires only 3 wire for connection, 2 for power and 1 for TX. Here is the diagram or RFID. Here you can see that it requires only 1 wire, this yellow one, for connection with the Arduino board, and it is connected on pin number 1, and 2 wires for power. Okay, let's just see on the Arduino programming language. Come here, open it. Now for the basics of communication, it does not require any library. It is just using the serial monitor method. It is called serial communication, but the communication is done between the EM18 module and the Arduino, and the data is sent over the serial monitor and we can see them. Okay, let's just begin the programming. First of all we have to declare we have to declare a variable which will store the data, and we are using a string variable. Okay, write string, it will turn into blue. Say string input, string input. Okay, come in serial void loop, come in void setup and write serial dot begin, begin. It will help us for reading data. Write pin mode input pin 13 as output for seeing the value on a physical system, and come down. Write a simple line, say serial. It is nothing, it is similar to serial communication, it just requires some common syntaxes. Write if serial dot available greater than 0, then give two curly braces and write s, say input 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 is equal to serial dot read read string serial dot read string. Say no, this is enough. Okay, and give it a delay of, let's say, 100 millisecond. After 100 millisecond it will give a serial dot print. I am using the word println so that we can get the values each time. In the next line we are using the variable input, so here we are giving output as also the variable input. Okay, just upload it. Remember one thing, while uploading, the pin that is connected to pin number 1 should be disconnected. So I am disconnecting here, because if the pin is connected, then there will be error in uploading the code. Okay, we are going to upload it. It's uploading. Wait for a second. It's saying there is a mistake, DELAY. My bad, I am correcting it. Okay, let's just upload it once again. It's taking some time, no problem. Okay, it's uploaded on the board. Okay, let's just open serial monitor. Then again we are going to connect the pin to pin number 1. It's connected, and now when we are flipping our RFID card, it will be giving us values. Here you can see that there is a string that is written, which is a number such as 0808, and there is a long string after, and there is a long string after it. Okay, but can we use this variable? Well, first of all, we are discussing about the variable that here is showing is the key. Now we are using the first card. It's giving us, first of all, let me remove the garbage. Whenever I flip the card, it's giving me a value. Again, when I am flipping the another card, it's giving me another value. It means that these are the keys for the card. So we can get a physical key of the card. So can we write a program which will be giving us a syntax, or can we do it a verification by using two cards and getting the right card? Well, yes, it is possible. Come here. Give a if statement. Say that say if input, because it is the variable that is storing the data, is equal to, come in serial monitor and copy any value as you required. I am copying the first value. Control C. We are giving two equal to signs as per the syntax, giving two giving two commas, inverted commas, and pasting the code here. We have pasted the code, and let's just say give two curly braces and say the value. If the input value is equal to the value that we have feed here, then there will be a turning on of LED pin 13. Say digital pin. Say digital write 13 comma high. Okay, and let's say serial dot println say correct value, correct. For better working of the code, we are going to write a else statement. Remember the curly braces for the if statement, and after finishing then write else, and come down with two curly braces and write the program. Digital write say 13 low, and say serial dot println say incorrect. Now let me explain you the complete program here. First of all, we are storing the value in an integer that is named as input. Again, we are calling serial monitor as 9600 baud rate, and we are using a physical pin number 13 as output. Come down. the pin is connected to serial pin 1, or you can see it is Arduino pin 1, so we are calling serial.available. Then input will be storing the whole string here, and it will be giving a delay of 100 millisecond and will be printing the value that the input has cached. Again, here is the if statement, which will be comparing the values of input and the number that we have predefined here. If the number is correct, then the pin number 13 will go high or glow, and a line will be written as correct value. And if the key is wrong or the another card is used in place of the correct card, then it will be saying as the value is incorrect. Okay, let's just upload it to the board. First of all, see here, again we are going to open the pin here, because it is not possible to upload the program when the pin is connected. We are giving its name RFID RFID card, and we are going to upload it. Wait a second, it's uploading. It's saying me value is incorrect. Here is my mistake. Again we are going to upload it. It's saying again now just upload it. What happened? Now just upload it again. There is a mistake in commas, so here it is not coming, and here it is absolute. So upload it. It's taking some time, and it's uploaded. Open the serial monitor, connect the pin back to pin number 1. We have connected it, and here are two cards. See the Arduino, I can make you see the pin number 13, it's not glowing. Okay, let's just take the card 1, and it's saying it's incorrect because it is the wrong card. Now take the second card. I have taken the first card. No, let me correct the card. Its correct value, you can see the pin on the LED on pin number 13 is glowing. Taking the wrong card, it's saying it's incorrect and LED is stopping. Okay, not taking the correct card, the pin is glowing. Well, by this method we can control the RFID tags, and we can use them to control our own systems. These are the most secure method, because there is not a it is not simple to clone the card, so it is a very secure method for communication. And by just glowing without even giving it a contact, we can take the value and we can feed it to the computer. So it is very useful for wireless communication at very short distances, or even you can say that for the identification of an object or a thing. Or even it can be simply used as a gate opener card. In your upcoming project, I will be showing you a simple gate opener mechanism, and this card will be working as a key for it. This is the most basic project for Internet of Things, and I will be showing you with a complete diagram, schematic, and working and all the things about it. We will be discussing about it in future videos. If you have any question, please ask me, or else thanks for watching. Here, okay, we are giving the conclusion of the whole project. In this project, first of all, let's just begin. We are using a card for gate opener, or you can say a card for RFID verification and tagging. Okay, here giving the value of the card, you can see that we are feeding the data with the help of this plastic card, which has a built-in chip, so that we can feed the data with the help of electromagnetic radiation in the EM18 module. An EM18 module will be giving the output value to the Arduino, and Arduino will be giving it to the serial monitor so that we can see it on the computer. This system can run as a standalone by using a small battery, and there is no need of computer. Again, about the RFID cards, they are of two types. One is passive, one is active. The passive have a range of 10 cm, the active has a range of about 50 meters. They are most useful cards, and they are of also two types. One is 133 to 433 kilohertz, while another is 413 megahertz, that is used for high security purposes such as ATM or credit cards. Okay, here is the pin diagram. You can see that only 3 pins are required. One for serial communication, that is connected to pin number 1 of Arduino, and 2 for power. and there is no need to buy the whole module. You can just buy the EM18 socket and connect it with only 2-3 pins, 2 for power and 1 for communication. Okay, this is the simple code that we have written. I am going to explain you once again the basics of code. The code is calling a string and opening the serial monitor, again a pin for physical computing. Now when serial is available, it is going to read the string and giving out the input as the output variable that we have gone. If the value is correct equal to this variable or this integer that we have, if the value is corrected to this number that we have written here, then it will compare them, and if it is right, it will glowing the LED as high and giving us a value, correct value, and if no, then it will be saying it is incorrect key. This is the basic of code. Again we are going to do an experiment here with the help of this card, and it's saying me the value is correct. This was the basic, or you can say that this was the conclusion of the project of RFID, and if you have any doubt you can ask me, or else thanks for watching. Hello everyone, and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about a very important topic, that is watchdog timer. A very important topic, that is watchdog timer. Well, about the watchdog timer, first of all let us think of a condition. If we want to run an Arduino for say a very long time, say about a year, how can we run an Arduino for an year? Because basically Arduino is based on architecture of 2 raised to 8, that is 8-bit. So after 49 days the millisecond will overflow and Arduino will hang. Or such are, let us consider a sensor which has taken a garbage value and it hangs the whole Arduino. Well, if you want to run Arduino and leave it on standalone condition without watching it for very long time, it is recommended that use a watchdog timer. Well, a watchdog timer is a timer. Let us think of it as a heart. A microcontroller's clock is like a heartbeat. If it is working properly, then there is no problem, but if it got stuck somewhere, then the watchdog timer give it a sudden shock and reset the whole microcontroller. This is a specially designed IC fabrication that is also built alongside the microcontroller, so that to protect it from hanging, so that it can run on a very long time on its own. This is called watchdog timer. Think of it, if you want to run for a long time, say 1 year, it will reset itself. Whenever the microcontroller overflows or whenever it hangs, it will reset itself. This was the thing that is called a watchdog timer. We have a long list of values such as ranging from 15 millisecond to 8 second. It will first notice or analyze the time. If the time is greater than 15 millisecond, then it will restart to 8 second. If the time is greater than 8 second, it will restart. But we cannot call a function other than this for the watchdog timer, because these are the pre-built functions in the watchdog timer and there are no another function that can be called. These are the pre-designed functions for the watchdog timer. Okay, let's just begin it with the help of an example. Okay, first of all open the Arduino. Let's just say, first of all, for calling the watchdog timer, we need to call its library. There is a pre-built library in Arduino, that is AVR-WDT. Okay, we are going to call it. AVR-WDT.h. Okay. Now in void setup, we are going to write some program. That is, first of all, serial begin for seeing the process. Calling it 9600 baud rate. Okay. Now let's just print something simple. Say watchdog timer initiated. It is preferred to use ln in place of direct serial print because it will print everything in next line. Watchdog initiated. Okay, that's right. Now first of all, to call the watchdog timer we have to disable it because it will cause error. So write wdt underscore disable, disable, give to parenthesis, terminate the line, again give it a delay of let's say 1000 milliseconds. Now call the watchdog timer. We are going to select 2 seconds. WDT O underscore 2S. My mistake, 2S. Okay, terminate the line. Now here we are going to call this physical pin so that we can see an output. Say output. Okay, now here we are going to test it in a for loop. Okay, write simple, say for, call the basic arguments for the for loop, int I is equal to 0, terminate the line, say I smaller than say 10, terminate the line, say I plus plus. Okay, now give two curly braces for the for loop, open them and write simple digital write, digital write, say 13 comma high, high, terminate the line, there is a mistake in comma so I am going to correct it, say delay delay, let's say about 500 millisecond will be better, 500 millisecond, terminate the line, again write it digital write low for next millisecond, and if you want to see the print, say serial dot println, say we are going to print the variable I here. Okay, now the important part, if I is greater than say 3, we are going to give two curly braces inside it, say break, break, and terminate the line. After terminating, it will go outside the for loop, so we are going to say wdt underscore reset, give two braces. Okay, let's just check the whole program. I think that's fine. Okay, let's just upload it to the Arduino. We are uploading it. It's taking some time. Okay, and hello everyone and welcome to the last section of mastering Arduino from beginner to core advanced. In this section we are going to do a real-time video or real-time project. We are going to do a real-time project, that is automatic gate opener, a system that is used for operating heavy gates using heavy motors, and it will be on high voltage, such as in our case it will be 12 volt, but the system is capable to run on 120 volts or 220 volts as per the given output to the system AC in the form of alternating current. Okay, let's just see the content. It is first of all about the project, then it will be talking on multiple sensor, then we will be talking on running multiple motors, or you can say the motors in both direction, or giving an output such as an alarm. Then we will be using the method for running all them simultaneously. Then we will be using on running with the help of RF remote. Then we will be going to run with the help of RFID card. Okay, first of all let me tell you about the automatic sensor first of all let me tell you about the automatic gate opener project. And we are not going to use this Arduino. First of all I am going to tell you I am going to tell you that we are not using this Arduino because we are going to use this prototype board. Here you can see this board will be used for the project. It is nothing but a modified version of Arduino made by me. It has 4 relays for output, and you can see all the basic necessaries that are required for Arduino, such as capacitors and linears for linear voltage regulation, port for 12 volt output, port for 12 volt output, port for 12 volt input, and another port for connecting sensors and motors to it. Okay, we are going to do this project on this platform. Here you can see that there is a chip that is 8MEGA328, same as Arduino, and it will be programmed with the help of Arduino, because here you can see that there is no this here you can see the small chip here, FTDI RL. There is no FTDI RL in this board. This chip is not there because it is at SMD component, and SMD component cannot be soldered easily, so we are going to use the Arduino board for programming of this machine, and the whole project will be going on this machine. But if you want, you can perform the exactly same performance or exactly same codes and exactly same motors with the help of your simple Arduino. For the betterment of the project, we are going to use simple modules, and at the let me tell you something. The whole project is going on this Arduino, and at the end of the course we will be doing it on this hardware. Is that clear? All the testing of individual parts, individual relays and other stuff will be going on this platform. We will be going to connect it. We will be going to running it simultaneously with another sensors and all that, and after the end of the syllabus we will be going to have an experiment on this board with the same program and everything. Okay, now let me tell you the block diagram of the system. Here is the block diagram. As you can see that we have input in the form of PIR sensor. Well, I would simply call it sensor because we are going to use different type of sensors. It is better for us to have a clear description of multiple type of sensor that we can be used in this project, not just a simple sensor such as PIR. We are going to use about 2 to 3 type of sensors so that we can use the system with any sensor that we want. It is an important project of Internet of Things because it is the basic foundation of Internet of Things. You can get a clear description about how to connect, you can get a clear description of how to get started with Internet of Things. And another things we will be discussing as we are discussing about the block diagram. Here you can see that the sensors, RFID and remote control will be the input to it, and the relays, lights and motor will be the output to it. The heavy motor will be controlled by a specially designed relay circuit by me. I will be giving you a block diagram of it to you. And the processing board, here you can see that we will have a special programmed watchdog timer at the end so that we can run the whole program for infinitely long time. Okay, the sensors we will be using are RFID and another sensors as we require. I will be telling you afterwards in the syllabus, and the RF remote. The most important thing is we are going to use all of them simultaneously. It is a special method of programming that I will be telling you so that we can use them simultaneously, and after that we are going to control motors or relays with the help of them, and even lights. Okay, this was the syllabus I have told you, and we are going to study this. Okay, if you have any question you can ask me, or else thanks for watching. Hello everyone and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial, after seeing the block diagram of the whole system, I want to discuss you about controlling a heavy motor with the help of a relay system. Here you can see that there are 2 relays. In the input of the relay, the center point are connected to the motor, while the 2 terminals which are shorted as follows are connected in parallel, such as the point 1 is connected to point 1 of the similar and point 2 is connected to point 2 of the similar, and each of the phase is taken to a positive and negative sign, that is showing that it is connected to a battery or a 12 volt power supply. Whenever the line switches, the value of this icon goes from here to here, and it will give a direction to the current, and the current will flow in one direction. And if we switch this relay, this will go from here to here, and it will give another direction for the motor, so it will rotate in reverse direction. Okay, let me show you an example here. First of all, open the Arduino, and we have connected the relay on the pin number 4 and 5. So first of all, I am going to call the pins. Say pin mode. Say pin number 4, pin number 5 as output. Okay, both the pins are set as output. Well, this was my design for the college project, but I found it very successful for running heavy motor even on the AC current. So it is a very practical design that I have shown you here, and you can get it in the PDF that I will be giving you in the beginning of the course. You can take it and you can make your own designs. Okay, let's just take a simple example. Say digitalwrite, it's a digital write. Give 2 times because we have 2 sources, and then give delay. My mistake, DELAY, delay, say 2000 millisecond. Okay, now I am going to copy everything and write it once again. Okay, in the empty brackets write 4 5. Same here, write 4 5. Say it high, LOW, low. In its reverse, say it low, and now say it high, so that the motor can rotate in both the directions. Connect the Arduino and upload the sketch. I am uploading it, just wait for a second. It's uploading. I think in the relay you can see the lights of the 2 relay that are. This is a relay module. You can buy it. It is a simple module, but it is very useful because it is only of about $2 or $3, but it can work in 4 relay, and I have connected them. You can see here in the same way that the wire I told you to connect it. The center points are taken to the motor while the alternates are connected to each other and given a power source. Here you can see the terminal. Let me check the motor wire once again. It's not 5, it's 3, so I am going to correct it. I am going to say it's 3, no problem. 3, again 3. Now I am going to upload it. It's uploading. You can see both the lights of the relay are glowing, and they are going lows and highs simultaneously. Okay, I am going to connect it to a power supply so that you can see the rotating of the motor. See that you can rotate the heavy motor in both the direction. You can also use heavy motors. You can also use heavy motors of high rating such as 24 volt because the relay have very high capacity of power. It can sense up to 120 volt and 10 ampere. That is very high, and it is required for big motors. So the relay connection can be used for big motor, but the precaution should be taken that the circuit has to be checked one time before connecting it to a heavy motor. Okay, this was about the relay. In the next tutorial we are going to connect the system with the help of a remote so that we can operate the motor in the both direction. The motor is an heavy voltage motor and it will be operated with the help of remote. Okay, let me give you a summary back to you. We have the relay diagram here. I have connected the center point to the motor. Here you can see here, and these are the built-in internal terminals that are connected like this in relays. These are the 2 external terminals that are used to given the circuit on and off value. So I have connected them in alternate values here, and one value selected here to positive volt and another value selected to ground. By this method, whenever the switch is gone of any relay switched on, it will change this value and give the motor one direction of rotation. It can be clockwise, and if another switch is on, then it will give the motor another value. It can be anti-clockwise. Well, this was the theory, and we have made a small program here. You can see that relay 1 is switched on, another is switched off, so it will rotate in one direction. Its vice versa is done so that the motor can be rotated in another direction, and it will rotate for 2 seconds. Let me show you once again. Here you can see that the rotation of a heavy motor here with the help of this relay method. Okay, this was the introduction here. Okay, if you have any question you can ask me, or else thanks for watching. Hello and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to run the heavy motor with the help of a remote control so that we can rotate the motor in the both the directions. Okay, I have connected a motor to the relay board that we have performed an experiment earlier, and I have connected two pins of the receiver. Here you can see that here is the receiver. I have connected two pins here, and there is a remote so that we can operate it. And the two pins give us two channels, one for turning on the relay and another is for turning on another relay, or you can say for another logical operation such as motor stopping or motor starting. Okay, let's just perform an experiment here. Open the Arduino. This was the code for the relay 1. Okay, let's just save it. You can download the code and you can make your own code as you like. Okay, go here and we are going to make another code for the program. We have connected the relay pins on pin number 3 and 4, so we are going to define the pin modes. Pin number 3, comma OUT PUT capital, terminate the line. Okay, go down, write PIN MODE pin mode. Okay, write the pin number 4 here. 4, comma output, terminate the line once again. We have connected two pins. Pin mode, say pin number 8 and 9 as input for the remote control. They are working on digital signals, so remember one thing, you have to convert them as digital input only. Say pin number 8 as input capital, terminate the line once again. Pin mode, say pin number 9 input, and for the input variable we need two variables to store the value. Go here and we are going to define int x is equal to 0 1 and int y is equal to 0, the second variable. Go down here, write dx is equal to digital, say x is equal to digital right, say 8, terminate the line. Say y is equal to digital right, say pin 9. Okay, now we have stored the value as x and y at digital right pin 8 and pin 9. Digital read, there is a mistake, it's read because we are going to perform the function of reading. Digital read. Okay, go down here, just write a simple condition. Say very simple condition, we are going to write if x is equal to 1, then say two curly braces, both one pin should be high and one pin should be low. Write digital write digital right pin number say 3 comma high high, and write digital right say pin number 4 comma low. Okay, that's what it, but we need another statement because we are using two pins here. Say if say y is equal to 1, we are going to turn down both the pins. Okay, we are going to write here digital right pin number 3 comma low, terminate the line. Again we are going to write digital right pin number 4 also low. Okay, just compile the experiment. We are giving it a name remote motor relay. you can download as I told you. Okay, just it's compiling, wait for a second for any technical errors, and it is saying right now there are no errors and it's compiling complete. Again we are going to upload it to the board. It's uploading, taking some time. It's successfully uploaded. Okay, check the value here. Everything is low, there is no serial monitor here. Connect the 12 volt supply here so that we can see the action in motor, and it's stopped. Whenever I press the value, you can see the motor is running. If I press another button, the motor will stop. Running, stop. Hello everyone and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to learn about using multiple sensors with Arduino. In this tutorial we are going to use a piezoelectric sensor as well as the remote control for giving multiple inputs for the Arduino board in using a program to get it output in the form of a heavy motor run. Okay, let's just begin it with the opening Arduino. Okay, we have opened Arduino. Open a new page. Okay, first of all we have to define the pins. Okay, I am going to define pin. In this I am connected pin number 3 as output and pin number 4 also as output for the relay. OUT PUT terminate the line. Now I have connected on pin number A0 as input. Pin A0, that is analog 1 pin, as input. This is an important experiment because we are going to use both the analog readings as well as the digital reading for performing an experiment. Okay. Pin mode say pin number I have connected it on pin number 9 as input. Okay, no problem. Again pin mode. You can use Sublime Text also, but it will require some compiling capacities. Even the Sublime Text have some mistakes that it cannot run almost all the programs of Arduino on it. So I am using Arduino IDE for programming. Okay, for that we need variables. We are declaring 3 variables. Int, because it will be storing the value of digital read. Int x is equal to 0. Now int y is equal to 0. It's a good habit to give them initial values so that it will not create any garbage. Int z is equal to 0. All 3 value x, y, z are giving value of 1, 2, x, y, z are giving the value 0. Okay, now we are going to call the variables. X is equal to digital read digital read. Say we are going to read it at pin number 8. Okay, no problem. X say y is equal to digital read pin number 9, pin number okay, we are here using the value 9 as input. Okay, for Z we are using analog read. Remember analog, this is important. READ. Say pin number capital A 0. And we need serial monitor to monitor everything that we have done. So we are calling serial.begin. It is very good habit to always call a serial monitor so that you can view your status live without causing an error. Okay, everything is correct. I think I should start it with if let's say x is equal to 1, yani x is equal means x is equal to high. Say digitalwrite digital write. I am going to say 3 is equal to high. 3 is high. Okay, now in next write I will be going write digital write WRITE. I am going to say 4 is equal to LOW low. Now that's clear. Okay, come down. There is something interesting going on here. It is saying that if Here remember one thing, the reading of analog is going from 0 to 1023. So I am going to say that if Z is equal to 102, Z is greater than, because in analog is a better practice to write something like this, say greater than 1000, then we will be getting value, say here, let me come here and I am going to write digital write both the pins low. I am going to say digital write 3, LOW low, again digital write I am going to say 4 also LOW. It's a good practice because analog pins take some time, so I am going to say greater than 1020 because it takes some time to go down and we cannot stop our motor for a long time because we want to do it quickly. Okay, let's just say at the last, before the last bracket, say serial.print, say serial.print, we are going to use variable x, so x is a good one. Okay, again write .print, we are going to use spaces, so I am giving 4 spaces, terminate the line, and in the last line we are going to use println because we want to terminate the line. println, we don't want a continuous line and we are using a z because it is storing the value of a0. Okay, now compile the program. We are giving its name multiple sensors simultaneous. Okay, we will save it later. I am just trying to compile it. So here is the first mistake, I forgot to put the parenthesis, putting the parenthesis. Now again compile, and it's compiling, taking some time. Now what is the problem here? I can see token expected, this is the token error, so I am going to give the correct token here. Again it's compiling, taking some time, no problem, let it compile, and the compilation is completed. So I am going to upload it to the board. Just wait here, and it's uploaded to the board. Okay, it's compiling, uploading, upload is successful. Okay, see here you can see the value of 0 as well as the analog value that is stored in Z. I am connecting it to power. Hello everyone and welcome to another tutorial of mastering Arduino from beginner to core advanced. In this tutorial we are going to talk about the RFID sensor. With the help of RFID sensor we are going to run a heavy motor. Well, how to do that? This has a simple procedure. Whenever with the help of RFID sensor we pass a key and compare a key with the pre-installed key with it. If the key matches, then the RFID signal will give an active signal to the Arduino board, and this active signal will processed by the Arduino board and send the active signal to the relay board. This relay board will process the signal and activate the relay in the direction such that the motor will start rotating. Okay, let's just do it. First of all, open the Arduino. Now here, first of all we have to call the RFID sensor. It's very simple, called serial.begin, say 9600. Okay, and for the pin modes, let's just check which pin we have connected on the Arduino board. It's 4 and it's pin number 5 and 6. So let's just call pin number 5 and 6 as output. 5, output. Okay, now pin number 6 as in output also. Okay, both the pins are set to output, and we have called the serial begin. Okay, come down. Now write the code simple. Say if, say the statement such as, say serial serial dot available available, give parenthesis, is greater than 0. It means it is passing some values. Then we need an integer or a string, so say string, s should be capital, string, say value, value will store the string value, say value is equal to serial serial dot read capital string, give to parenthesis, terminate the line. After that come down and give it a delay of say 50 millisecond. That will be enough because it works on very high speed. And say print ln and give the value. Okay, now terminate the line and before uploading it, remember one thing, that the pin number which is connected to Arduino board as pin number 0 should be removed, because it will not allow the program to upload it to the board. So I have disconnected it, you can see here. Okay, now upload the program to the board. It's uploading, wait for a second. Just wait for a second, it's uploading, it's compiling itself, and it's uploaded successfully. Okay, come down to the program and now connect the pin that is connected to EM18 to pin number 0 of Arduino. I am connecting it, wait for a second, and it's successfully connected. Now I am taking a RFID card here and putting it on the pin, let's say like this. It gives the value of this card. I am taking another card, it gives the value of another card. We are taking the value of card number, say card number 2, and copying it. We have copied it successfully. Okay, now for programming, again remove the pin that is connected to Arduino to EM18. Now inside say if the integer storing its value is equal to, give to upper columns and paste the value. This was the key. If the value is equal to the value of card number 1, then say the statement like this. You can say, give to curly braces, write digital, digital write, digital write, say pin number 5 is equal to high, terminate the line and say digital write, digital write pin number 6, low. Terminate the line. Okay, check it once again, and we need an else statement because we are taking only one value. So say else and give to curly braces, right here digital write, digital write, say pin number 5 is equal to low, and again pin number 6 should also be low. Digital write pin number 6, low. Now compile it. We have removed the pin from EM18. Okay, compiling it. It's compiling, wait for a second. Compilation is done successfully. Okay, now upload it to the board. It's, wait for a second, I have not uploaded it. I'm uploading it. Okay, I have done something interesting. I have connected a buzzer also, so that we can get something more realistic values. Okay, after uploading the code, come to the serial monitor, and it's not starting. Just wait for a second. Reconnect the Arduino. It's reconnecting. Now upload the program. It's uploading, and after uploading, wait for a second. Open the serial monitor. Now whenever I flip the card, I have not connected EM18. Wait for a second, it's connecting. Now do the scrolling and we get the value that is correct. So we get the sound from the relay, but if we want to see it in action, we have to connect it to a 12-volt supply. So I am connecting it. Okay, and you can see the motor is running. Again flipping another card, it's the same card. Now I am taking another card. Okay, you can see whenever I flip the another card, it's stopping, and whenever I flip the key card, it begin to start. You can see Again let's just see it in action. It's not working because of the wrong card, so take the right card and it starts. You can see whenever I take the second card it stops, and when I take the correct card it starts again, stops and begins. Now that was for the function, but if we want to insert a security feature in it, well, how can we do it? It's very simple. We have done previously an experiment on the piezoelectric sensor, so we can simply connect a piezoelectric sensor here with an analog read value. So I have connected it on pin number A0. So I am calling pin mode, say pin number analog 0 is given as input because it is reading the value. Okay, now come down here and give a value. First of all, we have to declare an integer for storing the value of analog read, say int an is equal to 0. Come down. Now come here, say first of all we have to set the value an is equal to analog read, say pin number A0. Okay, now come here and give it a parenthesis. If say A0 is say an is greater than the value, let's say 1020, then copy the same terms here. From here we are copying it. Okay, come down and paste here. It's saying that if the value is for the piezoelectric sensor are high, then the motor should stop. Okay, and we can also give a serial print here, say serial serial dot print ln, say it's giving some spaces, so no problem, we are giving 4 spaces here. Okay, now come down, say serial dot print ln. This line should be ln and this line should not be, so I am saying the value of an that should be showing on the screen. Okay, no problem. Compile it once for any error. It's saying a compiling error, that is A0. Now again compile it once again. It has been successfully compiled. Okay, upload, and it's uploading. Okay, let's just connect the pin number EM18 pin to the Arduino board. I'm connecting and it's successfully connected. Okay, now come to the COM port to see the value, and let's just flip the card. Just a minute, it's taking a garbage again. Now take the another card. Its value is giving high. Okay, now you can see that the value is 1023 greater than 1020, so the sensor had stopped. Again you can see that the motor is working. Now come here, see here there is a piezoelectric sensor. Whenever I press my finger on the piezoelectric sensor, the motor will stop. See here, the force was not adequate, so I will be trying it once again. Oh, there is a programming mistake, we have to correct it. Just wait for a second. Okay, first of all we need to put the code in the right area. We have selected the code here. First of all we have to cut it. We have cutted it successfully, and pasting it after the second bracket will be fine, because there is an bracket for the if statement also, and that is causing the error. This is the bracket for the if statement here, and there should be a bracket for void loop also. Let me check it. Come down, give a curly braces, and before that paste the code. Okay, compile it once. It's giving me an error that the declaration should be described before the token. No problem. Now again compile the sketch. It's successfully compiled. Okay, upload it to the board and connect, remove the pin. You have seen that the error because I have connected the pin. Once again I have to upload it. It's successfully uploaded. Okay, now connect the pin. and open the serial monitor. Come here, and we have to see the value like this randomly, so we can get the absolute values coming down here. Okay, the motor has been started and we are getting a value from the piezoelectric sensor, and I am pressing my finger. You can see that the value is greater than 1020, so the motor stopped. Once again, let us see it. Motor begins it rotating, and you can see the value of piezoelectric sensor. Now I am going to press my finger on the piezoelectric sensor once again, and it's stopped. Okay, you can see that this is a program for door safety. If someone enters in the door and by mistake comes in the way of the motor or the gateway, then the motor will stop automatically because it has pressed the piezoelectric sensor by its foot. So it will give a signal to the microcontroller that the motor should be stopped or an accident will occur. And we have connected a buzzer also, as I have told you earlier. So let's just try it with a buzzer. We are going to declare a function here. Let me come here and declare a function. First of all, we have to connect the pin, remove from the pin the EM18. We have disconnected it. Again, for the sake of experiment, we are going to make a function, and we are coming here. We are declaring it void, void say buzzer, buzzer, and give to parenthesis and to curly braces. Now come down. First of all, we have also to set the value for the buzzer. So let me check the pin number for the buzzer, and it is connected on pin number 11. Okay, come to the top, say pin mode, say pin number 11 as output. Okay, that is correct. Come down and set the value for the buzzer, such as we are doing a function that whenever the key is pressed, the buzzer is called. So we are doing it with the help of digital write, digital write, say 11 is equal to high, high, terminate the line. Again, say delay, let's say a delay of 1000 millisecond, terminate the line. Again, digital write, digital write 11 LOW, terminate the line, and say delay, say 1000 millisecond, and copy the code for a buzzer for ringing it 2 times. We are copying it, copied, and we are going to paste it. It is successfully pasted, and the value for the calling the function is BUZZER with parenthesis. Okay, come down here in the piezoelectric sensor. After reading that, we need here. So we are writing BUZZER with 2 parentheses and going to terminate the line. Okay, now just compile the code for any technical errors, and we found an error. C is saying the delay is not defined, and that is a typo, so we are correcting it. Again, compiling, it's saying the same error here again because I have copied the code, so I am correcting it and just compiling it once again. Well, there are no errors. Okay, uploading it to the board. It's uploading, wait for a second, and it's successfully uploaded. So first of all, I need to connect the EM18 pin here. Okay, I have taken the pin and successfully connected to EM18. It's connected. You can see. Now come here, open the terminal and take the card, and the motor begins to run. Now take your finger to the piezoelectric sensor and press it. The motor stopped, the sensor has been called the values, and the function has been called to give the value of 2 time rings. Let's do it once again. The motor started because of the card at EM18. Again, down, pressing the sensor. Let me do it once again. As before getting the value down to 1020, the sensor will continuously ring. It will be taking some time to get down because of the analog property of the piezoelectric sensor. So now it will not ring. See here. Okay, do it once again. I am going to take the EM18 for your experiment. You have taken EM18. The motor started. Going to press the sensor, and it's rang 2 times, and it will be taking some time to stop because of getting the lower value of the piezoelectric sensor. Or you can say that the foot has, until the foot has not been removed from the piezoelectric plate or in the pathway of the gate, till then the sensor will ring and the motor will stop, and once the foot is pressed then the sensor will stop and you can again use the key and start the gate. It will taking some time, okay, because the foot has been continuously pressed and it's stuck in a small loop. I am taking a sensor away, again giving a value high. Okay, you can see that the sensor has been taken away. Now take the card once again, swipe it. The machine has been started. Come here, press the foot and the machine is stopped. Okay, let's just recall what we have learned here. We have learned here to control the motor with the help of a RFID card, a relay control circuit for heavy running motors, a heavy motor and a piezoelectric sensor, as well as a buzzer for the circuitry to get us a reliable value when there is a security issue is occurring. First of all, let's just see the code here. We have called the code such that we have taken two values, an integer value for analog read and string value for the reading the strings from the EM18 sensor, and in here we have called serial.begin for displaying the values, and down here we have called the 5-6 pin for the relay and A0 for input as for the piezoelectric sensor, and pin number 11 for the buzzer. Come down here, we have made a function which is saying that the buzzer should ring 2 times and taken the value of BZZER. You can make it buzzer void, VOID, because we are not taking anything, we are not taking a value from the buzzer. Okay, come down here, we have taken analog read A0 as the integer AN, and in down here we have called the value set as serial read string with 2 parentheses and terminating the line, and after that we are printing the value of the key. Again, come down here, if the value is matched to a key string of the card which we have opened with the help of Arduino and we have copied the key string here, then the motor should run, or if the card is wrong, then the motor should stop. If anyone presses the buzzer or anyone presses the piezoelectric sensor, the value will rise above 1023, about 1020 for our case. So for that case the motor will stop and the buzzer function will be called, which will be ringing for 2 times, and if the foot is pressed continuously, then the buzzer will ring for infinitely long time until the foot has been removed, and after that the buzzer will ring 2 times and the motor will be released, and again using the card you can start the motor. Okay, this was the theory here, and we have set the value so that we can read the value of the analog function also of the piezoelectric sensor. Okay, we are going to perform the experiment once again. Okay, we have taken here, and I am going to use the wrong card this time so that we can get an idea. Let me open my COM port, or you can say serial monitor is also called COM port. We are taking the wrong card and no value is occurring. When we are taking the correct card and the motor starts, you can see the motor is rotating up. Now I am going to press my finger on the piezoelectric sensor and it's taking 2 rings and it stopped. Okay, this was the main theory and the code explanation for the Arduino using a RFID card to open a heavy motor, and this was the main conclusion for the using RFID cards for gate automation or heavy motor automation. This can be used as the foundation for Internet of Things. If you have any question, you can ask me. You can find the code at the beginning of the module, and thanks for watching.